So welcome everyone to the first lecture of AI Context Engineering Bootcamp, or more specifically speaking, LLM Context Engineering Bootcamp. So I know that the people who are attending this course are from many different backgrounds. I had received several emails from product managers, engineers, people who are students and industry professionals. So if you can just briefly mention in the chat, like, what do you do? Are you a engineer? What type of engineering? Or are you a student? Or um, what do you do right now? If you can just briefly mention that in the chat, I think that will set a good idea about what type of population exists here in this bootcamp. And also one more thing is, many of you are from different parts of the world. So for some people who had messaged me earlier that the time zone difference will make it difficult for them to attend the live lecture, but they will be able to go through the recording. Okay, I can see many different types of people who have commented. Many of them are students, many of them are engineers, software engineers. But I also know that several of them are AI product managers and traditional product managers. So I hope all of you are having a good time. So I'll just first set the reason why we decided to conduct this bootcamp, and then I'll first discuss a little bit about the logistics, what we will be doing in the upcoming lectures. When exactly do we meet? What all topics do we cover? And each lecture, how does it look like, etc. So I want to ask a question. How many of you have ever used any coding agents like Codex or Cloud Code or any other, maybe Copilot, or internally there are other softwares that teams use, or Cursor, anything. So you might have noticed that especially in the last 2 months, the way that these tools have exploded in its ability to actually do things, actually do very difficult things, it's so mind blowing. So especially we at Visuara, we spend, in my opinion, maybe 90% of our time these days on Cloud Code with Opus 4.6. And it really helps that um, the same account that we have. So we have a $200 per month subscription, which can be used by multiple people. But as individuals, that will be difficult. But the point that I'm saying is, the way these tools have become today is such that I think many people who are working traditionally in software roles or in traditional engineering roles, the traditional role is going to become obsolete, in my opinion, and something new is going to emerge. And we have been spending a lot of time building various tools in the last few months that I realized that the most of the amount of time that I spend is in figuring out how can I give my input in the best possible way to the large language model, so that I can get the best possible output. So first and foremost, I want to share an article with you. This was an article that exploded in popularity in the last, I think, 3 or 4 weeks. This is by Matt Schumer, and this already has around 85 million impressions. I will share the link to this article. Although it looks like a big article, it is actually incredibly well written, and I strongly believe that every single one in this call should read this article. So I'm just sharing the link in the chat. Just save it for yourself and you can read it later. I think it's like a 10-15ish minutes read. It's really, really beautifully written, and I think whatever has been mentioned in this article about the changes that have happened in AI from last year or last to last year to now is humongous. So if people are not really building in this space, you will not notice the difference, because you may not notice the difference between when you're using ChatGPT in the normal chat mode versus when you are actually using coding agents to build stuff. So, today itself, when you have a chance, please read through this article. I think it will open your eye. Now, let me first ask you a question. What do you understand about the difference between context and prompting? Because when you are prompting an LLM, also you are providing an input, right? Versus when you are talking about context, it also includes prompting, right? So in your opinion, what is the difference? Just in 1 or 2 sentences, what makes context a much more complex word and much more a word that requires much more attention? The main difference is that prompt is the part which user gives, right? User is inputting something, but then the large language model has access to so many more things apart from what the user gives, right? So as someone has mentioned, context equal to prompt plus memory plus external knowledge base. Yes, it's kind of correct. There are more elements, of course, but context is much more wider. It has got much more to do with than just the user. And the engineer who is working with an LLM should know how to set the context to the large language model in such a way that you get a very good and desired output. So for those of you who don't know me, who are attending our bootcamps for the first time, my name is Dr. Sridhar Panat. I am a PhD from MIT from 2017 to 2022. Before that, I did my dual degree from IIT Madras. And since 2022, I have been working with Dr. Raj and Dr. Rajat as part of Team Vijwara. Many of you might know us through LinkedIn or YouTube and places like that. If you don't know us yet, this is the team. So the structure of this bootcamp is in the following way. There will be a total of 8 sessions, and the first 8 sessions will be conducted by me. And this is the rough syllabus. So today we'll be looking at the mental model behind what exactly constitutes a context which LLM ingests. What are the 6 core elements of the context? So with this, we will discuss today. And then following today, tomorrow, we will discuss system prompts which go into the context, RAG pipeline. So day 3 will be dedicated to RAG. Day 4 will be primarily dedicated to MCP. And then day 5 will be, some of you might have heard or read that Cloud Code is really good at compressing the context or compacting the context. It's also really good at figuring out when to clear the context and when to compact the context. So that we will discuss on day 5. On day 6, we will discuss memory, and then some patterns that we have to follow in production and how to evaluate the merit or how good the context is. In all these sessions, I will show you the structure, what exactly will we do in terms of foundational knowledge or theory, and in terms of hands-on exercises, what we will be doing, that I will show you in a moment. Then my part will end with session 8, which will be a build project. And I have several 2 or 3 different projects in my mind. I'll be picking one of them, and the details of the project I will reveal towards the second half of this bootcamp. So these 8 sessions will be conducted from Monday to Thursday. So this week, the first 4 sessions will happen from today, which is Monday to Thursday at 9:30 a.m. By default, I have defined the lecture duration to be 1 hour, but I can imagine that several lectures can go above 1 hour. Then the next 4 sessions, session 5 to 8, will happen next week, again from Monday to Thursday, same time, 9:30 a.m. IST. And then session 9, so session 8, there is a small thing which I'm thinking. If the mega project that I am thinking is becoming a little bit more complex than what I'm expecting right now, I may need to push the session 8 to one of the weekends, because I might need more time with you, not on a weekday, but on a weekend. But if nothing changes, session 8 will be next week, Thursday. Then session 9 and session 10 will be conducted by Dr. Raj and Dr. Rajat. And both of these will be mega projects where you will be purely building. Nothing will be taught, but you will be building along with them. The exact date and time of these sessions will be updated later next week. So this is roughly how it looks like. So at the end of this program, what I'm hoping is for you to take away the art of thinking about the context that we provide to large language models. And hopefully you should also be figuring out how to build agents for your own purposes. So Saurav has asked about WhatsApp groups. So I have started a Discord server. I don't personally use WhatsApp very frequently, but I have started a Discord server, and the link to the Discord server has been posted in the 2 courses, one for the engineer plan and one for industry professional plan. There is a question, would session and 9 and 10 be 3-hour sessions on the weekend? So yes, so what I will discuss this with Raj and Rajat regarding the timing, but you can expect it to be 3-hour sessions. And if it is a 3-hour session, most likely it will be on a weekend rather than on a weekday. Session 8 also most likely will go for easily about 2 hours. So that's the only reason why I'm thinking, should I push it to weekend or not? But that I will confirm later part of next week. Yes, in the capstone project, we are expecting you to build along with us, because you should also have the experience of building things for yourself, right? Everyone should be able to participate in the capstone project because it will be through the lecture only, but the content associated with it will be available to engineering plan students and industry professional plan students. This is the rough format of each session. So I have planned 3 things in every session. First is foundations or theory, which we will go through. And this part will most likely be kind of, you will find it easy, because context engineering is not strictly physics, right? Context engineering is more about the best practices that have evolved as a result of communities usage, as a result of recommendations from different big companies like Anthropic, Google, OpenAI, etc. So the foundations or theory are more like, often you may feel like, oh, these are thumb rules. It can go either way also, right? There will be a quiz session where I will walk you through certain multiple choice questions. My goal with this quiz session is to make sure that all of you are registering the things that we discuss in the lecture, so that you store it in your long-term memory. The third part, which will be part of each session, is hands-on implementation. In hands-on implementation, I have designed 2 aspects. One is pure Python code. So for example, in today's session, I have a Python code which can be easily executed in Google Colab, but you will have to give your API keys and few other things. I will discuss that in a moment. But before the bootcamp started, several students had messaged me and industry professionals had messaged me saying they are not very proficient with Python. So will they be able to follow in the lecture? So what I have also created is these interactive web notebooks, which will cover the exact same concept that the Google Colab is covering. So during the lecture, I will be going through this interactive notebook so that everyone should be able to visualize what is going on in the exercise that we are doing. So everyone, regardless of your coding experience, whether you're good at coding or whether you're bad at coding, you should feel comfortable. But this Google Colab notebook, I'll be sharing immediately after each session so that you can implement the exact same thing which we implement during the lecture through these interactive notebooks in Google Colab also. The only difference is that in this, some parts of the code are abstracted away. It happens in the background, not in the foreground. Now, a few things about the large language models, the API keys. Okay. So before coming to the API keys, these are the things, the frameworks which we will discuss. And these frameworks are not like it came out of some textbook. I have gathered these frameworks from many different sources. Andre Karpathy has pioneered a lot of ideas that we will discuss in this course. Founder and CEO of LangChain, founder and CEO of Shopify. Then many other community members have proposed very different workflows that have become famous. Recently, OpenClaw has become one of the fastest growing GitHub repositories in the whole world. How many of you have tried OpenClaw, by the way? If not on your personal computer, at least in some other isolated computer. Have you tried building a personalized agent for yourself using OpenClaw? At least you should know about OpenClaw. It has taken the world by storm, and the way it works is also way the most of these tools work is by providing very good, very rich context to large language models. Yes, scared to use it. Of course, you should be scared to use, at least for the time being, because it's not very, you don't know what it's going to do if you are exposing all your personal data to an agent that sits in your personal computer. Because of that reason, although I have used OpenClaw in our other machines at our company, I have not installed it personally on my laptop as well. So today we will discuss about LLM OS analogy, which Karpathy had discussed in one of his talks that he delivered at Y Combinator. This was a few months ago. That talk had so many views. I will share the link with you. Then we will discuss in the next to next lecture the write, select, compress, isolate framework. Anthropic has another idea called write altitude. When you are constructing system prompt, how detailed should you be or how abstract you should be? So there is a write altitude principle. Then there are ideas like product requirements prompt. When you are building a product with pure AI agentic coding, how exactly do you give your prompt so that the output is something which you expect? So last week I had released one lecture video on our YouTube channel. It was titled as building like an agent for accumulating news, AI news from different websites. So I forgot the exact title of the video, but basically what I'm doing there is like I'm building an AI agent which will automatically look at different sources on the internet. So it will look at GitHub, it will look at Archive, it will look at Hugging Face, it will look at Reddit, various subreddits, x.com, LinkedIn, and then it will aggregate all the hottest topics that are happening at that point, and it will give it for me so that instead of me having to go through a lot of noise to read about things that are happening in the AI, LLM agent space on a daily basis, I just need to go to my website and there I can see everything in one place. So that I'm building. Almost 70% of the building is done. So just check our YouTube channel for that. So there I talk about a little bit of details of how to set up Claude Code workflow. But there also you will come across several different concepts like RAG, or storing things in the persistent memory, system prompts in the form of cloud.md files, which we will also be discussing in this bootcamp. And then React framework, reasoning and acting framework, which has become very popular since I think 2025, early part of 2025. And then budgeting the tokens, because your token, the context window is limited and finite. And also talking about what are the different types of memories you have when you are using LLM for a large number of iterations or large number of back and forth conversations. So the prerequisites are the following. The way I have constructed this website and also the Google Colab notebook is such that it works for either of the three API keys, Anthropic, OpenAI, or Google. Somebody asked whether we can also work with Olama or any other API keys. I can change the website, this interactive website and a Google Colab notebook in such a way that it also works for other APIs, because the way in which API keys are used in the function calling is different for each of these three. It's slightly different. So I need to take that difference into account to make it workable. But by default, if you have either of these three API keys, it should work for you. I personally don't have an Anthropic API key, although I use Cloud Code. I don't have an API key. I only work with OpenAI or Gemini API key. So just make sure that right now, if you want to go through this exercise once we reach that part in today's lecture, just make sure that right now you go ahead and make sure that you have either of these three API keys. Okay. So for Anthropic, if you are taking API key, you can just recharge for a minimum amount of credits, $5. That is fine. That can be the case with any of these. And to get the API key, just search, if you're looking at OpenAI API key, just search that on Google, follow the links, and it's very kind of straightforward process. But this API key, one of these API keys will be necessary for all the lectures in this series. So the sooner you get it, the better. The other things are a little bit optional. You having a little bit of experience calling APIs or HTTP requests, having a little bit of experience working with JSON file formats, those will be okay. I mean, it'll be good to have, but even if you don't have any experience working on JSON files or HTTP requests, etc., it's fine. I'm expecting most of you to have some level of proficiency in Python. When I say proficiency, I don't mean to say years of experience. I mostly mean to say you have used Python in some capacity at some point in your life. And make sure that you have Python installed on your computer also, because every single exercise we will not be conducting on Google Colab. The reason why I have created this Google Colab document is because I figured that many of you might not have all these things right now. So I thought Colab is the easiest way to share the code and help you execute the code in the fastest way. All right. So let's first discuss about the difference between prompt engineering and context engineering. So prompt engineering is basically very simple. You are the user. Let's say you are going to chat.openai.com, which is the ChatGPT website. And there you are providing the prompt to an LLM. Let's say you want to build a code base for implementing some deep learning pipeline. Let's say you want to implement vision transformer using a Google Colab code. You will give some prompt like, I am so-and-so. I am a teacher who is trying to teach vision transformer. I would like to have a, so you will mention who are you, what should the LLM act as, and then to what level of detail should the code be? Should it be extremely long? Should it have comments or should it not have comments? Because if you are building the code for teaching someone, the code should have sufficient number of comments and markdowns so that people who are going through it, people who are seeing it for the first time can understand. But if you are simply using it for implementation, you probably don't care too much about the code being really good or easy to read. You want it to work. So the prompt which you give to the user will include the instruction, right? It will probably include, in some cases, trial and error or some examples which you give. Okay, there is one question: which one of these API keys not only efficient but also affordable? So for most of the exercises that we will do today, the cost you will incur per API call will be less than maybe $0.5. Not per API call, cost per exercise will be less than $0.5, which is like what, 40, 45 rupees, right? So throughout the bootcamp, any API keys with maybe $10 to $15 credit will be more than enough for you, for most of you, I think. Then when you craft the prompts, right, are you looking at one shot success or are you looking at success in few shots? So one shot meaning you give one set of instruction and you want the LLM to give you a successful output in one shot. So if it is in one shot, you give more instructions, right? You say, hey, here is an example of one such code I had created earlier. Provide me something like this. So in prompt engineering, basically input is basically a text string. Your goal is to craft those text, which as a user, you should craft it in such a way that it helps the LLM produce the best possible output by knowing your intent. You cannot call the large language model multiple times at once. You can only make one API call at a time because you are going to the chat, you are asking a question, which means you are making one API call with the inputs and you can't do multiple API calls. And this is something that is good for a beginner, but as an engineer, you should be moving away from prompt engineering. You should be moving to context engineering where you have a lot more control. So what are some of the elements that form as part of context engineering? One is, of course, which I have not explicitly mentioned here, is user input. So the user input part will, of course, be there just like normal prompt engineering into the context engineering, in context engineering also. But beyond that, sometimes you will have to retrieve documents. So I will tell you my reason why I decided to start this bootcamp, the specific reason. So I'm trying to build an AI agent which will help me process many of my emails. So there are roughly maybe 200 plus emails being received every day. And if I have to respond to the emails in a timely manner, I have to spend at least 2.5 to 3 hours per day just on the inbox. And this is a major time sink because then I won't have time to work on anything else. So all of us are planning to build an email tool, email reply agent, which can be as good as us. So it's very different when the sort of emails that you receive are highly technical, right? You might also notice this, like if you want to build an AI agent to, let's say, reply in your work Slack or in your work Discord or whatever platform you're using, it cannot be a generic, just an AI chatbot. It should have a lot of background information about your project, who you are, what you do, etc. So if you were building, let's say you were running the company Visuara, okay, and you are getting bunch of emails about different programs or different courses, or maybe many companies want to partner with you. What all elements would you consider here? And the goal is I want to build a chatbot, and this chatbot should basically craft responses to the incoming emails. And me as a user, the only thing that I have to do is tick, which is approve the crafted response or decline, or ask it to regenerate. So regenerate the response, one of these three. So with one click, I should be able to manage responses. So if you were building something like this, what are the different aspects that you will consider? So one question is, why don't we use OpenClaw? It's a great question. The only thing is OpenClaw I am still not confident enough to use OpenClaw for our internal tools. I can use it if none of our emails or those things are not exposed. But even if we use OpenClaw, what are the different knowledge bases that you should have? So let's think about this, right? If you have a website, if you are a company selling a product, or if you are, let's say, an educational organization like us with bunch of courses, so you need a lot of details about everything that is there in our website backend, correct? And this, because many times the questions might be anchored around, hey, when does the context engineering class start? Will Python be required? So there are a lot of questions surrounding around courses. And let's say on our website, let's say we have 5 dozen courses. A lot of courses are there. So this info we need. What is the other info? What else would you need in the context? So another thing which you would need is your email history. Why do we need the email history? Because if I consider the email history from last 1 year or last 6 months, there is a certain way in which I respond. My way of responding is to some questions I'm very concise. It's very short reply, but to some questions that require longer responses, it's a longer email. And that is my personal preference. So somehow from my email history, these personal preferences should be learned, right? Then there is one more thing. So this email history, somehow website information should be concisely mentioned in some sort of metadata. Because if there are, let's say, 100 courses, I cannot load the 100 course related information into my context because my context is limited, by the way, which we will come to in a moment. So I have to have some metadata saying there are these many courses, this is the link to this course, something where metadata is some smaller version of the original data. Then email history, if I'm looking at the emails from the last 1 year, maybe there are 10,000 threads of responses, threads where there are at least one response. So this email history, I cannot entirely load into my context. That also will again kill the context. So I have to have a concise form of email history. But there is one more thing. One more thing is recency. So, or we can call it as recency bias. Basically, what this means is the last 20 emails or last 30 emails that I have sent contains the latest information about whatever we are doing, right? Because the email from 1 year back might have some outdated information, but email from 3 weeks ago will have more recent and more correct information. So recent, let's say 20 emails have very high value. What else do we need? Some things could be like rules. Rules are something like if let's say some course has 2 different links. One is like a link with the course name, one is like the link with the course ID. Always give the user the link with the course name because course ID based link is let's say confusing. So there are a bunch of rules that you might want to say, or some rules are, yeah, exactly, guardrails as Vishnu has said, or some rules could be something like the last date for any particular bootcamp is maybe 1 or 2 days after it starts. After that, it has to close. So if somebody asks, that should be the response. So there are, let's say, 10 different rules which are globally applied across all the conversations. On top of all of this, we have to have some feedback system such that if I deploy this application in the production, if the email response that is crafted by the tool is not very good, I should be able to say, hey, this is not good. I'm rating this 1 out of 5. Then I should also be able to give a reason why did I rate it 1 out of 5. Another way for giving feedback is, let's say the email agent crafted an email, but then I did not like the second last sentence in this email. So that alone I edited. So now from this information, if the email I have slightly edited in this section, there is something for the LLM to learn from this, right? Not in terms of fine tuning. There is something to be provided in the context based on this change that I made. So some feedback should be there. And also some RAG should be there, retrieval augmented generation. Why is that? Because if the person who is emailing is asking about one specific program, then that specific program's detail is somewhere deep buried inside our website details. But first, a RAG pipeline should fetch, let's say, top 3 courses that are relevant for this student or whoever is asking. Then it should re-rank. So it may fetch top 10 or top 15, then it will re-rank and then provide the top 3 course related details into the context. Now, when I keep saying context, what exactly do we mean? It simply means you have a large language model. You know that large language model takes text input, right? The text is converted into tokens and the tokens pass through the LLM. And then ultimately it is about next token prediction, and it will predict a sequence of tokens, which are the output from the LLM. So when I say context, in its crudest form, context is simply what is being filled in these tokens that are part of the large language model input. So then the question is, how do I fit my website metadata? How do I fit my email history in a concise way? How do I fit my 20 emails? How do I fit my RAG output? How do I fit my rules and the feedback, everything into this context window? Along with what? I'm missing one thing here, one important thing. What else is missing right now into the context? The email itself, the incoming email to which I have to respond. So that which is technically the user input. So that email also should fit into the context. So now all these things should fit into the context. Now, if you have ever tried to build a tool like this or a Slack chat bot for yourself, you will realize that it is not at all easy to make it respond exactly the way you will be responding usually. It's not at all easy. Sometimes it will hallucinate. Sometimes it will be over enthusiastic unnecessarily. Sometimes it will not provide enough information as much as you would have provided if you were responding. So it's not at all easy. And we have been spending tremendous amount of time perfecting this so much so that we can also release it as a product where anyone, if you are running a company and if you want to deploy an email responding agent, you should be able to do it with a few mouse clicks and a few data sharing of a little bit of data. So while figuring this out, I also realized that it is very hard to understand how to set up the context for the large language model to get an output which you are expecting. So that is one of the reasons why this bootcamp came into existence. Okay, there is a question. I think email is an input and website top courses are the real context. LLM will respond on input email based on the context. So LLM will respond based on the entire context. In the entire context, the incoming email is one of the things, is one of the inputs. But the rest of the things are output from your RAG, the email history in this specific case, the metadata from the website, the specific rules, the specific feedback. And you should notice one more thing. This feedback, as I am keeping on using the tool, this feedback will keep on growing. Because what if I give 10,000 feedback over the course of 6 months to this tool? I cannot fetch 10,000 feedbacks and expect it to fit into my context, because that will again cause LLM context to become useless, right? So these are some of the things that we should actually engineer properly if you have to get some tool which looks simple to actually work. So you might have noticed Gemini giving some example suggestions for replies, right? In emails, you might have noticed it. Gemini, it has some context, but it's only useful, like in my experience, 1/5 of the times that response crafted by Gemini is useful, but 80% of the times it's not useful. So that was another reason why we decided we should build our own internal tool. Memory is needed for this kind of application. Yes, of course, memory is needed. Do we also need skills in the context engineering? So David, I hope you are asking about the skill.md files. Is that what you're asking about? Yeah, we will need that also. It's one of the parts of context engineering. If feedback added for each interaction, or is it in batch? So currently I'm adding feedback for every single interaction, because my goal is to make the tool better and better with use. Okay, my question is to LLM. We are sending most junk data. How can we reduce to get precise answers to reduce the token limit error? Yes. So we will be discussing that. Very good question. Now let's come back to our main discussion. So the user input is just one of the things, meaning from our email example, the incoming email is just one of the items that goes into the context. There are many other things that go into the context. RAG, in our example, RAG retrieval is the retrieval of the, let's say, course related data. System prompt will include so many things about my own writing preferences, the style with which the email has to be crafted, who is the user. So in tomorrow's lecture, we will go into detail how the system prompt, which famously is stored in cloud.md files, especially for those who are using Cloud Code, CLAUDE, cloud.md files. So we will discuss tomorrow how system prompt exactly looks. Then there are a bunch of tools. So in fact, I have built an MCP, Model Context Protocol server, which again we will discuss in fourth lecture in detail, for fetching information from our backend server. So just with natural language, I should be able to fetch information. I should be able to process the information. And this is very different from making an API call, right? So currently we are also using MCP. There is a memory. There are two types of memories, persistent memory and short-term memory, in which the information regarding latest emails and last 1 year worth of emails metadata is stored. There is conversation history, because if I'm, let's say, having a thread with somebody, that thread has a history, right? That person has already talked about a lot of things with me. I should not chat to my LLM as if it's a new conversation, or the LLM should not respond as if it's a new conversation. And then, of course, guardrails, dynamic examples, which is a subsection of RAG, will be part of it. So this is just one example. In your company, you might be building something completely different. But in general, agents are taking off in such a big way, because right now the way the context is constructed by default in OpenClaw or in Cloud Code or in many other platforms like Lovable, you might have used Lovable to build a website front end. It's amazing. With very minimum input, Lovable can create very beautiful output. And Lovable is also at the end of the day using one of the LLMs. It's not like it's having its own LLM, but the context that is set for some sort of full stack or front end development in Lovable is in such a good way that even with a very small user input, it's able to produce such a very good output. So that is in one word what we can say. In prompt engineering, as a user, you are thinking in one dimensions, but whereas in context engineering, you are thinking about multiple different dimensions. And we will, in this day one context lab exercise, we will figure out the importance of each of the 6 elements of the context. So in 2023, okay, what separates our builder application from OpenClaw? OpenClaw also does the same, right? Yes, Mohammed, I hope you are asking about the email news aggregator tool which I had built, right? Or are you asking about something else? Are you asking about email response agent? If you're talking about the email responding agent, the main difference is that you need to construct some OpenClaw also can in effect do it, because it's an agent. You can have memory for the agent. It can have access to your Gmail, and it can do everything. But then you should know what all things are you going to provide to its context. You can't provide a 10 megabyte JSON file. Usually JSON files are very small in size, like it's in kilobytes, right? But when I downloaded the past 1 year worth of emails, each month, so 1 month email was roughly anywhere between 10 to 20 megabytes, the JSON file consisting of the data. Like that, if I have around 13 months, then that is anywhere between maybe 150 to 250 megabytes of data. Now imagine the size of the length of those JSON files. If pure text is contributing to 250 megabytes of data, it's humongous. It cannot fit in the context. So we have to have our own engineering to figure out how best can we fit all of this data, or what from this data should be fit into the context of the large language model to provide you the output, irrespective of whether you're using Cloud OpenClaw, or whether you're using Cloud Code to build your own application. So in 2023, you might have heard a lot about people talking about prompt engineering. That was the buzzword at that time. Then Andre Karpathy coined this term vibe coding in just one tweet, and then everybody started talking about vibe coding. And then everyone is now talking about context engineering, and especially now that the AI agents, especially coding agents, are becoming so good, I really, really urge you, if you have not, to use Cloud Code with Opus 4.6. Has anyone tried this combination, Cloud Code with Opus 4.6? So this will not work in the free plan of Anthropic. You will have to at least go with the $20 per month plan. But this is my honest feeling. Sooner or later, everyone is going to switch to one of these, either this or Codex or one of the coding agents. The sooner you do it, the earlier you will move ahead of the rest of the people, simply because it is so good. If you are a student, you should figure out from your institution whether you can get a discount. If you are a working professional, I think this money you should take from your pocket if your organization is not giving it, and it's completely worth it. It will save you. If I had access to this in my PhD, 50% of the time was gone in analysis of experimental data, writing the papers, making the figures. Doing the actual physical experiment was the other 50%. I now feel like if I had access to this back in 2021 or 22, I would have saved at least 2 years of my time. I'm being very honest here. So you should definitely try Opus 4.6 plus Cloud Code at least once in your sometime in the upcoming weeks. I think you will never ever code yourself anymore, like from scratch. So this can you tell me what's the difference between vibe coding and context engineering? Is it kind of the same, or is there some subtle difference? So in vibe coding, the way in which you work is to give you a good example is, if you want to build a website front end, and if you are using Lovable, you give your prompts, right, and it will produce some output. You may or may not like it. You will do it again, and you will give again feedback, and then you're hoping that after a few shots, the output you will get as a result of vibe coding is something which you will like. So you're not coding explicitly as a programmer, but you are more like sharing the instructions to the large language model based on what you see as from its output. In context engineering, however, maybe the vibing part is there in the user instructions. As a user, when you're giving prompts, yes, maybe you're probably doing it based on your feelings, etc. But most of the other 5 elements of the context engineering, it's pure engineering in the sense that you should have a RAG system in place that has very low latency, and it should be very, its metrics should be in such a way that whatever it fetches should be relevant to the context. You should have tools or MCP which are relevant to that particular task which you are trying to do. So in our case, the MCP should give us access to the entire Firebase storage or Firestore database. And if there are persistent memory and if there are short-term memory, that memory, we should decide what goes into each of those memories, what is persistent and what is short-term. We should explicitly decide those things. You cannot vibe code. You can try vibe coding the markdown files, which are there as part of this, which we will discuss a bit later, but it will not be as good as you explicitly engineering it, right? So in this talk, I will share the link. This was, I think, 2025 towards the end. Andre Karpathy delivered this talk at Y Combinator. Former director. This is a very nice talk. I think you will get inspired if you listen to this. Just 40 minutes. I'm just sharing the link in the chat. So in this talk, he gives an analogy between, he has talked about it in many different places also. You can follow him on x.com. So I don't think the link got shared. 1 second. You can see the link in the chat, right? I think earlier I put it in waiting room. So Andre Karpathy has coined this term where if you look at an operating system versus large language model, different components of large language model can be compared to different components of an operating system. So a CPU, which is the processing unit of an operating system, can be compared to the LLM model itself, GPT or Opus 4.6 or whatever you're using. Then let's look at the other parts, okay? So the agents which you build, which can execute tasks, are like various applications. So on Mac, if I'm using, let's say, Zoom, or if I'm using some other application for taking notes, this Miro Notes, there is a Mac application for it. Those are different agents which can perform one single task. Then the way I make system calls to those applications are similar to either API calls or like tool calls through MCP, Model Context Protocol. So I don't know if how many of you have heard of the term or are familiar with the term Model Context Protocol. So bear with me until we reach that lecture. For now, just understand that Model Context Protocol is the standardized way in which large language models can interact with various tools or softwares, for example. So if you want to connect your Slack with ChatGPT, you can use Slack MCP. And then to ChatGPT, you can directly ask, hey, look at the channels where I am yet to respond, right? So this is a natural language command. And that command, using that command, using MCP, LLM can access different channels in your Slack. And then from there, it can get details. And that details can be passed into ChatGPT, which it will process and give you a natural language response. And then file system, which are stored in your computer, which will be loaded into your RAM during the processing and which will be processed by the central processing unit, can be considered as an equivalent of vector databases which are used in RAG. And finally, context window is compared to RAM. Can anyone tell me why is that? Why is context window equal to or equivalent to RAM in an operating system analogy? So two things are there. One is RAM is not a permanent memory. Second, it's not an unlimited memory. Both constraints are there, just like context window. So context window of top large language models these days are like on the order of million tokens. But those million tokens will not remain always the same. Those tokens will keep changing. Plus, that million is finite. The moment you load certain number of documents, your context is done. So let's try to discuss that. How many words do you think make up one token? One token equal to how many words in English language? So I can see many different responses. One word. So the approximate answer is one token is equal to 3/4 of a word. Approximately. I mean, it's not exact, but roughly 0.75 words. Okay. Now, by that logic, if we have a context window whose size is, let's say, 2 million tokens, how many words or how many pages worth of data can we fit here? This can be easily calculated. So if 2 million, first of all, in one page, how many words are there approximately in one page of a book? Approximately how many words are there? You can say roughly like maybe 300 words, depending on the font size. Because a big paragraph or like a short paragraph is around 100 to 150 words. The abstract of one of my papers during PhD was 150 words. So 300 is like two such paragraphs. Now, depending on the font size, some of them will be 500, but let's keep it as 300. So one page is 300 words. Okay. Now, 300 words is equal to how many tokens? Or let's do one thing. One page is equal to 300 words. So 2 million tokens is equal to how many words? One token was 3/4 of a word, which means 2 million token is 2 million multiplied by 3/4 words, right? So this is 6/4, roughly 1.5 million words, correct? Now 1.5 million words will be roughly how many pages? It will be 1.5 million divided by 300, right? Which is equal to 1.5, or I can say 15 multiplied by 10 to the power of 5 divided by 3 multiplied by 10 to the power of 2, which is equal to 5 multiplied by 10 to the power of 3, which is, am I correct? 5 multiplied by 10 to the power of 3, which is 5K pages roughly. I hope I haven't made any silly calculation mistake. But just look at this. Now, this is the context window size of the large language models that you have around these days. It can fit 5,000 pages. There are some models which even have like 19 million tokens, which means it can fit roughly 10 times this, around 50K pages. So then a natural question that can come is, if the context window size is so big in large language models, why do we care about engineering the context? Because how often do you sort of use a 5K page document in your context? Why should you care about engineering the context? Okay, many people are saying cost. Why do you say cost? Can you just elaborate? Okay, I understand cost, but cost is the cost of usage of large language models are proportional to consumption of tokens, right? So number one issue is cost. Equally important is one more issue, which is, yes, latency could be another issue, but even more important issue is something called as context rot. So your context quality will be degrading as the number of tokens in the context increase. So to say that context engineering is, let's say, not needed simply because the context window size is so huge, the analogous part of that compared to operating system is like saying software engineering is probably, we don't need database organization so much because I have, let's say, 2 TB of RAM. If my computer had 2 TB of RAM, it's not like I suddenly don't have to manage my database or I don't have to manage my RAM, right? It's not like size of it is not uh, making you want to manage it. In fact, the more your context window is, the more capable and more powerful your large language model is, which means increasingly you will be doing more and more complex tasks. And because of that, you will have to learn how to manage the context. So there is a paper called, not paper, there is a very nice article written by Chroma on context rot. Just have a look at this article. This is also very nicely written. It's not a very long article. Came out around mid of last year. So this they had a paper which showed quantitatively how the context rot happened as the number of tokens increased per context. So yes, so somebody has commented MCP also has context overhead due to too many tool descriptions. Exactly correct. So we will be seeing that on lecture number 4. When you have 50 plus tools in your description, if your LLM has access to that many tools, your context will be bloated up with just the descriptions of tools, that the rest of the things in the context will be overwhelmed by this tool descriptions alone. So these are some of the LLMs and its number of tokens in the context: GPT-4o, GPT-5, and look at these 3 models: Cloud Opus, Gemini Pro, Meta Llama 4 Scout. This has around 10 million tokens in the context, which is roughly 28,000 pages. The Gemini 2.0 Pro is like 5,000, roughly 5,000 pages as we calculated earlier, right? And GPT-4o can fit around 300 pages. So here again, this is a bit challenging because you sometimes can pass PDF documents with 300 pages into the context of a large language model. It sometimes happen, right? But this is very unlikely. This is also very unlikely. But even then, you should definitely not exceed the context. If you are using Claude Code, you should be familiar of a command. One is /clear. This is one command. Another is /compact. So what /clear does is, which we can discuss during the building stage, but I'm just saying this so that you can keep this in your back of the mind. /clear command, what it does is, if you are switching your task within the same project from, let's say initially you were writing an article, then later in the same project you are working on a website, then you should probably use clear command to completely clear the context. Actually, in Cloud Code, there is a very nice GitHub repo which you can utilize called Cloud Mem. This is for efficient utilization of memory, and this has so many stars. For those of you who plan to use Cloud Code, you should definitely know about this GitHub repo. The installation instruction is provided down here. Just it's very straightforward. Just go through it. It can be installed as a plugin. So this will help you manage memory between sessions, which will again help you with having a good context. Now, this point we already discussed. If context window size is so big, why do we care about context engineering? Because you still cannot pollute your context, because then the relevant information will get flooded in the irrelevant information. So there are 3 different type of definitions. One by Andre Karpathy, who said the delicate art and science of filling context window with just the right information for the next step. This is one type of not a definition. It's more like it's the way he personally visualizes context engineering. Toby Lutke from Shopify, the art of providing all the context for the task to be plausibly solved by LLM. Basically the same thing. Then Harrison Chase is the CEO of LangChain, building dynamic systems to provide the right info and tools in the right format. In my opinion, this is slightly more specific definition of context engineering. I like Karpathy's definition a bit more in philosophical way. Then this key principle sentence I have directly borrowed from one of the blogs from Anthropic. Anthropic has a very nice blog on context engineering. Find the smallest set of high signal tokens that maximize the likelihood of your desired outcome. All right. Now let's look at this token budget. So this figure is showing you token budget. So in the exercise that is upcoming, what we will be doing is keeping track of the token budget and looking at 6 elements, the bare prompt, which is the user input, then the next layers, the system instruction, then conversation history, retrieved knowledge from RAG, the definitions of different tools that LLM is having access to, and the state and memory. How each of these 6 layers will affect the quality of the output is what we are going to do in today's exercise. But we will not do it all at once. We will do it in steps. So first, we will look at the quality of an output of, let's say, a chatbot if it had only access to users' input. Then second, we will add instructions on top, system instructions on top of it. Third, we will add conversation history on top of it. And then we will see quantitatively, if we were to quantify the betterment of the output of the LLM, how it looks like, that we can see. But here, this is how usually when you see a context visualization, Cloud Code also has a context visualizer, which will show something like this. Even in our website, there is one visualization I just want to show you. So here, if you scroll down a little bit, there was one visualization in which all elements are not there, but you see the context is shown as filled due to different elements. So this context is the input, which will be tokenized into the LLM. It will have a limit, 128K tokens or 2 million tokens or whatever. Within that, each elements of the of your prompt, system prompt, RAG, user input, etc., will keep on filling it. All right. So this is an example of each of the things. So retrieve knowledge. What do you retrieve after RAG? For those of you who are familiar with RAG, after RAG, what exactly do you retrieve after re-ranking? You have chunks, right? So in RAG, your knowledge is converted to chunks. Chunks are converted into vector in vector databases. Then certain number of chunks are retrieved. Then they are re-ranked. And then maybe you will pick top K or whatever number of items you need from those chunks. Those chunks will be, let's say they are in sentences. If it is a sentence of 10 words, it will consume how many number of tokens? Roughly 3/4 of 10, right? Roughly 7 to 8 tokens it will consume. So if there are 8,000 tokens as shown here, and let's say there are 10 chunks, it means each chunk has 800 tokens, which means each chunk has roughly 800 words. If we were to roughly say one token is equal to one word. So 800 word means each chunk is now a huge paragraph, or maybe it's a combination of like the statement of purpose that a student writes when they're applying for grad school is 1200 words. 1200 words is like 2 pages. So 800 word is like 1 page and a half. So here 8,000 token, if it is constructed through 10 chunks, it is like roughly 10 chunks with each of size 1.5 pages roughly, right? So that is what retrieved knowledge will look like. Tool output is, let's say you are using a large language model to track some price of some stock. So let's say some stock market website is giving you MCP server to fetch the stock price. What will you ask your large language model? You will ask, hey, can I know the price difference between NVIDIA stock from last month to this month? So this instruction is a natural language instruction. This instruction will tell, using the tool description, that I have to call the, let's say, finance tool MCP. And then within that tool, after you call the tool, you will get certain response, and the response will look in certain format. And that output from the tool will also be passed into the large language model context. So that output will typically look in this format. It won't look like paragraphs and like chunks. If you have conversation history, if you are running a chatbot, and if the chatbot should have persistent memory within the conversation, the entire conversation between user assistant, this should be passed into the large language model context. So if there are 10,000 tokens, it's roughly 10,000 words. I highly doubt if any chat between customer and user will be 10,000 tokens. But if there are multiple chats going on, and if all of those should be loaded into the context, which I don't think no one should ever do, but if that is the case, then you can imagine it to be that many number of tokens. And typically, the current query which user is asking will not be that long. If you imagine the way you are asking to ChatGPT, what is the typical size of your ask to ChatGPT? Unless you are copy pasting something, your typical ask is one paragraph. One paragraph is maybe 100 words, maybe 200 words, something like that, right? Which means it's on the order of hundreds of tokens. So current query will be a small part. Look at the fraction. Let me zoom out a little bit. Look at the fraction that this is contributed. The total tokens here are around 28K. Total budget is 128K. Out of the 28K, the prompt engineering part is only taking care of this 500 tokens. That's it. But 500 is only like a small part of 5 divided by 28.5. 0.5 divided by 28.5. It's a very, very small fraction. So the rest of the tokens are coming from your system prompt instructions, your memory and state. So in this case, the memory, we will see if it's a customer, what does memory mean? Okay, Vishnu has made a statement, file attachments can be part of the current query. Yes, if file attachment is part of the current query, if the file is like a 300-page book, then this will be very high. Then this 500 token will become very huge. Usually what is done is files like images are so heavy in tokens, which is the reason why the more you pass images into your large language model, the more expensive your usage will be. But if it is just a text-based PDF, usually OCR tools will convert it into digital format, and then only it will be passed into the large language model. If videos are input, then no need to say, it's like amazing, like your context is absolutely bloated up. There is a question, can we say the phenomenon of context rot is the reason why RAG applications is an option? Thus, reason why, even though we can push massive documents into LLMs, it is best if a RAG system is built of it. Yes, that is a very, very good way to think about it. Even if the context window becomes, let's say, 100 million tokens in the future, you will still not be passing very big tokens, very, very large number of tokens into the context of a large language model, because the performance will definitely degrade. You yourself think about it. If you are building a website, okay, in some parts of the website, you will have certain preferences as a user. In some other parts of the website, your preferences may be different. So let's say here your preference is to use font size 50. And here your preference is to use font size 20. Okay. It may so happen that if everything is fed into the context without any reason, you yourself may give contradicting instructions, like this and this might contradict each other. I have a perfect example for this. So we have a personal ChatGPT account, which me and my wife are using. Both of us are using in the chat. Now, she is pregnant. So when she is using this thing, she is asking questions regarding, why, like, what's the reason for this nausea and issues like that. Then yesterday, when I was using, I asked some question regarding, I forgot what it was about. Then it was responding to me. It was in a new chat. It was responding to me considering I am pregnant. It was giving me some weird responses. Then I was like, what's going on? I thought this was a new context if it is a new chat, but that's not the case. Internally, ChatGPT is taking care of the context in such a way that, it is assuming that the whole chat is made by one single user. Thank you so much. Thank you for your kind words. So this issue won't happen, by the way, if you are making API call. In the API call, automatically context is set by you yourself. There is user, but apart from that, there are system instructions. Now, let's say in the system instruction, you have provided your website, let's say preferences. I want this type of font style. I want this type of font family. I generally prefer modern dark color theme or bright color theme, something like that, you yourself might contradict when you move from page 1 to page 2 of the website. So this you will clearly experience when you are building something yourself. And that's a classic example of rotting of the context, because you are bloating the context with too many things. Is there a video or a link on how to effectively use Cloud Code? Yes. So we ourselves plan to launch. There is one video which I had recently released as a playlist last week. You can check that there. I'm building an entire website from scratch, just using Cloud Code with Opus 4.6. But we do plan to release more content on Cloud Code, simply because I'll tell you honestly, 3 weeks back, I had a time when I had sleepless nights. I was waking up at 4 a.m. and then I could not sleep till like for the rest of the time. And I had taken a promise that I will not touch my laptop before 8 a.m. because then there is no boundary between work and life. So then from 4 a.m. to around 8 a.m., I was just walking in the room and outside my building, just thinking about the sort of agents I could build. And this happened because I could see the power of Cloud Code with Opus 4.6, what it can build. And I felt some sort of excitement, which I had felt last maybe in the first or second year of my PhD, when some experiments became successful. At that time, I had gotten a very big kick, a high, and similar kind of high now I'm feeling after like 5-6 years. Of course, there are other highs, but it was very different. So I hope each and every one of you in the call, when you start using it, you will get some sleepless nights and you will feel like building something on yourself. Uh, it's truly amazing. I can't say more. So this we already discussed, right? The 6 elements of the context window. Now this is the context rot many people have been discussing in the chat. So before going into context rot, I want to show you one more paper. It's called Lost in the Middle Effect. I think I have it already open somewhere here. Yeah, this one. So this paper came out in 2023 end, and this already has around 3,500 citations. It's a really simple paper, by the way. I feel like if we had the same thought, I could have also written some paper like this, because this is purely about, it's not about building a new large language model or anything, right? It's prompting a large language model through inference and coming up with a conclusion. So this Lost in the Middle paper, what they showed was, when you fill the large language model with context, with a lot of information, the information that are there in the middle of the context are typically some critical information that are loaded over here in the context window might get lost. Large language model place a lot more emphasis on the starting point of the context and the ending part of the context. Whatever is there in the middle is being lost. Now, if you ask me, why is this fundamentally happening? I don't have a great answer, because I know that when we are constructing attention scores, if we have 5 tokens, 1, 2, 3, 4, 5, you have 5 queries and 5 keys. And the whole idea of attention is that of long range dependency. So my attention weights will look like, it will look in such a way that every single query can pay attention to every single key. So there is no specific reason why the middle tokens are the inference in the middle tokens are being affected so much. I don't know why that is the case. But from experiments, what is being clearly seen is that LLMs have this lost in the middle effect. So now what should be your goal as somebody who is creating the context for large language model? Your goal should be such that shrinking the context size in such a way that most of your info by default is coming at the two extremes, meaning shrinking this middle part as much as less as possible. So for example, if your context window is so large, and let's say LLM is um, losing much of information here and here, if you shrink it to this much, it may lose something, but what is lost is only limited to this much, right? And you ensure that no critical information is provided here. And usually when the different elements of the context are appended one after the other, user instructions come somewhere here, system instructions come somewhere here, rest of some of the items which are more dynamic come somewhere in the middle. And how exactly this works, I don't have a answer based on physics. It's just something that's based on experiments. But I really recommend you to have a look at this paper. It's very beautifully written. Just search Lost in the Middle Effect. Somebody had also posted about needle in the haystack effect. That was also something that was discussed in the haystack. So just have a look at, I think it came out more as a blog article. I'm not sure if this was just have a look at this blog article perhaps instead of the paper. It's also talking about very similar idea. Yeah, so lost in the middle effect is what are your main instructions? Your system instructions are some rules. Let's say your chatbot should never ever be condescending. Let's say that's a rule which forms part of your system instruction. Where would you rather put it? Would you put it here? Would you put it here? Or would you put it here? Your chatbot should never ever make a mistake of not taking that information into consideration, which means that information should never go into the middle of the context. Now, how do you say something is in the middle of the context? You have, at the end of the day, context is a string, a sequence of tokens, correct? And inside the context, you have system prompts, maybe something like information from cloud.md markdown file. You have information which the user gives. You have information which are tool outputs. You have information which are maybe recoveries from a RAG. So typically, this system prompt is very important because most of your rules are set here. And you don't want your LLM to ever hallucinate on these things, which means if you are concatenating this plus this plus this plus this, you don't want the system prompts to be somewhere in the middle. You ideally want it on the starting or ending, and typically it will be in the starting. Similarly, user also is giving some instructions with so much importance. You have to give so much importance to the user, because otherwise, if you are literally conflicting the user's latest request in the response, user will not like it. So typically, user response is also provided in one end of the a prompt. And can we control this behavior through prompt engineering technique? You mean, can we control the lost in the middle effect, or can we control where these things are placed? Which one do you mean? Oh, can we control the lost in the middle effect? Unfortunately, so far, it is a thing. I mean, it's a thing that it's a problem that LLM has. So I don't know, other than shortening the context window size, I don't know what else can we do to completely eliminate lost in the middle effect. Does it happen for smaller context length as well, lost in the middle effect? For smaller context length, in general, it is not. So when they did the experiments, it was more pronounced in the larger context. So typically for context window sizes exceeding like 100K tokens, the effect is more pronounced. Where is the paper? Yeah, this one. Any proven ways to reduce or limit lost in the middle effect? The most proven way is making sure that your context is compact so that most of the information, 90% of the information are all important information are already there, either at the start of the or the end. Then reducing the context, making sure that the middle information are a little bit dynamic. So I'll give you an example. Let's say you are fetching financial data from a website about Nvidia's stock. Okay, it is sometimes okay to have a little bit of hallucination there. I'll tell you why. Of course, it's based on the on case-to-case basis. But if the tool results are a little bit hallucinated, there are already frameworks in place where once you get the tool result, you can verify it whether with something with whether it is what you are expecting or not. So in the MCP that I had created, for example, I could fetch any data from our backend database. And before acting on that data, I have other agents in place which will verify that whether the fetch data is something which is correct or not. So even if this wrong data has been passed into the LLM and LLM has given me some response, I am not immediately acting on it. But what would cause an issue is in the system prompt, I have mentioned that never ever write anything into the data without my explicit instruction that I have mentioned into the system prompt. Now imagine that system prompt was somewhere in the middle. Then when I'm using my MCP, the large language model may erase some data or modify some data in my database, which should never happen. So for that reason, such kind of crucial, critical guardrails I place such that it will come in the start or the end of the context. It should never come somewhere in the middle. Can we repeat the context engineering? Yeah, doesn't the needle in the haystack test whether model attends to all tokens in the context. Yes, correct. That's very much correct. Needle in the haystack means there is one token that is like the needle. Haystack is the whole set of tokens. Can the large language model attention scores or attention weights be constructed in such a way that does the attention even does the model attend to even that token also, irrespective of where it is placed? Can we repeat the context with multiple different ordering of information? So Vishwanath, if I understand your question correctly, when you say can we repeat the context, do you mean um, the same information we repeat once more? Is that what you mean? Very good question. I recently came across a paper. I think it was from Google, repeating the prompt twice, Google paper. So in that paper, what they showed was if you give the same prompt twice to the LLM, I think it is this paper. Very recently it came out. Let me make sure if, yeah, this is the paper from Google. So basically what this showed is if you have a prompt, you repeat the exact same prompt twice, and then this will tremendously, it will increase the token consumption, of course, but it will tremendously increase the output quality of the large language model. And I haven't read the paper. I only came across the paper like 3 weeks back or something. I haven't read the paper. I do intend to read the paper, but I think it's a small paper. You might want to check this out. But this is very interesting, right? Somehow the context window is set up in such a way that when the prompts are given twice, it is somehow reinforcing the large language model, what the large language model is seeing, and the attention weights are constructed in such a way that if the prompt was only occurring once instead of twice, LLM is not able to as efficiently carry out the information. And yeah, of course, this is the trade-off between cost versus quality. Cost will be doubling, quality will also be improving. So what they did was very much this. If you have query like this, you literally paste it twice. So your user query token length is 2x of whatever it was. Take a look at the paper. It's very language of that is very simple. So usually what people suggest is, so this is the final recommendation, right? Should we have too many tokens in the context window or too less tokens? The problem with too less tokens is that model will start hallucinating because model does not have enough instructions to do what we want the model to do. If there is too much context, there is context rot. So in this case, if your model's token window size is 200K, anywhere between 50 to 100K can be considered as a sweet spot. Within 50, if it is 50 to 100K, remaining 100K tokens are free for model generation output, because when the model is generating an output, it also has to fill the context. It will fill the context. So you have to always leave some room for the model's output to be stored in the context. So with that point of view, if for this particular model is 50 to 100K, 200K is very good. Also, this is not a physics-based graph or anything. It's purely empirical. So now by extrapolating this, if you may ask, if it is between this to 2 million tokens, will the graph look exactly like this, or will the graph look something like this? It's very difficult to say unless you actually do the experiments, right? Okay, there is one question by Arun. Can you explain difference between context engineering and agentic AI? So if you want to build agents for various applications, context engineering is already a required part of it. However, every single thing that you do in context engineering may not be geared towards building an AI agentic application, because context engineering you have to do regardless of whether you have an agent or not. So one way you can think about how an agent works is, let's say you have a API key for Gemini, and let's say you are running a bunch of experiments on RunPod. This is experiment number 1. Then you have another set of experiments on RunPod, which is experiment number 2. Oh, that Google paper I did not share. Let me just make sure I paste it. So this is the Google paper. We just check this. So now coming back to the difference between context and agents. So let's say this is experiment number 2. And what you want is the following. You could either say something like something to the large language model, like run experiment number 1 first and run this second, right? And then you are sequentially executing it. You are executing experiment number 1 first, then its results are stored somewhere. Experiment number 2 first, its results are stored somewhere. Then you may analyze the result. Excuse me, just give me a moment. This is a little bit inefficient. The reason is, in fact, uh, if you had an agentic framework, you could actually execute this in instead of in series, you could run this in parallel. So if you are working on a paper, a research paper, you will form a hypothesis. You would want to run a bunch of experiments. You will have to analyze the results, and you will have to make figures corresponding to this. And these days, many of these things can be done using AI agents itself. So how many of you have heard of this called Paper Banana? This is a tool which is made on top of Nano Banana, and it's really, really good. It's really good for making actual research paper level quality figures. I'm not kidding. It's extremely good. The only thing they have done is they have built an agentic framework around Nano Banana so that paper making can be efficient. Now, my question is, let's say while you are running this experiment number 2, okay, your experiment 1 is already finished and you want to make a figure out of this experiment number 1, but simultaneously you want to run experiment number 2. What you do is you define 2 agents, one agent for figure making, another agent for running the experiments on Runpod or Google Colab or wherever. Agent number 2, and this is agent number 1. Now, each of these agents will have the access to the same API key. So if Gemini is what is being used, the same API key both of these agents will have access to. Now, here is my question. When agent 1 is making an API call to, let's say, Gemini or whichever model, and agent 2 is making an API call, is the context window the same for both of these API calls? The context window will not be the same because they are 2 different API calls. Agent 2 will have more context and more information about experiment number 2, whatever that is. But agent number 1 need not have details about experiment number 2 in its context. It needs to have only details about experiment number 1 to make figures corresponding to experiment number 1, right? So if you look at the overall framework, the 2 agents you have created so that these tasks can be done simultaneously in parallel, because it is just like how you have let's say you have 2 people working in your research team. To both people, you give the same API key. One person is using it for running Paper Banana to create some figures. The other person is using it for running some, LLM guided experiments on Colab or Runpod, right? So these you can call as sub agents also. And you are defining these agents so that you can do things in parallel, but you will not give the same context to both of these. So the context in the context engineering is also about the fact that although you have multiple agents here, both of these agents are not getting access to the same context. So in your agentic engineering, all you do is you define the agent, you define the tools and skills the agent has access to, and it will mostly do only one task. It will have an output in a certain format. This agent may have access to MCP. It will have some output which will be stored. So the AI agentic workflow will involve things around that. But in context engineering, in general, you can have n number of agents. You can have 100 agents. In Cloud Code, when you run, you might have seen it spin out sub agents. So what sub agents do is sub agent will create a new agent which will have its own context window, so that whatever is happening in another session is not affecting the sub agent's context. So you might notice that if there is a figure making agent, the figure might look very good, but another agent which is doing experiment number 2, maybe it will provide it can provide a poor result if its context has exceeded its context window optimum limit. So these are some of the things which context engineering will take care of, unlike just AI agentic engineering. I think now we are already running around half an hour above our timeline, but I think we can spend some time on exercises. So I don't want to go through Google Colab simply because I don't want you to get intimidated by looking at the code, although the code is not that difficult. The same information we can convey through this website. So I'm just sharing this website link in the chat. I will be changing the link later and putting it on the course website also, but just open it. And there is one place where you have to place your OpenAI key or Gemini API key. So just click this key icon over here and paste your OpenAI or Gemini API key. If you don't have the API key, you can just listen to the lecture right now. It's okay. So now this exercise is very simple. This exercise is supposed to show you the importance of different elements of the context engineering. There are 6 layers of context engineering, and this exercise is supposed to show you the importance of each of them, right? So this is the situation. There is a frustrated customer whose name is Marcus, and he's contacting the company Novatech Electronics about a headphone which this customer recently purchased of $18.99. Yes, I will share this link as well as the collab link. So this is the website link, and so if you guys really need a different version of this so that you can use Olama or any other API keys, just let me know. I can make modifications, but currently by default, this code works on 3 keys: Anthropic, OpenAI, and Gemini. Website primarily works on OpenAI and Gemini. I haven't set it for Anthropic. Okay, so this customer is now coming and chatting because the headphone of $18.99 is defective, and the self-service option in the website is not working very well. And because of that, and then there was a 45-minute waiting hold on the call. So now it's like the customer is saying, I want to now do a credit card dispute, etc. And this customer is like a premium customer, meaning this customer has already purchased items worth of $12,400 from the website. So these background information is there. Now the task is this: we should go through each of the 6 layers. Excuse me, let me drink some water. So now our task is this: if we have a large language model who has only access to the system prompt, let's say, so this is our bare system prompt, not system prompt, bare user prompt. So the user is saying, based on the past conversation, no, the portal just gave me some same error. It wouldn't let me submit anything. So I called your support line and sat on hold for 45 minutes before I got disconnected. This is now my 3rd attempt to get this resolved. I'm absolutely livid. These are $18.99 headphones that I need for my professional work, and left ear is crackling. It's been barely a month. I'm about to dispute this on my card, and if someone doesn't fix this right now. So this is user prompt, user input. Now, if we are simply doing a traditional prompt engineering, there is nothing much to do because users input is this, and then based on this input, the LLM has to produce the output. But the LLM, ideally, in context engineering, it should have access to some conversation history, right? So this conversation history is like the user initially asking, hi, I need a help with a defective product. Order number is this. Then assistant will say, I would be happy to help with this. I can see this is for this headphone. What is the issue? Then the user is answering this. Then you'll say, thank you for these troubleshooting steps. The crackling issue is firmware upgrade and resets does sound like hardware issue. Let me look into the best solution, and so and so. So this is the chat that has happened so far. Now, what I have built here is we will be passing to an LLM. The LLM will be whichever we select here. So right now it is Gemini 2.5 Flash, Gemini API key I have pasted here. And based on this, what we will do is we will only pass one of these layers at a time. So first we will pass just the user input. So currently user input is 110 tokens, which is roughly 100-ish words. And the output is output of the LLM is analyzed for various parameters. So here, when I click running, oh, you are not seeing my screen right now? Do you see my screen right now? The interactive website? Okay, you do see? Okay, awesome. So when I run with just one layer, which is the user input, okay, this is the output that LLM produces. LLM responses, oh my goodness, I'm so incredibly sorry to hear this. This is an absolutely unacceptable experience. I can only imagine how frustrating. So a lot of fluff, nothing useful. Please accept my apologies. Waiting for this is like literally repeating what the customer has said. And but if you really look at the resolution, there is almost nothing. Like, could you help me with the order number or email address? Order number was already provided to the chatbot earlier, but because the chatbot did not load the conversation in the context, the earlier conversation into the context, it has no idea what has happened so far. And because of this, if you try to grade the quality of the response, like whether it adheres with its persona, so persona should be empathetic, it should be helpful, etc., whether it adheres, and this I have manually mentioned on what factors should you grade the LLM response. Yeah. So how there is a question: how are you calculating the hallucination and completeness metrics? So hallucination is, there is some knowledge inside the knowledge base over here, which I have not added yet, but the knowledge is about a refund policy. Knowledge is about if the customer has purchased something of greater than, let's say, $500 or something, the window of returns can be extended by 15 days. So these things are part of the policy of the company. And then the grading is done by, yes, exactly. So grading is done by another LLM. In this case, it's the same LLM, but with a different API call. So that for grading, it will have access to all the context, and then you can perform the grading. Okay. So it's just for us to see, but a human can also grade it. Then actionability is, this LLM offers no actionable steps, 0 out of 5. So overall, if you look at it, out of a score of possible 40, it's getting only 18. And this is simply because the in the context window, only one thing is available, which is the user prompt. And user prompt, we should expect it to be perfect. Why? Because if you are providing a chatbot, if the customer is asking something to the chatbot, we cannot say, hey, customer, go and study prompt engineering and do this. We can't expect that. So this is perfect, which cannot be touched. Now, what we do is we go to the next step. In the next step, we add some system instructions. Just a second. I have a bit of a sore throat, so that's why I have to pause a little bit to drink some water. So system instruction is, you are Alex, a senior resolution specialist at Novatech Electronics. So Alex is the name of the chatbot. You have 8 years of experience and authority to approve resolutions up to $2,000 without manager approval. Then, as I mentioned, in the system instruction, you have to provide the rules that should never be hallucinated on. Always lead with empathy and empathy before offering a solution. Use the customer's first name naturally in the conversation. Never say I can't or that's not possible. Always frame what you can do. Acknowledge every frustration. Then take personal ownership, not I will, the team will. I mean, instead of the team will, put I will. If the customer had a bad experience, explicitly apologize for it. Introduce yourself by name and your role. When you have policy details, cite specific numbers when proposing a solution. So these are some rules that the chatbot should live by. And you can notice that nothing is too specific in this rules in this system instruction. Nowhere it says, if customer comes back with a $1,899 headphone, say this. It's not saying that. And tomorrow we will see why are we not doing that, because it's too specific. There is one question: how did I implement the right hand metric card? This one, right? So the way it was implemented was using one more API call. So into that API call, I'm passing everything just for grading, because if an LLM has to act as a judge, that judge should get everything, right? So when you say use chat GPT 4.0, you got 14 out of 40 or 23%. Is it for the system? Is it for the first step with just the user input? Or is it with the more? Yeah, okay, that makes sense. because score will not be constant. Each time if I run also, it will be different. But now let's see with the system prompt how the score improves or whether it declines. So let's move to the second step. So one thing I have noticed while running this, sometimes it because it's not physics. Sometimes with system prompt, the score can degrade a little bit. In this case, now with the system prompt, the score is increasing, 23 out of 40. Yeah, when you say you call an API for the score, which API was that? So that API was also same as this. So here I pasted Gemini API key, same thing, same I use for the judge also. So I make two API calls. In one API call, I only pass the user prompt and system prompt. In the other API call, I pass everything. I pass all the details and how the judgment should happen. And then it will be used for judging the result from the first API call. And that judgment result is what is shown over here. Okay. And here now the score is 23. So policy accuracy, no restocking fee for defective items, context awareness, but actionability is still zero. Maybe no actions are being provided in the response. But some changes you can see. Here it says, hello, I'm Alex, Senior Resolution Specialist. So this is one of the system instructions. Yes, I can share the GitHub repo for this. The code base I have already shared, but I'll put it in a GitHub repo. How do you make the judgment is consistent across multiple calls? So the instructions that I have provided to the judge LLM is the same in all the calls. Whether the LLM will hallucinate itself during different calls or not, yes, there is a chance that hallucination can happen. So I cannot ensure 100% consistency from one call to the another. But since the judge LLM has most of the context, we can hope that it is judging based on objective metrics, not hallucinating. Then let's move to the third step. So third step will be adding one more layer of detail. One more layer of detail this time is the retrieved knowledge. So retrieved knowledge is this. The bot will look at the company policy document. So the standard returns window is General Electronics 30-day window. Yes. So whatever response we are getting. So here for each experiment, for each experiment, we are making two API calls. First API call is to make to be made into the LLM with the user input and whichever other input we are providing. Second API call is made into the judge LLM, and judge LLM has been given certain criteria by me, and judge LLM will judge the response which it received from the first API call, and that is how these scores are generated, right? So judge LLM knows everything. What constitutes a good response, what constitutes a bad response, it knows. Judge LLM can be another OpenAI API or anything else, doesn't matter. With system prompt, it should have given actionable responses as Alex has the authority to provide a refund till to $2,000. That's not happening? Yeah, that's true. The main thing is it has no idea about the refund return policy or refund policy or anything because RAG is not there. So now we are adding RAG, retrieved knowledge, which is around 600 tokens. So now you see the token window has increased. In the first, it was user was just this dark blue. Then now we have this green, we have this blue, and now we have RAG knowledge and run with 3 layers. Now I want to show you this assembled prompt. Okay, so initially only this was there. Initially, only this was there. User thing is assembled at the end, but system is assembled at the beginning, and RAG is implemented in the middle. Implemented as in RAG is assembled in the context in the middle over here. So this whole thing is the prompt that is passed into the large language model. Okay. And now the score has increased slightly, 28 out of 40. But you look at the token consumption, initially it was 479, then it is 744, and now it is 1262. What if the inputs and response of the agent that is given to the judge LLM is beyond judge's context length? Oh yeah, very good question. In this case, that is not the case. But if it is beyond, judge won't be able to judge. Or if it is beyond the sweet spot, there will be context. Sumit is asking latency is also improving, some sort of caching. Good question. None that I have implemented myself. So I'm not sure latency whether it's improving because of deliberate prompting, or it's just an aftermath of having a better context. I'm not 100% sure of that. Prasanna has asked, so this whole context is assembled and passed as a prompt. Exactly. So this is the whole prompt. And now look at the score. So this is how the score looks now. Empathy and tone, context awareness. And if you hover your mouse on top of it, it shows why it got 4 out of 5, or why it got 3 out of 5, why it got 1 out of 5, right? And then we can add one more layer now. The next layer is tool definition. Tool definition is basically what kind of tools are there. If order ID is provided, look up order. Then process replacement for replacement of defective products, or issue refund for refunding of defective products, and issue service credit. And then context window has increased by another 300 tokens. And the tools are added over here, just below the RAG output. So what is at the start and end of the prompt again? Here, what is at the starting? System prompt is at the starting. What is at the end? User input is at the end. Everything is in between. The tools RAG are in between, and then run with again 5 layers. And why do we do that? To eliminate the context rot in the middle, not context rot, eliminate the lost in the middle effect. Eliminate or minimize. So now again, 30 out of 40, because now some scores are improving. No hallucination, 5 out of 5. No policy hallucination detected. Personalization, actionability is still 1 out of 5. Completeness, address the defect, address portal failure, address hold/disconnection. And you read the output. Output has increased in size actually. You have to scroll a lot to read the full output. Whereas earlier in the very first case, output was too small. Does this sound like a good resolution for you, Marcus? Just read through the output once. It's actually becoming better. And then the sixth step is state and memory. So now everything is there in the context. The user, system prompt at the top, user prompt at the very end, history of previous conversation, knowledge from RAG, tools, which are functions it can call, state, whether the memory is currently there or not. What is there in the memory for this bot as of now? Very good question. So in the memory, it is stored that this customer is a platinum customer because the customer has paid 12,400 in the past. The customer satisfaction level is this much. So it's like a loyal customer, and that is part of the state. State meaning what is the current situation for this customer, and it will be stored somewhere in the document, and that will be there in the current memory. And then look at the token size. Token size has become 1.9K, and look at where it is assembled. User, it's at the beginning. Not that. Context system prompt is at the beginning. User is at the end. Once again. Yeah. So system prompt is at the beginning. Then user prompt is at the end. Then the interactions between the user and the bot in the previous turns are over here. This one. So user assistant, then user assistant. So this is the previous conversation history. Can we try reordering this prompt and try? Yes, in the code that is possible to try. Here, I think I can add a tool to study the effect of lost in the middle. I can do it such a way that a system prompt is added later in the middle, but I feel like lost in the middle, for it to see the actual context window size is not 4K for Gemini. It's much bigger than that. So I don't think you will see the context lost in the middle effect with such small number of tokens. You will have to add more number of tokens. Are all memory implemented using markdown file only? I see this a lot in cloud. They all are stored as MD. So it's either most of the times it's MD or XML format. Or MD markdown format. So in most of our recent building processes, everything is stored as MD. In many cases, I have my big document stored as JSON files for structure, but I will often have a metadata of the JSON stored in another markdown file. Yeah, so now finally the score is, let me run with 6 layers. So one thing you should notice is that sometimes the score will reduce even after adding one more layer. Okay, I have noticed it, and to get a good example where the score actually keep on increasing is very difficult. The reason is this: if let's say it's a generic example, LLMs are already very good at producing good output, which means unless you have a very specific judging criteria, and unless you have a very specific conversation history and very specific knowledge base, your score may not keep on increasing. And even with all of this, if you run this 2 times, the output may differ because LLM will provide different output during different conversations. But on an average, the effect is what you see in this table. The score on an average will keep increasing with more input. So this is user plus system, user plus system plus RAG, user plus system plus RAG plus conversations, user plus system plus RAG plus conversations plus memory. And the score is the highest. Now, I want you to do one thing. I want you to go back home and try it in this Google Colab also. Yeah, score reducing is okay. Can you guys share a screenshot of your scores in the chat if possible? Like for your 6 experiments, how was the score? Like this. Did anyone get better than 30 percentage? So mine is not percentage, 31 out of 40. Mine is 31 out of 40 in the last attempt. It will also depend on whether you are using OpenAI or whether you're using Gemini. Oh, with all the 6 layers, Shivam, you're getting 20 out of 40. Oh, that is a bit weird. Okay, Sriharsha got 33 out of 40, which is very good. In real environment, our state slash memory and RAG share the same services or different? When you say services, what do you mean specifically, Sumit? Okay, Avinash has 27 or 31 in, I think, in the second last experiment. Yeah. And Nachamai has, I can't read the font. I think it's 23, 26. It went up to 26. Yeah. Oh, database instances. Is RAG and memory always stored as database? Not necessarily. RAG almost always has a database. For memory, we need not have a database like a vector database or something. It can be simply stored as a markdown file in your backend wherever you are deploying this application. So in our case, the email tool, the memory is the history of last 50 emails, which is stored as a JSON file. Now let's do one thing. I want to conduct a small quiz, which I think most of you will find very easy. Okay. There are 15 questions. Let's go through this. In the LLM OS, so this is just to refresh what we discussed in today's lecture. So every lecture, we will end with a small quiz like this. In LLM as an OS, what maps to the RAM? Context window, right? Fairly straightforward. Then in LLM OS analogy, what acts as the file system? Persistent storage, the model reads from on demand. Just read the full question. It is the RAG and RAG databases and vector stores. Can you tell me why is it, let's say, not the system prompt? Because system prompt is also a file, like a markdown file. Why is it not system prompt? Because system prompt is not on demand. System prompt is always there, whereas RAG database is always on demand. Then traditional prompt engineering, primarily, I mean, most easy question. What is it? It's the user's input is the only thing that traditional prompt engineering minimizes, optimizes. Which of the following is not the one of the 6 elements of the context here? So I can see 2 outputs, B or C. Is it structured output schema or model temperature? It is model temperature because model temperature and sampling is like top case sampling or whatever is something that has got to do with LLM. Model temperature defines from the output token how much variability is there when the final softmax probability score is predicted. Are you picking the one with the highest score, or are you doing some sort of search to find one of the highest probable elements, right? Highest probable tokens. So it's model temperature. It's not structured output schema. Structured output schema we will see when we describe, let's say, for example, when we define tools, we will define the structure. Tool result or retrieve knowledge is also part of context. An LLM app works in great in testing, but degrades over weeks in production. No code change. What has most likely happened? Token overflow, or because token can exceed your budget, of course, or is it model drifting? The model itself, LLM itself, is becoming worse over time. Or is it prompt injection? So many times what may happen is token overflow can be taken care of. You know how? When token reaches around 80% of the budget, you can auto compact, that we will discuss in one of the lectures, or you can entirely clear the context. But context rot can happen even before your context window become full. So your application can degrade even if overflow has not happened. That's the point. So context rot can happen more likely than uh, overflowing of the token. But this can happen, but this is very rare. The lost in the middle paper, I mean, this is fairly, yeah, Cloud Code keeps on compacting, yes. And if sometimes it will compact only when 80% or something is reached, and the output becomes very bad. So then I often say slash compact very frequently when I need to switch from one task to another task. How many tokens does the phrase context engineering typically require with a byte pair encoding tokenizer? This word equal to how many tokens roughly? Is it one token or two tokens? You can say roughly two tokens, right? Because roughly one word equal to one token in BPE, not exact, but approximately. Then 1 million token context window, like Gemini 1.5 Pro, is roughly how many pages? So this is easy to calculate. So one token equal to 7 by 4, 3 by 4 of a word, or 0.7 times of a word. 0.7 of a word, right? So 1 million token is 700K words. If each page has, let's say, around 200 to 300 words, I can divide this by 300. So 700 by 300 is roughly 2.5 or something. 2.5K pages. 2.5K pages is close to 3K. So here we can say 3K roughly. So the C would be the approximate answer. This concept I have not discussed, so I will skip it. You have 128K tokens, you stuff it with 120K tokens of potentially relevant documents. What may happen to the output quality? Will it improve? Will it degrade? Model automatically ignores. Quality remains the same but latency increases. Mostly what happens is there is too much noise compared to signal. Your quality will degrade simply because you are overwhelming your context window. All right. Which of these are not a real cause of context rot? Stale information that was accurate last week but isn't anymore, contradictory instructions across different parts of the context, token fragmentation from mixed encoding schemas, irrelevant context that dilute signal to noise ratio. So many people are saying C, many people are saying D. I have a question for those of you who are saying C, token fragmentation from mixed encoding schema. Why do you think that causes context rot? Or why do you think that does not cause context rot? Because in this question, I can see so many different answers. So let's look at it one by one. If you have contradictory instruction, it will cause context rot, correct? Which means B is not the answer. it will definitely cause irrelevant context that dilute signal to noise ratio. That can also cause context rot, correct? That is literally what we discussed in the last question. Stale information that was accurate last week but isn't anymore. This can also happen. You know how in our email responding agent, let's say our or chatbot, let's say the policy changed. So last week the policy was correct. This week it has changed. So probably this is one answer. But there are many other things which you can imagine which may not cause context rot, but these three will definitely cause context rot. All right. Yeah, encoding schema is just like the way you convert your words into tokens and tokens into vectors. What is the primary difference between prompt engineering and context engineering? It seems like many options are C, but yeah, prompt engineering is one static text which goes into the LLM input. In context engineering, we have dynamic inputs such as the input from RAG, output which comes from the tools, and so on. And then there are persistent instructions in the form of system prompts. And then there are markdown files which can act as memory. A customer support agent has a system prompt saying, always be empathetic. After 15 turns of conversation, it becomes blunt and robotic. Why? Yeah, Sriharsha, as you said, system prompt is definitely getting diluted. This you might have noticed in ChatGPT, right? Maybe this is one thing which all of you have experienced 100%. If you keep on running in this, running your instructions within the same chat, it will keep accumulating those conversations into the context, and then the context rot happens. Now, last two questions. So your RAG pipeline retrieves 5 documents and places them in this way. So first goes system prompt, then you have 3 documents from RAG, actually 5 documents from RAG, then you have user query. This is what we saw earlier. Which document could be least effective? The document that could be least effective is whatever is there in the middle. So, and this is how we assembled in the exercise. Please note, in the exercise, we had first the system prompt, last the user input, in between everything like the conversation history, memory, RAG, tool info, etc. So here, some things in the middle, like anything over here can be, problematic, but based on what we saw in the paper, doc3 could be the most affected. This is not a rule, by the way. It's something which maybe in some cases doc4 may get affected. Maybe sometimes information in doc2 may get affected, but on an average, middle items can get affected the most. The last question, which context engineering operation does a RAG pipeline primarily perform? So this write, compress, isolate, select a framework we are yet to discuss in detail, but just read the question and try to understand based on your logic. It generates new context from the knowledge base. Is it this? Because of course, RAG can add more info into the context through whatever it does, right? But is that the case, or is it compress? It reduces documents to fit the context window, because you can provide large document for RAG, and then RAG will produce chunks and it can add it into the context window. Or is it selecting? It chooses from information to include from a larger corpus. Isolate. Most of you have said C. That is correct. So I think that brings us to the end of the quiz section. It's also on the website, which I will be posting in our course website. And for those of you who are in the engineering plan and industry professional plan, please note that I had posted yesterday a Discord server link. Please join that. I don't think everybody has joined yet. Please make sure that you have joined the Discord. We will continue the kind of conversations there. And I want you to go through the Google Colab notebook once before tomorrow's lecture. And tomorrow we will be discussing about how to craft the system prompt in a very effective way. Because if you think about whenever you are working on Claude code, the first file that you will be working on will be something like claude.md file. And this claude.md file will have everything about the system instructions. The Discord server link will be available only to the engineering plan and in the industry professional students. I have already posted that in the website. Today's recording, it will take some time to process because it's been almost a month. And anyone who has a question, please feel free to put it in the chat. Because of the size of the call, unmuting option won't be there. But feel free to add a question and add the question in the chat. What else is there? Yeah, is conversation history persisted or stays in the memory? Very good question. So there are two types of conversation history, right? So in the example of email reply agent that I discussed, there are two types of conversations. One is the conversation of every single threads that happened over the last 1 year. Obviously, that you cannot put in your persistent I mean, you have to store it somewhere, but you have to also compact it in a way that if some information is needed from that, you have to retrieve it quickly. So what we have done is, if there are 10,000 email threads stored in JSON files, such that those JSON files, each of them are 10 to 15 megabytes, and you have 10 such JSON files of 250 megabytes, you can't use it directly. So what you do is you go through it, you ask the LLM to create markdown files, which finds my writing preferences, which finds my style of replying to technical and non-technical questions, etc. And it should create its own idea, which is a much shorter summary of what all has happened in those entire 10,000 or 3,000 threads. This is one memory which is stored as a markdown file. The second one is the recency. Recent, let's say 30 or 40 or 50 conversations have so much more value, right? So now where should I store this? That maybe I will store as such as JSON file, or I will convert the JSON format into markdown file or XML format. And that I will have separately accessible for the large language model, because storing just 30 or 40 conversation is not too expensive for my context window. But storing 250 megabytes worth of JSON files into my so that it can be retrieved into my context is very expensive. So so how is state management done here? So in that particular case, what I have done is I have the following things which are coming in from the memory. One is the recent history of my feedback. How has I given feedback based on last interactions? Second is how has the last 20 interactions gone between the email reply agent and the customer. That is the second thing. Third thing is a detailed summary of last 10,000 or last 5,000 conversations which happened over last 1 year. And third is a compressed information about all the, let's say there are 100 or 150 courses or whatever on the website, a very compressed, concise format of that. So these four things I am loading into my state for context, but this is all very concise. But on top of this, I'm performing RAG to retrieve the best match courses. I'm performing RAG to fetch the most relevant email for the current conversation going on. And I'm also performing RAG to find from the several dozens of feedback that I have given to my chatbot, my email agent in the last, let's say, 2 months, what all feedback are relevant for the current ongoing conversation. So there are different, so for the state or memory, there are a bunch of things. But on top of it, if I need more information dynamically, I have added RAG on top of it. Okay, so I think we can wind up. So one important detail that I need to mention is the things that I will be posting today. One is lecture video recording for the engineering and industry professional people. I will be posting Miro boards, the code file, the website link, which will be different one which I'm posting. Then all of this I'll be pushing into a private GitHub repo that also I will share. Also Miro I will be sharing. For the free folks, you will get access to the video. Video I'll be anyway posting sometime later on YouTube as well. So thank you so much. Really, please try the Google Colab notebook. Please have your API keys ready. If you did not have it today, by tomorrow, please have it ready. And this experiment, if any of you are interested, just try this once. This repeating the prompt. I think this is very easy to try. Like repeat the prompt twice or thrice and see how the quality improves while your cost is doubling. We can discuss about so research plan, what I'm planning is we have different research topics in which are related to context that we want to work on. And the goal here is to work such that we can target some workshops which are part of, not part of, which you can see from here. Just go to openreview.net. So what we usually do is we work on different projects, and whichever is relevant to whichever workshop we submit to those workshops. So recently, a couple of our papers got accepted into ICLR workshops. So the main paper, like main conference like ICLR or NeurIPS, it's very difficult. But if you are interested in research, you can just let me know. I had sent an email yesterday with detailed instruction on how to move from engineer to research plan, but just drop me an email at hello@visuara.com. I'll be happy to respond to that regarding whatever query. So next lecture is about system prompt. The lecture after that is about RAG. The lecture after that is about MCP, and that will be covered this week. Next week, primarily, we will do things which will help us in the building. So for building, I'm planning a very exciting project. I really want all of you to be ready with hands-on skills by then. So thank you so much. We will meet again tomorrow, same time, 9:30 a.m. IST. Have a good rest of the day and try out things on your own, and happy learning experience. Bye. Good morning, everyone. Can you see me, hear me, and see my screen all right? If you can just confirm, that'll be great. Awesome. Thank you so much. So let's get started. So yesterday we discussed about the 6 different layers that constitute a context that we provide to large language model. So today we are into lecture 2. Today we'll be looking at one particular part of that, which is system prompt. So primarily system prompt in modern context engineering, for example, if you are using cloud code, it is primarily defined through cloud.md file. So we will be spending most of the time today figuring out what is the most sort of scientific way to structure this markdown file so that you can get the best output out of your LLM. Now, just to reiterate the structure of this bootcamp, yesterday the 6 elements of the context was system prompt, user instructions, which is primarily what is optimized in prompt engineering, then tools, which will come as part of MCP, then memory or state, then RAG, which is for dynamic fetching of data from your knowledge base, and then conversation history. We briefly touched upon these and we saw the importance of each of these elements through the exercise. And today we are primarily focusing on this one part, which is system prompt. And tomorrow we will move into RAG. And day after tomorrow, we will move into tools or MCP. So there is one question from Ankit. How is memory different than conversation history? Aren't they the same? So conversation history is a lot more less persistent, whereas the memory part or state is more persistent. That's the primary difference. So to give an example, volume. I don't have a volume increase provision, but is my volume all right? My mic is as close to me as possible. Can you hear me? Okay, awesome. So to go back to the example of memory versus conversation history, let's say we are building an agent to respond to one single email in that particular thread. So in that thread, you are conversing with one person. And let's say the thread is such that already 25 exchanges have happened in the thread, right? So that history of what has happened in the thread, which is the 25 conversations corresponding to the current conversation, that will form part of the conversation history. However, that will not necessarily be part of the entire email agent's memory or state. It will not be a persistent memory. In persistent memory, the following things will be there. Because in persistent memory, your email preferences or the way you have replied to your emails in the last 1 year will be there. The way you respond to technical queries versus non-technical queries will be there. Those things will be concisely mentioned by taking, let's say, 10,000 or 5,000 different email exchanges that happened over 1 year. There is no particular reason these 6 elements are put in this particular order. This is not the order. The order is what we discussed yesterday. In the context, initially what goes, just to refresh your memory, what is the first part, what is the middle part, and what is the last part, if you can recollect what we discussed yesterday. First part is the system prompt, which forms the rules, guardrails, etc. Last part is the user prompt or user instructions. Everything in between will form RAG, output from tools, things related to memory or knowledge, etc. And just to reiterate on Ankit's question, yes, so short-term memory, conversation history is sort of, you can think of it as short-term memory. The 6 layers of context, you can actually expand to more layers, because sometimes people like to add one more layer called agents. But I'm not doing it because, in my opinion, agents is already have most of these things which are mentioned here is already part of agents. So I don't want to define one more additional layer called agent, right? But you can think of conversation history as not exactly as memory. This, if you call as state, which is a better word. This you can call as some sort of session memory, and this you can call as state. And state is defined based on knowledge base, as well as what is stored in the memory markdown files or memory txt files or xml files, right? So the order in which it appears in the context is what really matters, not the order in which how I have written here. The order in which it appears in the context is in this way. System has the highest priority because guardrails and rules are set here. User also has very high priority. And why do we put it at two extremes? Why don't we then put system and then user? If user has very high priority, why are we not putting it second? Because to minimize lost in the middle effect. Because in the lost in the middle effect, people, or let me just admit some people from the waiting room. In the lost in the middle effect, what happens is, the most prominence given by LLM is to the starting and ending of the context window. Whatever is there in the middle of the context window, there is a slight lost in the middle effect whenever the context window size is bigger, right? So if an LLM has 1 million or 2 million as the context window size, try to keep the actual context length as 50K to 100K tokens. So now let's look at system prompt and how we construct the cloud.md file if you were building using Cloud Code. So the cloud.md file typically have 5 components, which you will be able to identify when you look at the cloud.md file in detail. So we will look at that in detail, but usually the 5 components are the identity of what you are doing with your Cloud Code, or what you are doing with what you are building. So for example, if you are building an email response agent, who the model is, it will not say something like you are a senior code reviewer. You don't have to give like a anthropomorphic definition. It need not sound like a human. However, you should mention what this tool or what you are building is all about. This is an email responding agent, or this is my personal digital clone for responding to Slack messages. Or you can also say this is meant for maintaining a website which automatically updates whenever new things happen in the AI space. So who the model is, simply, it does not mean who the LLM is. Okay, please don't get confused by seeing the word model. It simply means whatever you are building, and whatever you are defining in the cloud.md file, what is that meant for? It is meant to be used as a agent, or it is meant to be used as something for updating your website, or it is meant to be used as something which will respond to you on your behalf or schedule meetings on your behalf. Then rules are how you should execute certain things. For example, never use, never respond about refund policy without looking at the policy document, or never use camel case, use snake case, or never store the points scored by a student if this has got something to do with a school or something. Never store the points scored by a student in more than 2 decimal points. So these are sort of like do's and don'ts, which will come as rules, and it will set the guardrails for the large language model to give you the output. So this is of the highest priority. If you look at these 6 things, 5 things: identity, rules, format, knowledge, and rules. Even if you have extreme shortage of context, number of tokens in the context, rules will be the last thing which you will remove, because rules will set your guardrail. You might remove the rest of the things a little bit, but rules will be the final thing which you will remove. Then the format of how the LLM should respond is very important. Sometimes LLM is supposed to respond to you in Python code format. Sometimes it is supposed to respond to you in a natural language if you are using it as a chatbot, right? And sometimes LLM is supposed to create files for you, which could be like JSON files or something like that. So, and apart from all of this, often there are other format related uh, specifications mentioned in cloud.md. For example, let's say you are constantly using an agent to build and redeploy a website whenever changes are happening, which means for a website deployment, you may follow certain code like npm run dev or npm run build you will do, or npm run dev you will run. So if these are the commands that you are using to build, it can go in format as well as in knowledge. So sometimes, as I will ask you some questions, the boundaries between knowledge and format is a little bit fluid. It might confuse you what is knowledge and what is format. Sometimes the boundary between rules and for knowledge is also a little bit confusing. Knowledge is more about um, what you do or what you are trying to accomplish. Rules is more about how you do it. So in one line, you can say knowledge describes what reality of the application or what the reality of your agent is. Rules literally control their behavior. Rules define how they should or how they should not behave. And finally, tools will define in the cloud.md file. Tools will define what all tools or what all functions or what all libraries your agent or your large language model can get access to, or what all libraries will be referred to when the context is constructed for the large language model. Okay. So now to make all of this solid, what we can do is this we can do together. And this will mostly help you if you work, if you have cloud code. So you don't have to necessarily do it right now, but if you do it along with me, that will be even better. So just go to this website. So this is the landing page for Cloud Code, and they will give you this line of code to run in your terminal. Just copy it and run it in your terminal, and that should install Cloud Code for you. And to log into Cloud Code, let me just switch to my. Can you see my VS Code right now? Can anyone confirm if you are seeing my VS Code and not the Miro board? Okay, thank you. So now I have created like an empty working directory here. I will just delete everything right now. So it is completely empty. Nothing is there. And this is my working. Let me also delete this. So right now in my terminal, if you look at what is there, this is the present working directory, LLM context engineering. And if I try to list the items, it's basically empty. LS will list all the files in this working directory, and nothing is there. It's fully empty. Now, the way you use Cloud Code, you can use it in two ways. If you have installed Cloud Code, you can simply type Claude, CLAUDE. It should open within the terminal the chat box for talking with Claude. Okay. And here you can type anything, not to get you responses, but to take actions. So here you can say, create an empty file called cloud.md. Then it should create a cloud.md file, which will look empty. So basically, this agent has control over everything that is there in your working directory. So ideally, you will invoke these agents, a Cloud Code agent within the working directories where you have trust. So now you see, to take the action, it is asking you your permission. So then it's asking, do you want to make this edit to cloud.md? Yes. Or yes, allow all edits during this session. No. So often what you will notice is that when you are using Cloud Code, constantly you have to keep giving permissions. Even within this session, if you are performing a different task, it will again ask you permission, right? Which is a little bit annoying. It is a guardrail, of course. So if you are building something very sensitive, you keep the guardrail on. You do it this way. So I'll just give permission, yes. And you see a cloud.md file is created, which is empty. But let's say you are building something very big. if you're building something very big, it's very, very difficult to keep sitting in front of the system and keep on giving permission for every minor things that Cloud Code is building. So to prevent that, you can check this GitHub repo. It's not that popular. This GitHub repo is not extremely popular. But however, what it provides is something which can help you bypass constantly giving these permissions. So they give you the line using which you can install this CCO. They call it as a thin protective layer for Cloud Code. I don't know why this is not as popular as it should be, but it's very, very helpful for building something that will take a lot of time. So once you have CCO installed, you can invoke Cloud Code in a slightly different way. Let me just show you that. So I'll just exit this session /exit. So now I'm back to my terminal. And yeah, you can also do Cloud allow dangerously skip permissions, but CCO is a better way to do that. So here, instead of typing Cloud, you will type CCO. And then again, it will open Cloud Code, but with skip permissions enabled. But I think there are some guardrails present as well. Okay, so now if I ask it to do something, it can make changes in your folder. So now let's say I want to create a cloud.md file for a RAG chatbot that I'm building. So I'll just give minimum instruction. Okay, let me make sure that my context is completely clear. So I just cleared my context with /clear. So my context is fully empty. So if I say /context, I think /context should help me visualize the context if I'm not wrong. Yeah. So this is the visualization of the context. So total, I have 200K tokens, out of which 9% is gone. And here it shows where those tokens are gone. In system prompt, some tokens are gone. This is not the system prompt where I have defined cloud.md. Cloud.md is literally empty, but this is within the system prompt because Cloud Code uses a lot of agents, right? This 200K tokens are not consumed just based on what I give, but it is also consumed by Cloud Code agents, which Cloud Code helps deploys whenever you try to execute a task. So this 18K tokens are by default consumed, not because I have done something, but because Cloud Code has already deployed certain agents, and that will consume some context. Now we will track this context usage visualization as we go ahead. So now what I'm going to do is, I will say, I want to build a RAG chatbot, make cloud.md file for this. So as you know, this is the worst kind of prompt I can give. As a user, I am being extremely lazy. I am not that. First of all, you don't have to directly make cloud.md file because you are not really good at doing that. But you can give detailed instructions so that Cloud itself can create the cloud.md file. So here, this is my one-line instruction. I want to build a RAG chatbot, make cloud.md file for this. So this is too vague. It's too useless. And let's see what Cloud will now do. So last time when I tried this, what Claude did was it had no idea what my preferences as a user is. So it asked me for my preferences, like, would you like to use LangChain? Would you like to use ChromaDB for the database, etc. Right? But I don't know what it is going to do right now. Let's wait and see. I think it's directly writing. I'm not sure why my preferences are not asked. Perhaps the preferences which I had. Yeah. So there are so many inherently defined skills in a dot skills folder, which is installed globally. And from there are a lot of slash commands, /init, or if you are working on project roadmap development, you can define commands like /prd, using which you can invoke project roadmap development. But here they have already directly created the cloud.md file. Let's look at the structure of this markdown file. So here it says project overview. And in the project overview, it says a retrieval augmented generation chatbot that answers users' questions by retrieving relevant context. So this is out of the 5 elements that I showed you in the Miro board: identity, rules, format, knowledge, and tools. What do you think this is? This project overview is what? Is it identity? Is it knowledge? Is it rules? This is sort of like identity, right? Here we are not saying identity as per you are a programmer or you are a chatbot with these human characteristics. That's not necessarily the case. You don't have to say give such human form, but identity is basically what this project is all about. This project is all about a RAG-based chatbot for responding to whatever queries. Then there is something about tech stack, and it mentions the programming language, large language model to use, embeddings, vector database, framework, API, etc. Out of the five things mentioned here, what do you think this tech stack is more close to? Is it tools? Is it knowledge? Is it format? Is it rules? Out of these, it's definitely not identity, right? Identity is already mentioned over here. So, in my opinion, tech stack is a combination of two things. So, first of all, in this project, what do you think would be the tools? Tools will ultimately be the packages, libraries which you will use, or if there are functions which are written, what you will use, or APIs that you will use. Those are at the end of the day tools, right? So in the tech stack, when you say that it's Cloud API, you are saying this is one of the tools that you should use. When you are saying ChromaDB, it is another tool, LangChain or Llama Index. These are all defining certain tools. But at the same time, it's also providing knowledge, right? It's saying the large language model should be Python, LLM should be cloud based. So that is the reason why earlier I said sometimes the boundary between knowledge and tools, or sometimes the boundary between rules and knowledge are very thin. But here, essentially, you will find a combination of tools as well as knowledge. What about this? What about this project structure, which is the SRC folder of the project, in which different subfolders are there? In each subfolder, there are .py files. That will be the format, right? What is the format in which we are structuring this project? Then let's now look at another part. How about this retrieval quality? Out of these five, identity, rules, format, knowledge, and tools, this is definitely not identity, right? This is also definitely not output format. And this is not necessarily tools, because we are not necessarily talking about tools or APIs here. So it's again a thin boundary between rules and knowledge. Here, you can think of rules as the following. Whenever you say how to do something, it's about rules. Whenever you say what to do, or what the thing should look like, what your tool, what abilities your tool possess, those are knowledge. So when you say start with cosine similarity, it's coming closer to rules, but it's arguable, right? One can also argue that, oh, this can also be considered as knowledge. But generally speaking, as a thumb rule, if you say, hey, never use as a chatbot, never say I don't know. If you say something like that somewhere in this markdown file, that is coming as part of rule. It's not a knowledge. But if you are saying whenever there is any mention about refund, look at the refund policy document. There again, it's a combination between rule and knowledge. So just look at this. How about this? Prompt engineering, system prompt defines this, retrieved context is injected, instruct the LLM to. In general, is this closer to rules, or is this closer to knowledge? Is this saying how to do something, or is this saying something like how things should be? This is more closer to knowledge, like in the sense that system prompt define chatbots rules on consent. This is not this. Look at this line. This line is not saying how to do something. It is just talking about what the reality may look, what the some specifications about the chatbot looks like, right? Retrieved context is injected with with source attribution. This is again not like, it's not mentioned as a rule, it's mentioned as a knowledge. Okay, some students are waiting to join. Let me just actually, there is no one in the waiting room. Currently, it's empty. All right. Um, Now, what else? Let's look at Format, identity, we discuss rules, format, knowledge, tools. Yeah. So I think this, and how about this? Develop commands. What are these in your opinion? Is this, you can see that there might be a thin boundary between knowledge and tools. In my opinion, this is more about knowledge, because here we are not explicitly saying these are the tools that are used, but in fact, there are three things coming here. One is format, the format not of the output, but the format of how to run the server, or how to put the server into local deployment. So some format is being specified, but some knowledge is also there, because this section of the cloud.md file gives your large language model knowledge about the development commands. All right. And what about this? Where does this come? Environment variables. Is this a rule? This is not rule. This is not identity. This is not, let's say, tools. This is knowledge. This is knowledge about environment variables. Either you provide it here itself, or you put, I mean, you usually don't provide it here, but you are saying that environment variables will look something like this in the .env file. So usually the way you store env files are you create a .env, and you have something like this. Let's say these are the APK, sorry, not APK, API keys, and you put the API keys here, right? So this is how .env is structured. And usually you will also have a .gitignore, so that you are not, and then you should mention .env file in the gitignore, and only then you should, you will ensure that .env files are not pushed into the GitHub. Okay, there is one thing. This is very confusing. How to put various components into what bucket? Exactly. It's not a sharp boundary between what is a rule and what's a knowledge. And as I always say, LLM context engineering is not physics. It is more thumb rules, more things which has evolved because big companies have experimented a lot and things have been figured out. Because community has built guidelines and suggestions. So there is a sort of a boundary between. It's not a hard boundary between what can constitute knowledge and what can constitute rules. That's also one reason why in the website I have mentioned the art of context engineering, not the science of context engineering, because it's not strictly a science. But right, do we need to force everything into these buckets when they don't fit so well? So this is the exact great question, Sankalp. That is the reason why I showed this example. Just tell me, look at the command which I had given. In my command, did I mention anywhere how the cloud.md should be structured? The only command which I gave was, I want to build a RAG chatbot. For this, make the cloud.md markdown file, right? But the way cloud itself constructed it is in such a way that your markdown file ended up having structures which follow each of these sub elements. Now I will show you another way in which you can construct the markdown file in an even better way. Okay, so let me switch my workspace. So this is another workspace which I recently built as part of building the AI developments tracker. So I'm building a website for tracking the developments which are latest happening in the AI space on GitHub, Archive, Hugging Face, then X.com, and LinkedIn and Reddit. So what I did here was, I knew that for this project, markdown file is extremely important. So I did not want to make it myself directly. I also did not want to give a 1-line or 2-line commands in the terminal to create it. So what I did was, just look at this document, ideas.md. So in this ideas.md, what I did is, I just added my requirements in long natural language text. Right? You can see the ideas.md, right? I hope I'm showing you the correct tab. I hope the tab switching has worked for you. Okay. So in this ideas.md, so my usual workflow is I use this software called Whisper Flow. The spelling is this, WISPR fellow W. So if I press my function key on my, I use a MacBook. So if I press function key, it is activated. Then what my speech will be converted to text. So usually I have a lot of requirements in my brain. I have to somehow put it as fast as possible onto some document. So I just put all my ideas in this ideas.md. But this is highly unstructured. I did not want Cloud to use this unstructured ideas.md to create a structured cloud.md file. So what I did is I asked Cloud to first create a version 2 of ideas v2.md, which is a structured version of ideas.md. Now, this may look very similar to cloud.md, but I did not explicitly ask ask Cloud Code to create a cloud.md file, but rather I asked to convert ideas.md into a little bit more structured format with subheadings. So this hash or double hash are all subheadings. How do you know? I have installed a plugin. I'll just show you this in the preview. So this is how the Markdown file, if you have any Markdown preview extension installed on VS Code. So I have installed this extension called, I forgot the name of that. Yeah, this one. So this extension I have installed on VS Code, Markdown Preview Enhanced. So if I'm on a Markdown file, all I need to do is, so if this is ideas.md, I want to see as a proper preview, I can just plus Command Shift V, then it will open this preview in this nice way. But here you see this is very unstructured. But the ideas v2.md that Cloud Code created is much more structured with headings and subheadings. Let me just show you that. See, this is much more structured. Then what I did is this ideas.md, the problem is this ideas v2.md probably will not follow this structure, which is ideal for cloud.md. So then what I did is I asked in my terminal to keep track of what is there in ideas v2.md and then use ideas v2.md to create the cloud.md. So Ankita has asked, you created ideas.md to v2 with cloud. Yes, exactly. I use cloud to convert into the structured v2 format. And then using the v2 format, I use cloud.md. And that's the reason why in the first part of the cloud.md, in the identity of the model, it says it refers to ideas v2.md. So ideas v2.md provides the full context of what this project is. And then the rest of the details like, and this project overview is also identity, but then the rest of the section, tech stack, or this project structure will give the structure. Tech stack will give idea about the tools that I will use. It's also partly knowledge. Then you will also see the development phases. So this is sort of like knowledge because I am going to develop this tool in different phases. First, it will be a single user minimum viable product. Then I will, are you using Cloud Code in VS Code? Yes, I am using Cloud Code in VS Code. So, I mean, I have a Cloud Code extension in VS Code, but right now I am not using that. I'm using it in my terminal only. So this Cloud Code extension also you can get from here. Go to VS Code extensions and type Cloud Code. This you can install, but I personally have not used this Cloud Code extension as much as I'm using it in terminal. So in VS Code, you can open terminal by pressing Command J. So Command J means it will close, Command J means it will open. So this is my terminal, right? And to open Cloud Code here, you can either type Cloud or you can type CCO if you have CCO installed, right? So this is a better workflow to create cloud.md files with the help of Cloud itself. And but instead of directly creating the cloud.md with very minimum instructions like what I did here for this RAG chatbot, I barely gave any instruction. And because of that reason, I'm pretty sure this cloud.md, like whatever I build after beyond this cloud.md will not be very good because I have not given anything about my preferences, right? Can we compare this to the plan mode in Cursor where you speak and keep planning, and once the plan is ready, the agents start working? Yeah. So Cursor or GitHub Copilot, that main difference is the way in which these coding agents handle the context. So I have used Cursor a little bit, but the most amount of time I have spent are on Copilot. So till Cloud Code, I was spending time on Copilot. And then after that, I switched to Cloud Code. And once I switched to Cloud Code, I have never used anything else. So yeah, just to reiterate, Ankit, so first you took note of your raw thoughts, yes, and then used a V2 version, I mean, another version to structure my raw thoughts into a structured version, and then use that into Cloud Code. Yes, exactly. All right. So now let's go back. So Anthropic has this idea about what should be written in Cloud Code, and that is written in I think there is a nice article about context engineering Anthropic. There is a very nice article. Just I will share this again in the course dashboard, but this is a short article which I recommend everyone to read. This was again sometime in the end of last year, yeah, September 29, 2025. Effective context engineering for AI agents. This article had become very popular. It's actually not that long, but there are many sub articles which are linked within this article. So just go through this article at least once, okay? So Anthropic has this suggestion of idea of right altitude. So the right altitude simply means when you are giving examples in Cloud Code of what to do or what not to do not stay. Oh, link I have not pasted. Yeah. Did you get the link? Okay, just a second. My Wacom is not loading. Yeah. So the principle of Anthropic's cloud code construction is you should neither be too high in your instructions and nor be too low. And what is too high and too low? Too high means too vague. Too low means too specific. So if you are looking at something that is lying on the ground, when you are standing on the ground, you see all the minor details of it. So you should not be writing in Cloud Code something like if a user says how much, if a user asks how much, reply our plans start at $9.99 per month for basic. Can anyone tell me why this is not a good idea? Why can't you add something like this in cloud.md file? Like, why exactly is this a problem? The problem is because it is too specific. This, what if your pricing changes next week? Many changes can happen to your products or pricing. Anything can happen. And cloud.md is one such files that will almost not change once you finalize. The lifespan of cloud.md file is months. So if your project development is weeks or months, throughout that time span, your cloud.md file will almost remain constant. So for example, this cloud.md, which I initially built for building the AI development tracker, it has not changed from the first version because the basic ideas which I had in my mind, they haven't changed. In this ideas.md, although I have mentioned some specific things like, where is that? I think I had mentioned, yeah, for example, I had mentioned that you have to check GitHub repo, x.com, LinkedIn. These are specific. What if some other platform also I need to track, right? So cloud.md should ideally mention, look at some platforms like this, or track some people, some famous people who are working in AI. But then later, if some changes need to be made, just provide a provision for that. So cloud.md should never say, these are the buckets that I am always looking at. It should never say something like that. It should say, broadly look at social media sites with LinkedIn as an example, Reddit as an example, or x.com as an example, right? So there is one question. If we update the ideas incrementally, then will idea v2 and Claude also update? No, not by default. Automatically, it will not get updated. I have to explicitly say that. So my entire goal is I don't want the cloud.md files to keep on changing. It's not a dynamic document. That this document acts as the foundation. Now, I'll give you one example when something changed, as Rakesh has asked. What if some rules change? If some rules change, of course, it has to reflect in the cloud.md, right? Because rules are like guardrails, or it should be loaded in every single API call because the rules should never be broken. So if you want something to be never broken, you have to load it in your cloud.md. Now I have another question. Right now, my cloud.md for this is how many lines? 300 or 400 lines or something like that. Yeah. 250, 265 lines. Okay. What if this cloud.md file was, let's say, 5,000 lines? 5,000 lines, and let's say each line consists of 10 words, right? And then this will be, or 10 or 8 words, and then this will be 5K, 50K words. 50K words is approximately equal to one. If we say one word equal to one token, it's 50K tokens. Now just tell me, do you think the entire cloud.md is loaded at once into the context? Is the entire cloud.md always loaded into the context? So there are two issues here. Okay, first of all, cloud.md should not be 5,000 lines. It should be something like 200 to 500 lines, not more than that. That's the first thing. And even then, let's say each line is like 5 to 10 words. This can be anywhere between maybe 2K to or 1K to 3K words, which is 1K to 3K tokens approximately. One word is, I mean, each token is 3/4 of a word. So that is one thing. This we should follow. Second thing is cloud.md is not entirely loaded all at once. Okay, that is something we should understand. What is usually done is parts of cloud.md, which are the most important, are always loaded. The remaining parts are loaded as and when is needed. And how do you do that? So which parts will always be loaded? If there are parts which mention about rules, that will always be loaded into the context for every single API call. But which are the parts which may not be loaded always? So let us look at this cloud.md. Let's say we are working on phase 1. Do we have to load this phase 2 description, or do we have to load something which describes phase 3 if there is a phase 3? It need not be loaded. So what is usually done is to pick the relevant sections from Cloud Code, either we can use RAG. So cloud.md is converted into chunks. Chunks are converted, stored in a vector database, and then users query along with the rest of the context is converted into vectors, and then those vectors are compared against the embedded vectors, and then relevant portions from the or relevant chunks from the cloud.md are fetched and they are passed into the final context. That is if you want to use RAG. There is an even simpler approach, right? Even simpler approach is just using keyword. So if you are currently working in phase 1 using keyword matching, you can figure out that a section that comes under this triple hash. So that's the reason why this markdown document format is very useful, because anything that comes under this heading, this triple hash means it's a heading of style. Let me show you. Of this style, phase 1 single user MVP. So anything that comes under this heading is one section. So then if I use keyword matching, I can just simply load this section fully when I'm working on phase 1. I can ignore everything else, right? So this is how you ensure that your context is not, every single API call is not unnecessarily costing you a lot of money if cloud.md has a lot of details which you don't have to use every single time, right? There is a question, Cloud Code internally must be doing RAG. We did not have to do it. Exactly. We don't have to internally implement, we don't have to explicitly implement it. It's already implemented internally. So these are some examples of too high or too vague commands and too low or too brittle commands. So if it's about customer pricing, be helpful with pricing questions, extremely vague. But if you mention the exact pricing, like $299, $29.99 or $9.99, it's also too specific. What you should ask is when what you should write is, when asked about pricing, check the pricing database first. If no exact match, suggest the closest plan. Again, look at this, handle errors gracefully. Very vague. If you get orders, if get orders, order function returned 404, order not found, please check the order number and try again. This is again too specific and too brittle, because this is not the only error that can occur when the get order function is called. When a tool call fails, explain what happened in plain language, suggest one alternative, right? So these right altitude is something like you are neither too specific and nor vague. I know one thing which I often use in a vague way. I sometimes say, do not hallucinate. Then I myself keep thinking I am talking about context engineering and I am writing the most vague thing which you can ever write, right? So I'm sure all of us have some habits like that. It's completely useless. It doesn't matter if we say don't hallucinate. It's not useful at all. So just keep this in mind when you are constructing any sort of instructions for the large language model in the context. So now we already discussed some of these things about system prompt organization. So actually there are two formats in which system prompt can be organized. So ideally, Claude apparently prefers, this is not something which I have tried myself and tested. I don't have results to show. But based on my reading, what I have understood is that Claude typically prefers XML documents with these tags. So anything under the identity section will be coming under this opening and closing tag. So this is the identity opening tag, closing tag, opening tag, closing tag, right? This is one option. Second option is the markdown file. And in general, the general consensus is that although such a preference is mentioned in certain documentation, the difference between using an XML document and using a markdown document, so cloud.md document, is not at all remarkable or not really perceivable. And for some reasons, many other models typically prefer markdown files. So, okay, there is one question: is Claude.md the right file name or agent.md? I'll come to that. They are two different files. I'll come to what's the difference between Claude.md and agent.md. So the format that, in my opinion, which you should use is not XML. Just go with markdown file so that it's a little bit more universal, and there is no perceivable difference in the quality of output. And this is also structured. The hash will tell that everything coming under everything after hash in the same line is a heading. Everything coming under that is coming under that heading until you encounter another hashed statement, which is another heading. If there are double hash, that's the next hierarchy of heading. If it is triple hash, that is the next hierarchy of heading. So the same thing which you can construct using this XML document, you can also construct using Markdown document. All right. Then there is another idea which usually we don't follow that much, is start minimal and then keep adding into the Claude.md document. I'll show you one example of what it means. So let's say we are building a customer support agent. Okay. What I earlier mentioned was, okay, there is one question. I was planning to read that XML is preferred. That is one additional thing to remember. Yeah. It's not at all something which will break your model or anything. You can continue using Claude.md or Markdown files. So one thing which I rarely follow, but which is something that is preferred, is building the Claude.md file in a sequence of few steps. So what they say is, if you define all the rules at once, what may happen is, if you have 10 different rules which you have defined, or 20 different rules, what may happen is rule number 1 and rule number 20 may contradict each other. It can happen when you tell so many constraints, some of the constraints might be contradictory. So what is the general way of constructing the Claude.md file is, do not mention every single rule, mention one or few at a time. Then after mentioning a few at a time, try building and see what are the issues in your development. And then based on the issues, build the Claude.md file until a point where you are satisfied with it. And then once that level is reached, use that Claude.md file as your file for the rest of your building process. So this is an example. This figure is showing you an example. Let's say we are building a customer support agent for Shopco, a random company name. And you will start with a minimal prompt. Minimal prompt is something like this: you are a customer support agent for Shopco. That's it, a minimal prompt. Then this prompt will introduce some failure. The failure might be on a return policy. The model might hallucinate saying something like, hey, as a customer, you are eligible for return. Here is the return after 1 day or after 30 days. But then you will realize that, oh, that is not ideal. The model has to look at the policy document before taking a decision. Then what do? You add one additional sentence: use the provided tools for actions. Do not guess. If you just added do not guess, it will not be very helpful. You have to say, and this is a very simplified prompt. Okay. Obviously, the Claude.md will not be simple like this. It will say which tools you should look at if you want to look at the policy document. So use the provided tools for actions. And if you have any doubt about return policy, look at the return policy document. Do not guess the return policy. And then you will run again. And then when you run again, this time it may approve a refund. This is another failure. It may approve a refund outside the window. Then you will say, okay, this is the first initial prompt, minimum prompt, which you had already given. Then this was the second prompt which you had added. Use the provided tools for actions. Do not guess. Then last thing which you have added is returns must be done within 30 days window. Then again, when you run, you may say like process damaged item as a standard return. Then you will have to add something like damaged item require different routing. So the good thing about doing something like this is you are less likely to add something contradictory in your own the base document. Whereas if you add everything like what I have done here, you may end up contradicting yourself, which is very likely. So I have already read my Claude.md for my AI development tracker website throughout. And I hope there is no contradiction here because I have read through this once. So the least which you can do is either iterate and build like what the start minimal, then add policy says, or build the Claude.md file and don't be lazy. Read through it once properly. Okay. Make sure that there are no contradictions. Make sure that rules are not contradicting each other. Sometimes user preferences may contradict the rules. Like to give an example, the rule may say the refund should be done, the refund window must be within 30 days. But then in the user preferences, the user might have said something like, if a customer is asking for refund, um, always check the legitimacy of the case, and always, if it is legitimate, provide the refund. But then the model will get confused. The model will not know what to do. I mean, it will take an action, but then it's not clear, right? Should it follow the refund policy or should it follow the user's instruction? So you should construct this in a sequential way. We will do this in one of the exercises today. And these are some of the configuration files that other platforms use. So in cloud.md is there. You might have one question. If you are using, let's say, Codex, can cloud.md work? Cloud.md is not by default referred to in Codex, but you can create similar markdown files which Codex uses. Or in Cursor, you can use .cursor/rules. In GitHub Copilot also, copilot instructions.md you can create. This I am yet to come to. Agents.md I am yet to come to. Okay, so this we will see. So Shamim is asking anything for Kimi. So Kimi, you are asking specific to the Kimi model. Is that what you're asking? Kimi K2 or something like that? Um, so by default, we're not talking about models, right? So here in Claude, it's mostly Anthropic's models, but in Cursor, you can use different models. In Copilot, you can use different models. In Windsurf also, you can use different models. So if you are using these model agnostic coding platforms, then I'm pretty sure it does not change. It need not be Kimi specific. However, if you are using Claude.md, ideally it is best suited for Anthropic's models. It's not best suited for Kimi or Quen or other models, right? So if you are using those models, and for coding agent you are using Cursor or let's say Windsurf or Copilot, then for sure I don't think you need to make any extra changes. You can follow whatever the general rule is. If you want to store something in Copilot instructions.md, I'm not an expert in this, but I am an expert in this and this. I can talk about that more. GitHub Copilot I have used extensively, but I have realized that one thing, that the way in which Copilot handles context is not as good as Cloud Code handles context. In Cloud Code, it has a global context because there is a file which it installs, something like //cloud. Okay, this is something like a global file, but then there is also a file which is local, which you will see after you install, like /.cloud. So I can show you my cloud file if it is there in this. For example, this is my .cloud file, okay, and this is my agents file. So inside, okay, I'll come to the .agents in a little bit. Why is there nothing related to Gemini? Same, because the coding agents, see, we have to understand two differences. Coding agent is different, LLM is different, right? Gemini has different LLMs. Kimi is a LLM, Quen LLM, Opus 4.6 is an LLM. So right now, the Claude Code is not an LLM. Claude Code is a coding agent which is built on top of LLMs by Anthropic. You can use Opus, Sonnet, or Haiku, any LLM within the suite of LLMs provided in Anthropic. Now the question is, there are two questions here: which LLM is the best, and which coding agent is the best? So in my opinion, right now, among all the existing coding agents, Cloud Code or Codex are the best. Rest of the coding agents you can try, but I'm not sure how advanced they are compared to these two. Also, for fair reasons, these two companies are like, I think OpenAI is now $800 billion, and Anthropic is, I think, somewhere close to $350 billion or $400 billion. Of course, they have a lot more resources than other companies to build. I don't know whether Google offers something as good as these, but my opinion is, if you want to use other large language models and not Anthropic or not OpenAI models, yes, go ahead with Windsurf or Copilot or Cursor, does not matter. But if you are anyway going with Anthropic models or OpenAI models, go with Codex or go with Cloud Code. Now, so you might have a question like, what is universal? If Claude.md is not universal, what is universal? One thing that is universal is this agents.md. So it is emerging as a universal standard simply because Linux Foundation has pioneered it and they are mainly open source. So agents.md structure is the following. I will show you one example in my document. So here there is a dot agent, and inside this dot agent, I don't have agents.md here, but I have skill.md. So what these define is these are sub agents with different skills. So agents.md, earlier somebody had asked what's the difference between cloud.md and agents.md. You can have so many different agents.md folders which define what each of the sub agents do. So if you have agent number A, which performs a broader level task, let's say you are writing a research paper. Okay. Let's say you have a research paper writing agent with its own agents.md file, which orchestrates your entire research activity. But you could have a sub agent inside this, which has only ability to write. So you will have a writing agent who will have its own agents.md file. And what will happen is, now this agent is the way your folder structure is defined will be such that for your overall research, your agents.md will be here. Inside this, you will have a folder called, let's say, writing. Inside the writing folder, you will have its own agents.md file. What will happen is you will have defined bunch of instructions in this agents.md, right? And you will have another set of instruction in this agents.md. What has happened is this and this both will be utilized in the context. And whatever is mentioned in this specific instruction, if it is conflicting with this for whatever reason, whatever is mentioned in this in the lowest point of hierarchy, that will be utilized. For example, this agents.md is utilized only while writing, right? So when you are writing, something that is mentioned in this agents.md and something that mentioned in this agents.md, if they are kind of conflicting or something, instructions provided by this is used. But if nothing is conflicting, instructions provided in both are used. So agents.md, you will define multiple because you will have multiple sub agents for executing one single task. You could have a sub agent for writing. You could have a sub agent for making figures. You could have a sub agent for executing code or going to run pod and executing the code. You will have a sub agent for analyzing the files, right? And maybe there could be another agent which orchestrates both of this, writing the code as well as analyzing the results. You could have an orchestrator sub agent. So agent is like if you think of it, it's like a tree. There is a master agent which orchestrates everything. Under this, you could have 4 different agents with its own context. And under maybe this agent, there could be 2 other sub agents with its own context. And these agent.md, just like Claude.md, will define what this agent is supposed to do, right? Now, what is the difference now between agent.md and skill.md? I will show you the skill.md. Let's go to a skill for this front-end patterns, okay? So I will show you the skill.md file for this. So this will define the skills that the model should have in natural language when it comes to front-end development. So here it simply talks about what are some preferences. So you yourself can create the skill.md by saying, I prefer modern styled website. I don't like thick fonts. I generally like to use thin font which are elongated. Or you can say something like use Next.js instead of React.js. You can mention all these preferences here to create the skill.md. You can also mention no preferences. Still, skill.md can be created by Cloud Code. One more option you have is this skills.sh or something. There is a website which is like a marketplace for many different skills. There was one more website which I was frequently using to download skills directly from internet. Place for agents. I'm not sure if it is this. Yeah, this one. So this is also another good one. So if you want to find a skill while building, let's say, to give an example, let's say you are making an agent for making figures using paper. So maybe, or you for a PowerPoint presentation. So then you can search PowerPoint here and it should ideally load. I'm sure there are some skills that are written for PowerPoint specific. So automating PowerPoint.md. So see, this is a markdown document. Let me just verify. So this is a markdown document which you can directly install using this npx skills command, or you can download and add it manually to your workspace. Or if you are using Manus agent, you can directly run this. But basically, the good thing is here you will see stars and upvotes, knowing how popular this particular skill is. So if you look at some skills like front end, you will see that large number of upvotes are there or stars are there. Where do I go back? So this link I will just share in the chat once. Just check this. So this is one way in which you can, directly get the skills which other people have defined. There is one more GitHub repo which I want to show you, which will be very, very helpful to you. It's called Everything Cloud Code. So this GitHub, this has, I think, 50K stars or something like that. Yeah, 69K now. So this GitHub was created by, I think, somebody, I think I'm referring to the correct GitHub repo, somebody who won a hackathon. And yeah, so this was created by some person, and now it is maintained by, I think, more than one people. Basically, one thing you can do is in any GitHub, any Cloud Code project, you can install this. And then what will happen is this everything Cloud Code will get installed inside your working directory, as you can see here. So this I did not create myself. I took it from this GitHub repo. I forked it, and then, or I directly used this command rather. There is this command mentioned to install the plugin, and that plugin will appear in your working directory. Now, the usual convention is my working directory is actually this AI developments tracker. It is not everything Cloud Code. So the usual convention is your .agents and .cloud, everything should ideally be over here, immediately inside the working directory, not inside a subdirectory. But I have explicitly mentioned in my markdown files that the skills and .agents, everything can be found inside this subdirectory. I have mentioned it explicitly, because of which, if any skills are needed, Cloud Code can refer to these skills, API design or article writing, backend, or any skill, right? But otherwise, by default, Cloud will look at .cloud folder, .cloud file over here itself, which will be like a hidden folder. You will not be directly seeing it if you open it in a Finder. Where did you mention this in cloud.md? I think it is mentioned. Let me just check where it is saved. I think it is not stored in my cloud.md related to this particular project. I think it is saved, that preference is stored in my global cloud.md file. So there are two cloud.mds any project will refer to. One is the project specific cloud.md. Second is the global cloud.md, which will apply to all the projects. So some skills you may want to apply to all the projects. For example, if it's a web development skill, why would you restrict it to just one project? It can be applied to all the projects. So you can install it in such a way that it is applied to all the projects. The best way to do that is, in my case, I have one folder called, I'll show you on my Miro board. So I have one folder called AI agents, which acts as my parent working directory. Okay. Inside this, I have different projects. So inside this, I may have a project called, let's say, LLM context engineering, or I may have another project called AI developments tracker. So in this AI agents folder, I will have a .cloud.md file, which will define my preferences, and a folder inside which there will be a cloud.md file. Similarly, inside this also .cloud will be there, inside which there will be cloud.md. Now this cloud.md and whatever skill.md I'm defining inside this working directory is specific to this working directory. So if I define some writing skills or email skills or whatever, it will not get universally applied. But whatever I apply in my master directory, master working directory, will get applied universally for all the projects. So some skills, if some writing preferences or something you are mentioning, I don't want my writing preferences to be mentioned in all my projects. I want it to be project specific. So I will not mention any writing related skill.md files in my master working directory. I will only mention it in my project specific working directory. So these are just conventions. You guys can figure out if you don't want to follow that convention and still get something useful out of it. Okay, this we have covered. Anatomy of, okay, by the way, agents.md and cloud.md should follow similar things. In agents.md, there will be very explicit mention of the tools. In cloud.md also, there are broad mentions of the tools, but in agents.md, because agent is literally meant for accessing tools and executing certain functions, agents.md will have a lot more emphasis on specific tools. This is one diagram which I wanted to show you the order in which things may disappear from your context. So think about output from RAG, okay? Output from RAG is extremely dynamic. It does not appear after 2 or 3 iterations of API calls of the LLM, because RAG output depends on the current context. So RAG output will live only for a few seconds, whatever output you get. So that contribution of RAG output to the context is very short-lived. On the other hand, as I mentioned earlier, cloud.md or agents.md literally will be there unchanged in your working directory from weeks to months. So in my case, okay, there is one question. Cloud Code will leverage both agents.md and cloud.md. Yes, exactly. It has both. Sometimes you will notice that when you are running a big project, Cloud Code will automatically spin subagents. Sometimes you can define your own subagents, and sometimes it will spin its own subagent. Now, can I ask you a question? Will subagent have its own context window, or will it utilize the context window which is same as its parent, the parent agent who spun the subagent? Will they share the context window, or will it have its own context window? So just think about it. Why are we first of all, what is an agent? An agent has its own ability to make its own API call to the LLM. It has its own ability to access files separately and produce outputs that purely depend on its own context. So a sub-agent ideally will have its own context window. It will make a separate API call, and think about it. For each API call, we are providing the context, right? And which means if an agent is a pure paper writing agent, why should that agent share the context with a coding agent? It's not needed. So the whole idea when we say agents are being, this we will discuss more in detail when we comes to the tool section, which is day after tomorrow. But when we are spinning new agents, the idea is that that agent should have ability to execute its own API call of the same LLM, right? And handle its own context window, so that agent's actions are not polluted by what is happening globally in the project. So globally, if the research is progressing in a certain direction, that should not affect a particular agent's ability to analyze a particular result, right? So sub agents will always have its own context window, but some items will be shared between the context window, because, for example, cloud.md will always be there accessible to every single agent. Then if there are things like specifications of features, so I had mentioned my feature specifications, and then it created certain skill.md files based on my feature specifications, right? But those skill.md files kept on getting modified as I asked for more and more features or more and more different skills my AI news tracker should have. So the lifespan, this is very correct actually. Hours to days is actually something that I have observed in my execution. The skill.md file may stay for hours. Some skill.md file will stay for days, but it can get heavily modified as we ask for more and more specification and more skills. Implementation plan is hours to days. So implementation plan, there is one thing here. This implementation plan, there is a broader level phase 1, phase 2 implementation plan mentioned in cloud.md. So here, if I go back to AI developments tracker, this cloud.md has a phase 1 implementation plan, then phase 2 multi-user implementation plan, right? So this was remaining constant throughout. But however, I created different set of markdown files called app feedback v1.md. So here what I did is, in natural language, just by speaking, I created these instructions based on what the app is looking at currently. So this app feedback v1.md will spin off its own different phases. So then it will decide, okay, I am in phase 1 right now, but I have to implement phase 1A, phase 1B, phase 1C. So it's a new implementation plan. And the life of that new implementation plan will depend on what your current feedback is, what features are you focusing right now, etc. Again, its time span is hours to days. And then as I keep on giving different feedback at different levels of my product development, no, app feedback.md is not a skill. Skills are usually stored in skill.md. App feedback v1.md is my own document, which I created. You know why I created? Because if I'm giving this much feedback, I might as well store it somewhere rather than giving it in terminal. Because if I give it in terminal, after some time, it's gone. But this way, all my preferences and all my feedback is stored in these markdown files. Sometimes my feedback in V1 may conflict with something in V5, but later, once my building is completely done, I'm planning to ask Cloud Code to create a master feedback document using all my 5 feedbacks documents. And that so to create the master feedback document, I need all my feedbacks which I have given in all different stages, right? So that's the only reason why I created this MD file. What are we achieving with separating everything? So actually, yeah, I think this was a mistake on my end. I don't think separating the everything Cloud Code is a good practice. Ideally, what we should do is just have all these folders within the working directory. So that is better, right? We are not achieving anything, I think, by separating. This was the only reason was because when I installed installed the plugin, it ended up installing it in this way. And then I went ahead creating my cloud.md. And then I realized that, oh, my .cloud and .agents are actually inside a subdirectory. Now, should I move it back or should I continue building? Then I continued building, but I ensured that Cloud is referring to the .cloud in this subfolder and .agents in this subfolder, right? But we are not achieving anything by separating these two. Oh, there is actually one more file which I think you should know about. There is another file called soul.md. This is something which, if you have been reading on x.com, many people talk about soul. The difference between your output when you have a soul.md versus when you don't have a soul.md is night and day. It's highly different. So in Cloud Code, I don't specifically use sol.md because my cloud.md itself is doing the function of sol.md. But in general, if you're working on OpenClaw or other frameworks, just remember to put a sol.md and put what your agent is supposed to be like, the details of that in the sol.md. The difference is extremely humongous. Okay, one last thing, then we can get into the exercise, is about classification tasks, reasoning task, or some other structured output task. Okay, so 3 tasks I have mentioned here because in cloud.md, it's a good practice to mention some examples. So let's say you are performing a classification. Let's say you are building an email classification into whether an incoming email should go into your primary inbox or whether your incoming email should go into the rest of the inbox, like social updates or anything else. Now, this is a sort of like a binary email classifier. Now, for this classifier to work in cloud.md, it will be very beneficial if you add 3 different examples, 3 diverse examples. So when I say diverse, show one example of an email that actually belongs to the primary inbox. Show another example of an email that actually belongs to social inbox or update inbox. Or if it's about a product review, show one example of positive review, one example of negative, one example of neutral. Basically, just giving total up to 3 examples covering diverse set of cases. You can give more examples, but in general, there is a huge diminishing return because if you add more examples, those examples are now consuming your context window. It is loaded frequently. You don't want that. But if your task is a very simple classification task, this is enough. But if your task involves quite a bit of reasoning, so a reasoning example is whether you want to approve a refund or whether you want to approve some sort of returns, something that involves policy, etc., you should provide some reasoning example. So this is the reasoning example. Customer ordered laptop 45 days ago, and the reasoning for the output is 45 days is greater than the 15-day window, which means it's not eligible for return, right? Return or refund. So now this is not like input and output. So this is input, reason, and output. And you can give 2 or 3 such examples. If you need your agent to execute a complex task. Now, what if your agent requires a specific format of response like JSON or something like that? The best thing is you yourself provide some example of what kind of format you are expecting. Provide a provide some sample JSON objects in your cloud code so that it can follow that. One good example here is of the format is in my project. You can see um, so here, this folder structure, we don't have to explicitly mention this format. Yeah, see, this folder structure, we don't actually have to explicitly mention this format because this is something that most LLMs already know. But by giving this format, we are kind of reinforcing the structure of this whole project that I want to follow. And I'm reinforcing that apart from cloud.md, ideas v2.md is there, which means if I'm referring to ideas v2.md at the top of the document, my cloud code will not get confused now, not knowing where this ideas v2.md is. It already knows because I'm providing the structure, right? Um, there is one question. These examples can be specified in agents.md, each subagent instead of defining in cloud.md. So some 2 or 3 examples you have to mention in cloud.md. And this example, I mean, it can depend on the task, by the way. If the only task that your cloud code is doing is building an agent for responding, you can mention this in cloud.md. But if these things are part of one sub agent's task, so within an email response agent, let's say one agent is assigned explicitly to classify the email, another agent is assigned explicitly to produce response for an email. If such sub agents are there, in that case, yes, you can mention the examples in agent.md rather than in cloud.md. All right. Um, Okay, now we'll move on to the exercise very quickly, but I just want to show you one example of a poorly designed cloud.md, and I want you to tell me why is this poor. You are a full stack developer, a full stack engineer. This is this. So I'm mentioning the identity sort of, right? I'm mentioning some sort of rules. I am mentioning, I mean, these are some rules. This is in the boundary between rules and knowledge. I'm mentioning some structure, but what is in general the format problem with this whole document? You can see that it's a little bit vague, right? Because it's not leveraging anything about the markdown structure. This might as well be like a cloud.txt. There is no difference because it's not leveraging the fact that there are headings or subheadings. It's neither in XML format, and the details are completely vague. You should see this one. You should design the architecture properly. What does this mean? This doesn't mean anything. This is exactly the kind of instructions that maybe 95% of the people actually give, right? It's like me telling the model don't hallucinate. So this is a very, very vague instruction. A better designed thing will be you will have headings, subheadings, and within subheadings, if there are further subheadings that should be given, and the technology stack, make it explicit. If you want explicitly Next.js to be used instead of React.js, if you want to use Tailwind CSS instead of something else, and deployment, if you want to do in Vercel, not in Railway, mention that, right? And then this, if you do, your issue is that cloud.md file may become bigger, but it will save you a lot of pain downstream. And in any case, cloud.md file is not going to be entirely fetched all at once, right? So this is an example of poorly designed and well-designed cloud.md. Now let's move into an exercise. So I will share a link with all of you. And here, just paste the API key. I don't have the API key yet. So I have created my own vault for storing my API keys just for quickly referencing. So I'll use one of these Gemini API keys. All right. So now here is we have 3 tasks here. First task is we will sequentially construct a cloud.md file. Okay. Sequentially construct meaning we will define the identity, we will define the rules, we will define some of the knowledge, we will define examples, etc. Yes, I will share the Colab notebook also. So this is the corresponding Google Colab notebook. But as usual, I will, since many people are like product managers and coming from low coding background, I will go through the interactive website. So this is the Google Colab. Again, you will need Anthropic, OpenAI, OpenAI, Anthropic, or Gemini API key. Just you can store it in the env file over here. So this key icon you see, you click that, and here you can add the secret key. So either if it is a Gemini API key, just add it here and just enable it like this by clicking this button. This is the best way to store the API key in for usage in Google Colab. So here, this is the task, okay? We need to create a student grade calculator. Let me just annotate. So this has to follow a certain structure. So when I'm building this calculator, I don't want to use fraction format. I don't want to store numbers as 0.3. I want internally Python to represent it as 3 by 10 or whatever the fraction is. So Python has to follow decimal format instead of following floating point. Then certain constraints like use a lookup table to assign letter grades. So letter grades like A, B, C, D, and then return results as grade reports, or then use, if you want to export the final grades of the students into a CSV file format, use csv.writer, not string concatenation. So there are some specific details I want to follow while building this. So don't get hung up on the details. It's not important. What is important is how the difference look like when you use cloud.md versus when you don't use cloud.md. Okay, so let's see that. So firstly, if you don't have cloud.md, what would be your prompt? Your prompt will be asking a simple user prompt asking LLM to write a grade calculation function, which takes students' marks, and then it should produce a grade score, right? So it'll be like a very simple 1 or 2 or 3 line prompt. But if in presence of cloud.md, you are providing more details. So what I want you to do is, I don't want you to just manually type these things. I have made your life a bit easy. You have a solution button here. Just click this solution. It should automatically populate the project overview, project structure, etc. So project overview is this: a student grade calculator that computes weighted final grades, assigned letter grades, and exports results in CSV format, so and so. Okay. Project structure is the folder structure of your project. So in your SRC, there will be a calculator.py, inside which there will be a calculate final grade function. There is a models.py and so on. So this is the details of the project structure, folder structure of the project. Then some conventions or rule which are provided in our problem statement, I am adding here. All grade uses decimal format, not floating point. Then determine the grades by using the grades cutoff and use the lookup table. Then return the grades in grade report data class, CSV export using csv.writer, etc. Similarly, in testing requirement, I have mentioned some details, some of which are knowledge, some of which are rules. And one thing I notice is that like some things are repeated multiple times, like do not use float grade for grade calculation, use decimal for precision. This is already mentioned in the, I think, in code conventions themselves. But this is how the full cloud.md will look like if I add each of these sections. Project overview, which is identity; project structure, which is the structure that defines the output; code conventions will define some sort of rules and knowledge. So here is the boundary between knowledge and rules. Testing requirements will again define knowledge and rules. And tools, where are my tools? Here some tools are defined. This grade cutoffs is like a tool. Then a data class, this is usage of a tool. Then csv.writer is again mention of a specific tool. And here also some rules are mentioned. So in this important patterns, you will see a combination of rules, tools, and knowledge. And this is purely, this section is what? Common mistakes to avoid is what? Is it knowledge or is it rules? This is purely rules, right? So this markdown file will be passed along with, if cloud.md file is used, it will be passed along with the prompt to the LLM. Okay, LLM, which LLM is used? I'll be using Gemini. I think 2.5 Gemini Flash 2.5 Flash. So now let's run the code with and without markdown file. I hope this works. I hope it does not hit any API limit or something. Did you guys manage to run this with your API? If you got any output, it compares the output at the end. So I want to show you that also. If any of you manage to get the output, just show me a screenshot. It should show a score out of 25. In the absence of markdown file, how does the output quantitatively look like in terms of a score? How does it look like in the presence of markdown file? So this markdown file is consuming 439 tokens. Okay. Can you add input field for Cloud API? Yes. So you have Shivaram, you have an Anthropic API key available to you. I can add a Anthropic option also. The only reason I did not add is because I don't have an Anthropic API key at the moment. I use Cloud Code, but I don't have Anthropic API key. Okay. So Amit, David, okay, 10 out of 25 versus 25 out of 25. For some reason, my API call is taking too long. I don't know why. Okay, glad to know that you guys are getting it fast. So I think mine is running a bit slow. I have no idea why it is so slow. Okay, okay. So one issue that happened earlier was when I had deployed this on Vercel, and okay, so see, now this is the score breakdown. So this time for calculating these scores, I am not using an LLM as a judge. For this, I am simply using keyword based matching my requirements, and then the output will have a set of keywords. So this is the output with cloud.md provided. Okay, output is much longer and much detailed, and this is the output without cloud.md. If you want to see how the prompt provided to the LLM looks like, you can scroll down and click this. We view the full prompt sent to the LLM. So this is the prompt sent to the LLM in the absence of cloud.md. It's too small, it's too vague, not at all specific. So there is no doubt that the LLM will not be performing as good. In this case, the consumption of tokens is like extra 439 tokens are being consumed. There is a question, did we ask Cloud to generate cloud.md from natural language? You mean in this case? In this case, I have already, what I have done is this show solution button, right? I have already hard coded a good cloud.md structure that was created using, I think, Gemini itself, not Cloud Code. And then I just enabled this button click so that with a button click, you can add the different subsections of the cloud.md into these project structure, testing requirements parts. And then the whole cloud.md file is basically a concatenation of these different subsections, which is what you see here. And then the prompt in the presence of cloud.md will look over here at the bottom, very long. And here the user message will come at the very end. So this is the user message, write a Python function with so and so. Everything before that is what is there in the cloud.md. So here, basically, the prompt that we are passing to the LLM is concatenation of two things, concatenation of stuff that are put into the cloud.md, and with that concatenated with things that are there in the user prompt. So when you are hitting Gemini API, are you just passing the content from cloud.md as the prompt? Exactly. So I'm passing this whole thing as the message to the LLM. This whole thing, the cloud.md info plus the user prompt. User prompt is write a Python function, calculate final grade that computes weighted average of the scores from the scores dictionary and weights dictionary, determines the letter grade, and returns the result. That's it. There is no mention about the specific format of CSV export or anything. I'm just saying I need the result in a CSV format. So may I know if we can access the lab as lifetime? Yeah, you can access the lab lifetime. Only thing is you will have to use your own API, your own API key. Now let's move on to the next lab. This is just to show you the difference when you use cloud.md and with and without cloud.md. It's obvious, right? I mean, if you don't provide enough details, of course your output is not going to be really good. You already know that. So, but this is just to show it quantitatively. We can now move on to phase 2. So in this phase 2, let me just refresh. Okay, I think most of you got higher scores in the second case, right? With cloud.md, you got probably 20 or 25. The scores will vary, of course, it's an LLM. But I think most of you might have gotten higher score in general when you used cloud.md instead of not using. Now here, this is a different example, okay? We are not talking about the student exams anymore. we are talking about, one more thing, by the way, guys. Some students had messaged me yesterday saying the timing of the lecture is a little bit long because in the US time zone, now it's late night, 11 p.m. or something in some of the time zones in the US. So one thing I must say already that I think most of the lectures might take more than 1 hour simply because some topics we have to go a little bit deep. So what I'm planning to do is I will try to finish as much as possible by, oh, it's 1:30 a.m. Okay. Oh my God. I don't know what time zones you guys are in, but hats off to you if you are trying to work or study at 1:30 a.m. Amazing, guys. Um, yeah, so it's like it's a problem with many different time zones. Bunch of the folks are from EST, bunch of the folks are from Central Time Zone, IST, UK. So it's like a bit of a challenge. But that's the reason why I'm putting the recording as fast as possible, so that in case we want to drop off and watch it next day morning, you can do that. Okay, so here the issue is this: we have a chatbot, and that chatbot's response need to be graded on 10 different questions. So these are the 10 questions. Okay. I want to return my laptop. This is the order ID. So if this is the question that customer is asking, ideally chatbot should not immediately give a response, right? Ideally, this is the grading criteria. So chatbot should first say that let me look at the order first, and then let me look at the return policy. Then looking at then guessing the return policy, right? So this is one thing. Second thing is, what's the price of new MacBook Pro? Then it should not hallucinate. It should look at the price table or something and then come back. Then I'm going to sue you if you don't fix this right now. Should de-escalate the situation. And so and so. So these are some issues which you are going to ask the chatbot, and chatbot should be responding. And based on this instruction, we are going to grade the chatbot's response. Now let's see, when we are building the cloud.md file sequentially, like one after the other, what will happen? So first is round one, which is a minimal prompt. So you can click this show solution to add a minimal prompt in cloud.md. So this is just the identity. If you are a customer support agent for Cloud Store, an online electronics retailer, help customers with orders, returns, etc. Be friendly and professional, right? And let's see how the minimal identity prompt will help you help the chatbot score for the 10 queries. So 10 queries are done. If you want to see the scores, go back and scroll down. So in the 10 queries, actually it has scored pretty well. So I want to return my laptop. Either I can definitely help you with returning your laptop. To start the process, you will have a couple of options. Okay, you know why this output is only partly displayed here? Any idea why this is the case? You can only see so much, right? Because I have manually defined a cap for the maximum token limit for each response, so that chatbot will not give a paragraph response. So that is the main reason. So the input plus output should not exceed a certain limit. There might be one problem which I might have to fix here, because in round 4 we are adding more details, but let's see what's the case. So for 2 questions, it's not answering in the correct way. But for the rest of the questions, it's kind of following our guidelines. Now in round 2, we will add one more detail, which are critical rules. So in round 1, it was simply talking about the empathy factor and the identity factor. In round 2, I have mentioned certain critical rules. So these critical rules will hopefully help the chatbot to take better decisions. But let's see, because I have capped my number of tokens, whether the output is becoming weird or not so good or not. See, it's only 8 out of 10. So you know what we should do here to make the output better, or to make the scoring a bit more fair? What I should ideally do is I should increase the number of tokens from whatever the cap is right now to maybe uncapped. So that I will do. And in the last part, I will jump to R4, because I also want to show you one quiz. So here, if you click show solution in round 4, 3 things are added. You are a customer support agent. These are the critical rules. This is the tone in which you should speak. And if there are specific issues that the customers are facing, this is how you should reroute, right? So these 3 things are explicitly mentioned. And when you run again, the problem might happen is that the input tokens plus output tokens are forming the context window. But here with the edge cases also added, the chatbot is scoring 10 out of 10. So all the questions are being addressed really, really nicely. So we skipped the round 3, but I urge you to try the round 3 also and just let me know what output you got. So ideally, you should see in round 1 with minimum. So in round 1, we just had minimum prompt in the cloud.md. In round 4, you had all the different instructions. As you go from round 1 to round 4, your score should ideally increase. Of course, sometimes it may decrease. I have noticed that when you go from round 1 to round 2, sometimes, or round 2 to round 3, sometimes the score decreases from 8 out of 10 to 7 out of 10. Not able to see R1 and R2 options. So to go to R1 and R2, you mean after running? If it is after running, just click it once more and then scroll down. If you want to progress from round 1 to round 2, you have to finish round 1, right? There might be some issue in the logic of button enabling or disabling. I will just fix it if there is an issue. The third example, which I want to show you, there is one interesting quiz also, which I want to take you through. But the third example is adding few shot intelligence. So few shot intelligence, in this case, we will start with no examples, some static examples, and dynamic examples. So static example simply means if you are providing 3 examples of what is a good behavior to the LLM, like this. So into the context, you provide example number 1, example number 2. Okay, round 1, 4 out of 10, 3 out of 10, 4. Oh, that's super weird. I will have to check why that is the case. And can you guys tell which LLM are you using? Which model are you using? Is it Gemini or is it OpenAI? GPT-4. Okay. That is weird. I don't know why. Maybe it is because of the truncation of the output. Okay, I can do one thing. I will increase the, I'll just first ensure that there is no truncation of the output and I'll increase the limits. And then hopefully you should get better response. So ideally what you should get is something like in round 1, very kind of low score, 6 or 7 out of 10. And eventually as we add more details into the MD file, the chatbot should be able to handle questions in a better way. But of course, the scores itself show that, LLM factor itself is coming in, but it should not be as bad as 3 out of 10. Okay, Sriharsha is sharing. Okay, Sriharsha's score is something similar to what I am getting. I'm also getting something very similar. Sriharsha, are you using Gemini or OpenAI API? Okay. I'm not sure why this issue is, but I'll have to investigate it. But this is ideally what should happen. Like as you add more details, your chatbot should become better at responding. So now talking about the examples, let's say we ask 5 questions to our chatbot. Okay, I want to return my monitor. Order number is this. I bought it 10 days ago. This is the first question, second question, third, fourth, and fifth. And we can run with no examples provided, meaning no example of how to respond to a query is provided in the markdown file. Then what will happen? So we are now running 5 queries and let's see the score. Okay, so let's go back to baseline. In baseline, this is the first question. This is how the first question was, and this is how the response was. Empathy was not so great. Action, it was not actionable, but it did not guess, and it stayed on the topic. If you want to see the full prompt that was actually passed to the LLM, you can click this. The system prompt is this: you are a customer support agent on an online retail seller. Help the customers with their questions, and then the user just give the first user prompt, which is this: I want to return my order number 3301. Okay, so this is the full prompt which we are passing into the LLM, and this is the full response which LLM gave. And this response scores out of 4 rubrics on which we are scoring the LLM. Only 2 are, it's working only for 2. Then my package was supposed to arrive 5 days ago. Still did not arrive. Same thing. The system prompt will remain the same. User prompt will vary. Here also system prompt will remain the same, and user prompt will vary. And please note that these are different API calls. Okay, so for different API calls, context window will be different. Now in static, okay, to click this, I have to first run the baseline. Okay, this is one issue I should fix. I should be able to freely jump from baseline to static. Okay, baseline 2.4 out of 4. Okay, so baseline is Almost done. Then let us run to static examples. Okay, now this is static example. So static examples are in different category. There is examples in returns category, in shipping category, product category, complaints category, account category, and in all. So if you are picking three examples, would you pick all the three from returns, or all the three from shipping, or all the three from products, or would you pick it from different sections? If you are only allowed to pick three, you should ideally pick such that diversity is maximized. That's how LLM can have maximum knowledge about different situations it may encounter. So ideally, if you are picking one from returns, do not pick one from returns again. If you're picking one from shipping, do not pick from shipping, so on. So here three are picked: one from returns, one from shipping, and one from complaints. And then we can run static. Basically, run static meaning in the prompt which we send to the LLM, three things will be there. System prompt will be there along with examples. Then user prompt will be there, which is the sentence, right? So now these are the scores. I should have displayed the system prompt button here also just to see how the prompt look like. But the prompt will look like the following. System prompt is, you are chatbot for this, be empathetic and helpful. Following that, the example will be concatenated. Then after that, you will have the user query, which is the question like this. Now here, I have not run the dynamic yet, I think. Oh, I have to go to the static, just a second. Okay. So here you can see 2.4 out of 4 average. So already, yes, I am displaying the scores here. So in static, these are the scores that I got. In no example, I got 2 out of 4 average score. Here it is 2.4 out of 4, slightly better. And this is the full prompt. This is the system prompt. Then examples of good responses, example 1, example 2, example 3. I am not sure if this is supposed to be user, okay, because user is not giving the example. I think this might be a mistake in the internal coding of how I'm displaying, how I am constructing the full prompt. Ideally, the example is part of the system prompt itself. It is there in the MD file. User is just giving this, the customer prompt. I want to return my monitor, order 3301. Okay. So, but look at the total prompt that is appended. It is appended thing about the identity plus static examples plus what the customer is asking, right? And then the full response is over here, and you can score the full response on these 4 rubrics. And in dynamic, let me check my score. In dynamic, I scored 2.8 out of 4. So I got 2 out of 4, 2.4 out of 4, 2.8 out of 4. How are the scores calculated? Good and bad, etc. Do you have API call? No, I don't have this time I don't have a judge LLM for API call. I am simply doing keyword matching. So keyword matching meaning in my baseline here, where is that? Or I think in the phase 2, I had mentioned how the responses should be, right? In phase 2, I had said, when you are crafting the response for returns, always look at the return document. Do not directly give a solution. So that the keywords in that command is matched with the keywords in the solution in the LLM response. And then based on that, a score is constructed. And using that score, I can say whether empathy factor was maintained or not, whether actionable response was provided or not, whether guess was made or not, or whether on topic, whether it stayed on topic or not. The even better way to do this is by using an LLM as a judge, but then often it is not needed. It's also expensive. Here it's not expensive. Here anyway, I'm running 4 examples, but here anyway, it's not an LLM judge. It's a keyword matching. Yesterday, we discussed about the LLM judge. I'm curious to know if any of you got a graph that looks sort of like this. Ideally, with more examples which are dynamic, you should have a better score. And what are the dynamic examples that we fixed? Look at this. When my question is about the returns, most of the examples are about returns. 2 examples are returns. One is about complaint. Whereas when I forgot my password and reset the email, then I don't know why this was part of I don't know why these 2 examples are provided. It's anyway showing 0% semantic match, but these 2, I don't know why it's appearing. So ideally, nothing like this should appear. Maybe it's because I am forcing the LLM to pick 3 examples. This also is not RAG. Here also, ideally it will be RAG, but here what I'm doing is keyword matching. So there is no vector database. I mean, keyword matching also you can call as some sort of retrieval, of course. But here I'm not using a vector database. Here I'm purely matching the keywords in the query with the keywords in the examples. And based on the matching of the keywords in the query and keywords in the examples, I am picking which are the best dynamic examples that suit the current situation. And those dynamic examples, along with the query and along with the system prompt, I'm passing to the LLM, and then LLM is producing the output. So right now, the scores are like this for me. I think many people might have gotten something similar. Did anyone get the reverse score? Okay, David, did you get reverse? You got best score in no example and worst score in dynamic. Is that the case? Sriharsha got okay. I have no idea, David, why it happened. It's amazing how variable LLM's output can be. Sriharsha seems to be getting very similar to what I'm getting. Um, this is the ideal. Okay, I'll tell you one more thing, one more experience from my me running these examples at different examples many times. One thing I have noticed is the LLMs of today are incredibly good, even in the absence of a good system prompt. Okay, and because of that, it's very hard to come up with examples which actually show your point. In general, if you use an LLM 1,000 times, you will form a mental model in your brain that, okay, I need better Claude.md or better system prompt for getting better output. But it's very hard to show that exact same thing for one example. When you pick one example, LLM can behave in such a way that sometimes the response it gives is already good, even in the absence of static or dynamic examples. Maybe that is why, David, you are getting the opposite of result. Like your dynamic case is the worst and baseline is the best. I am very curious to further look at why that is happening. If no relevant examples are there in case of dynamic, how and what would be the output? So in dynamic case, there are relevant examples. You mean, okay, in dynamic case, if 0 examples are provided in the example database, how would the output look like, right? In that case, output will look very similar to what the base output may look like in the case of baseline. In the case of baseline, LLM, if in the system prompt we have mentioned like if some policy or something like that is asked, don't hallucinate, look at the document, and then it looks at the document, no examples are provided, then hopefully it may not hallucinate. Maybe it will reply something like, unless specified, it may reply something like, I'm not so sure what the detail about this particular query is, or something like that. It depends on what other details have you provided in the system prompt. Phase 4 is just looking at all of this in one frame, but we don't have to go through that. We can go through. I just want to show you one last thing. Okay, this is a page which I have created just to show you how the cloud.md file sections are retrieved. So I asked you a question earlier, right? In cloud.md, is the whole md file passed as part of the prompt into the LLM, or only sections are passed? Actually, only sections are passed. So here, let's say my cloud.md file has 1,300 tokens. Okay, 1,300 tokens divided into 12 sections. So section about authentication, database, API design, logging, error handling, etc. And how will these sections look like? It will look like things coming under subheadings, correct? Now, if the task that the LLM is supposed to do right now is about, let's say, unit tests for user service, can you tell me, out of these subsections, which subsections will I be utilizing? Which subsections will be retrieved to be passed into the large language model? Is, let's say, database convention needed? Probably not. Testing standards might be needed. Unit test, maybe in the testing, if error, I don't know if error handling is needed or not. Performance guideline is not needed. Naming convention is not needed. Deployment and DevOps is probably not needed, right? So only out of these 12 sections, maybe 4 sections are needed. So let's click this retrieve relevant docs. See, only 4 sections are needed. Testing standards. Oh, actually, naming conventions is coming into the picture here. Maybe because something about the testing is provided here also. So this naming convention is now contributing 110 tokens. Each of these are roughly 110 tokens. So now look at the total number of tokens that are consumed. Instead of 1,300 tokens, it's roughly 100 multiplied by 4. Around 440 tokens are being consumed, right? And only these 4 subsections will be now passed into the context. Similarly, if we are asking about React form component, then maybe what we need is front-end architecture. We might need an API design if the form input is passed into some database. Something about database might be needed. Logging and monitoring, I'm not sure if we need. Security practices, yes. So let's run this and see what all sections will be probably used. Front-end architecture is the most obvious. Okay, error handling probably will be used in most of these because in every case some error can happen. You need some error handling mechanism. API design, if the form is the whatever you input you are putting into the form is sent as a JSON into an API function. Data validation is needed. So again, only 4 sections are being used. So then you can actually run the Cloud Code with the full context as well as with just the selectively retrieved context. Do you think in this particular example any difference will happen? Okay, again, there is a question. Who is selecting the sections? Sections are, again, as I mentioned earlier, like in the cloud.md file, I said if I'm working on phase 1, I will select only phase 1 based on keyword matching. So I can select it based on 2 things. So sections from cloud.md can be based on RAG, or it can be based on keyword matching. If it is RAG, I have to chop the cloud.md or agents.md into chunks. Chunks need to be stored in vector database. Then user query also needs to be converted into a vector. Then those vectors are compared using cosine similarity or some Euclidean distance or just dot product. And then when you compare the vectors, you may have top 3 or top 5. Then you may re-rank it, and then you will figure out which vector is or which vectors are closest to your user query. And what are those vectors? Those vectors are chunks from your document. And what are the chunks? Maybe the chunks are different sections. So chunking, how the chunks look like will depend on the chunking strategy. But if your chunking strategy is such that it's based on sections, this will be one chunk. Perhaps this will become another chunk, and so on, which means each vector, there will be one vector corresponding to each chunk. So if top 1 vectors are being used for when you are saying, hey, now let us implement phase 1, then in phase 1, the chunk corresponding to phase 1 is the vector corresponding to whatever this chunk looks like, right? So phase 1 will be converted to a chunk that will be stored as a vector. And when sorry guys, my Wi-Fi just got cut off. Can you hear me right now? Am I audible? Is my network okay? Okay. So where I left off is I was discussing about the chunks. So the way this retrieval happens in RAG is RAG will find the most appropriate chunk corresponding to the user query, and those chunks will be passed as the system prompt. Now, my question is, in this particular case, the output difference between using the full cloud.md file versus only the selectively retrieved items are not going to be that different, simply because the number of tokens here are anyway minimal. 400 versus 1300 is not going to make any difference. But if your cloud.md file was so big such that you had 50,000 tokens in that, then it is difficult. This selection is automatically handled by the coding agent. You mean, Nikhil, is this handled automatically by we don't. Now let's move on to quiz. 10 minutes on this. Directly, you just answer the question in the chat. Okay, do you guys hear me properly now? I just need to test. Yeah, it is being recorded, so nothing will be lost, but I'm not sure how my internet speed is. Let me just test it once. Okay, not too good, but not too bad. So let's move on to the quiz. This is the first question. Actually, there are 25 questions. It may take few minutes, but anyways, I think this will be fun. So which system prompt instruction is at the right altitude for handling customer pricing questions? Among this, just answer with A, B, C, D. A, B, C, or D. The problem with A is too vague, so it's too high. B is too specific. D is also vague, so C should be the correct answer, right? Then a system prompt has 5 components: identity, rules, format, knowledge, and tools. You're building a support chatbot but running low on token budget. Which is the component you should cut last? Which should you remove last? So this we discussed in the lecture. Rules are guardrails. We should not remove it. Rules should be removed last. Format, identity, knowledge. If it comes to choosing between these, you have to always keep guardrails, right? So rules you should remove last. Then in cloud.md or agents.md file, which section typically is the highest value per token? This is not something we explicitly discussed in the lecture, but I'll be happy to see your thinking process. So which among this is the most important value per token? A, project overview, project structure, code convention, common mistakes. So this is actually very confusing. The best thing is providing common mistakes to avoid. You know why? Because when you are using cloud code to build something, the best is direct something you should not. This common mistakes avoid you get the model going into loop and producing something which is completely wrong, and then you having to provide feedback again to get back. Oh, again. Do you hear me all right? I'm temporarily on my phone hotspot, but I'm not sure how good this is. I just switch on my camera for the time being, just to save some bandwidth. I think there is some power issue here. All right, let's go on to the next. In the 5-layer context stack, which layer is always loaded into every single LLM call out of these 4? Screen is not shared. Oh, let me do once more. All right, how about now? So out of these 4, which one is the most common one, which is almost always loaded into the stack? It should be layer 1. This already we discussed. But again, please note, agents.md or cloud.md are not entirely loaded. Its parts are loaded. Then using few short examples, you are using few short examples for classification. You have a budget of 5 examples. What happens to accuracy as you go from 3 to 5 examples? Marginal improvement, diminishing returns kick in hard after 3. So this actually, there is no proper consensus on this. In some documents, it also says if you add too many examples, what may happen is, so if for example, I'll tell you a situation. Let's say there is positive, neutral, and negative example. If something is, if you are giving one positive, one neutral, and one negative, you are already providing 3, right? 3 with diversity. Now, if you provide 2 more, what if those 2 more are positives? then you are somehow giving model some information which may not be in the right way. The diversity is lacking. So it can also decrease the model's performance. So C or D can technically be the answer. Marginal improvement is for sure is the case. But in this case, people always say, I mean, this don't take this into account. In general, when you read articles, you will see that models will get confused when you are adding few more examples which are not diverse enough. If all the 5 examples are diverse, it's okay. If 3 examples are positive, neutral, negative, then 2 more examples you add such that they are positive. Now you have 3 positive examples, 1 neutral and 1 negative. Not the best because the diversity suffers, right? So answer can be C or D. Then you have 15 customer support examples in a bank. A user asks about a damaged product. Dynamic selection picks 3 most similar example. Why does this beat static selection? This we already have discussed. So why is 3 dynamic example the best instead of 3 static example? So if it is about shipping, then we don't have to pick example related to something else, right? So you should not be wasting your tokens. The problem with 3 static example is that in every single call, you are using the same static example. It's not good. The actual problem is that in static example, the main reason is in static example, you are paying more in the form of tokens, in the form of API call for irrelevant context. So that is the main issue. In dynamic selection adds variety, prevents the model from overfitting. It's not about overfitting or anything. Yes, dynamic selection adds variety for sure, but it's not just about overfitting. That's not the main issue. The main issue is static example keep on getting loaded always. This is something which we have not discussed, so I will just skip for the time being. Okay, how about this? Anthropic recommends start minimal and then add for system prompt. A colleague argues it's faster to write a comprehensive prompt already, like writing a claude.md file, the full file already, without having to write it one by one. What's the issue with this? The problem is that the rules which you define in the beginning are not the rules that you come across based on your experience. You are speculating some things might be the rules, and you may or may not end up writing a good claude.md file, right? So this is the main issue. But if you are already clear of what exactly you want to build and you have thought about it a lot, then in my experience, you can write claude.md in one shot also. But in general, if you have no idea what you are building and if you don't know where you will be going after 5 steps, it's better to start with minimum claude.md file. In agents.md, files can be nested in subdirectories. This we discussed. Example, repo/root in the root and then in the src/API. How does this hierarchy work? Only the deepest is loaded. Then root is always used. Subdirectory is ignored. Tools pick whichever agents.md is closest. All agents.md are concatenated with deeper files adding to or overriding parent rules. Clearly, this is a confusing question. Everybody is answering different things. So if A was the, let's think about different scenarios. If only the deepest agent.md is loaded, the problem is bunch of rules defined in the parent. There is a reason why we are calling it as a rule. So clearly A is not probably the answer, right? I can just click it. In general, what happens is all MD files are considered. But if there is a rule in the later part of hierarchy, which is kind of different from the rules defined in the earlier top level of hierarchy, the later agents.md files are being used. The rules mentioned in the later agents.md files are used. Why? Because if an agent is writing something related to API calls, the rules mentioned here will override, in case if there is a conflict, the rules mentioned here will override the rules mentioned here. So, but all the rules, everything mentioned here as well as here will be used. Then which few short patterns should you use when the model needs to apply multi-step policy? Example, determining refund eligibility based on order date, product type, condition, etc. Because this is a complex, this sort of like a not an easy classification or something, right? It's complex. So you will have to give chain of thought. You give the problem, you give the reason, you give the solution, and this you provide in the examples. Then your system prompt is 5200 tokens. According to best practices, what should you do? System prompt, you can think of it as prefix, suffix. Let's go back. Which view shot pattern should you use when the model needs to apply a multi-step policy? Input output pairs, prefix suffix, show the output to structure, output structure to complete. Prefix suffix is what we discussed, the third type of example. So if you want a JSON file, show the full output. Like if this is the request, this is how the JSON file should look like. Prefix suffix is just a complex word to describe the structured output format which you are expecting when you are expecting code output, code or some other format. If you have a specific writing style or something for a documentation for your company, you have to provide that specific style. Chain of thought is when you want your model to make a decision regarding something which is complex. Input output pair is mostly used when you have some classification, very simple task. 5200 tokens. What's the best practice? Would it be compressing, or would it be like splitting cloud.md and system prompt plus having a dynamic RAG based retrieval? Of course, it will be RAG based retrieval. This is what we discussed earlier. So it should not be that every single thing is put in persistent memory, or it should not be that every single thing is dynamic. You need persistent memory as well as you need RAG. Then you are selecting 3 few shot examples from a bank of 20. Which selection principle matters the most? This we already discussed. We need diversity, right? So let's go ahead. Okay, you build a chatbot and it has great response. It scores 9 out of 10. But after deploying, after a month, the accuracy drops to 5 out of 10. You haven't changed the prompt or anything. What might have happened? Is it about model silently updating the weights, or real users ask different questions than your test user? Prompts was overtrained on tests. Production latency causes the model to generate slower. So it's not about model weights or anything. Model might still remain the same. It's more about when a customer is having long conversation with a chatbot over a few weeks, all those things might be stored, right? And then the longer the conversation, just like ChatGPT, when you are chatting in the same chat window, your context is getting rotten because, oh, let me check B. B is also possible. Real users ask different questions than your test set. Sure. I mean, yes. Ideally, when you are building a chatbot, you would already consider real users' data. For example, when we are building an email response agent, I'm already taking real responses into consideration. But you are right in the sense that a new question coming in the email can be completely different from what we have seen already. I'll just switch on my camera for a moment. If my bandwidth is getting slowed down, just let me know. Then in the start minimal and then add, your round 1 chatbot hallucinates order details. What is the correct round 2 fix? Meaning in the round 1, minimal things are there. In round 2, what else will you add? Will you add something like never hallucinate or make up information? Will you add 5 few short examples? Will you add something like, if something is about order retail, have a function called? So we will go with C, right? Fairly straightforward. Okay, how about this? Your cloud.md is 1200 lines. So my cloud.md was 260 lines. So 1200 is almost 6x the size of that. What would you do in this case? Keep it more context is better, or should you not do it? Lost in the middle is definitely a risk, right? We discussed this earlier. And higher API cost will also be there because you are passing the same set of 1200 lines in every single. So A or B or both can be the risk. The highest risk is more than, even if you are, let's say, not so worried about the cost, lost in the middle is the biggest risk because your quality might degrade. Chatbot keeps hallucinating on the orders. You add the rule never hallucinate. It doesn't help. What's the issue with this? It's basically very vague. So it's like a too high altitude. Don't hallucinate is a vague term with no example or no it doesn't say anything to even a human, right? We have no idea what does it mean. You have three few shot examples, all showing positive sentiment classification. You add two more positive. I think this we had already discussed in one of the earlier questions. What happens to accuracy? Will it stay the same? Will it get worse? It can stay the same. It can get worse also, right? A or D can be the answer. No effect few shot examples only influence the few categories, the exact categories shown in them. The model already knows other, okay, it stays the same. The model already knows other categories from its training data. Okay, A does not training, it's not about training data. It improves slightly more examples, help always get model calibrate regardless of category. It gets worse. Model over indexes the positive. Let's try with D. D is the correct answer. The thing here is like here all the issues are there. Sometimes the chatbot can become worse because you are giving more useless examples. Sometimes it can get better depending on the context. Um, okay, how about this? Which layer of the context stack has the highest impact? Which has the highest impact on your output quality? Okay, the question is a little bit tricky. Let's go with C and see what it says. There could be, so what is tricky about this is, but teams most often skip or underinvest in. The reason why teams underinvest is because people want to build very soon, right? People are so fast, like they don't want to wait until a proper cloud.md is constructed. But however, teams also usually under invest in providing good examples. This I know from experience. So it can be layer 1 or layer 4, both. But what always gets loaded is something from cloud.md and or agents.md is almost always loaded, which means it answer can be a layer 1 or layer 4. We're almost at the end. When a system prompt says be formal and professional, oh, A2, let's see A. Layer 5 dynamic tool results. One thing is RAG. If your chatbot requires RAG, I know that people spend time on it. In the sense, like if you are building a tool for which you know RAG is needed, that part people generally work on. But people are too lazy to give examples from their past, interactions with the humans or with other people through your email system or through your chat system. The human to human communication example. That part is where people are a bit lazy. I have seen. We have worked with many different companies building RAG-based chatbots. So in general, I mean, yes, any of this can be an answer because this is vague. But layer 4 is something where people are a bit lazy. When a system prompt says be formal and professional, a few shot example demonstrates casual friendly tone, which does model typically follow? This is a tricky question. The system prompt says this, but the example says this. So what type of tone will be followed by the model? It's a little bit tricky question. So in general, what happens is if you provide examples, example is something where the human is showing how I want things to be in a more concrete way. What you define in system prompt is not a in this case in system prompt of B format formal and professional is not some concrete thought of the human. It's a vague set of words that describe a concrete example, right? So in general, what happens is if you provide system a few short example, it always has a very high priority. However, this also depends on the example. Again, I will reiterate, this is not physics. Large language model output is just like it's like psychology or something. I don't know what to call it. But because it's not physics, sometimes when you run, you might also end up with a case where system prompt is given higher priority, right? But these are based on um, generalized large number of examples or statistics. Static few shot selection weighs about 30% of the tokens. Yes, also may vary from model to model, as you yourself have seen in this data in the experiments we conducted today. Static few shot selection weighs about 30% of the tokens on irrelevant context. What technique does dynamic example selection use to fix this? So in dynamic example, what we do is we use RAG to retrieve the appropriate examples or appropriate sections from the claude.md file, right? So we can just go with A. So this is straightforward. Almost the last three questions. You wrote a comprehensive 800 token system prompt covering 20 different scenarios, but only score 6 out of 10. Then a colleague starts with 3 lines and iterates to 400 tokens. So instead of 800 tokens, you have 400 tokens, scoring 9 out of 10. What could be the issue? This we discussed earlier. You want to start building slowly and then build on top of each other. Otherwise, the rules which you have provided might contradict each other, right? Because in the beginning, when you are giving it in one shot, you are speculating a lot of things without experience. And then you need to aggressively reduce your system prompt to 400 tokens. What is the component can you most safely remove first? What would it be? It cannot be A, right? A is unsafe to remove. Rules are very important. Let's see what says if it is format, uh, whether the model's output is format issue. Identity is the safest to cut first. Model can often infer it from its role from the rules, examples, conversation, etc. Format can default to natural language if you don't provide the format properly, in the sense that if you are expecting JSON format, you have to tell that it should be a JSON format. Otherwise, most often the default format of LLMs is natural language. And identity is like what you are. It is usually provided, as you have seen in our claude.md markdown files. It's in one paragraph, right? Then identity token is less compared. Okay, that's a very good thing. Yes, for sure, for sure. Identity is much smaller in terms of token consumption compared to format. Yes. In general, if you are asked just, hey, cut one of these, then maybe you want to cut identity. If you are to say cut one or two, but maximize the amount of tokens that you are eliminating from the context, then maybe you will cut identity and format. This you will not do in practice, by the way. Okay. In practice, your claude.md file will not become the bottleneck will be something else. Mostly it might be tool descriptions or stuff like that. You have confirmed your chatbot suffers context rot, performance degrades, which fix directly addresses the issue. Would you increase the model's context window? Would you reduce system prompt? Or would you re-inject key system prompts? Or would you add few short examples? It's again a little bit tricky. We know some things. Reduce the system prompt under 100 tokens is a little bit aggressive, in my opinion, because 100 tokens is like 100-ish words. It's like a small paragraph. I don't know if that will do the best. Increase model's context window is not under your control. Let's try with C. C is not the correct. Periodically re-inject key system prompt. I mean, here we don't have to believe the answer that this MCQ app is giving. Okay, it can be either of these. In my mind, it's not D. That much I am clear. It's too small. 100 tokens is too small. Increase model context window. No, it's not a solution. Maybe we can re-inject system prompt, but then re-injecting, you have to decide when you are going to re-inject, how much of the system prompt you are going to re-inject. But in general, if the performance is degrading, what I have done in my email chatbot, I have sometimes seen the performance degrades. Then what I added is I added some examples as part of system prompt, which will also help me as a rule. So some rules were something like never refer to some links before 2025 November. So this was something which I explicitly added after I noticed that some performance is degrading. So there, it's a clear example, because which link is before 2025 and which link is after 2025, the model knows. But I'm explicitly saying, hey, before this date, if you are referring to the links, don't do that. Refer to the newer links. So that was an example of D, but then it could be A also. Last question. Common mistakes to avoid section is considered the highest value section in claude.md. Why does telling the model what not to do work so well? Models have built-in negativity bias. It encodes tribal knowledge from code reviews that model cannot discover by reading code base. Negative rules are shorter and more token efficient than equivalent positive rules. I'm not sure if C is true or not. I have not read this anywhere. I don't know. Model uses elimination strategies. Knowing what to avoid narrows down the solution space more efficiently. Here again, B or D could be answer in my opinion. Let's try D and let's see what the answer that this MCQ app is saying. It says D is a better answer. It encodes tribal knowledge. Let's read the description. The model can learn code patterns, naming conventions, and project structure by reading the source files. But it cannot learn, never use raw SQL here, always use query builder, or don't use floating point financial calculations. That knowledge only exists in the developer's heads and code review comments. Anti-patterns encode this tribal knowledge. So by tribal knowledge, it means the knowledge of the humans who came before cloud code. Options A and D sound plausible, but are not how models work. Option C is factually correct. D, I don't know what's wrong with D. D sounds correct in my opinion. Model uses elimination strategies. Knowing what to avoid narrows the solution space more efficiently than knowing what to do. This is arguable whether it is D or C. Most of the time it requires more evaluation to choose the option or approach. I did not understand the question. Most of the time it required more evaluation to choose the option or approach here. What do you mean evaluation, Ranganathan? If you can elaborate, I did not fully understand. Let me check if any other questions are there. Will these MD files, okay, will these MD files have any role once the app is deployed? Will this MD file reside until the app is deployed? Very, very good question. Think about it. In my production, okay, when I'm deploying my email tool in production, I don't have Anthropic API. So I am not using Cloud Code at all, right? I'm using OpenAI API or Gemini API. So the way files are referred to in production environment is very different from the way files are referred to when you are in development mode. Because in development, when you are local hosting, your files reside locally. You could still use Cloud Code, or even if you are not using Cloud Code, the way the files are referred to are much different. So before you move from development to production, you have to ensure that the files which you have created, markdown files or txt files or whatever it is uh, it is explicitly mentioned in what folders it will be provided, and that should be passed as a prompt into whichever LLM you are using. So this is one issue which we are also facing. We have not perfected the way in which how to make production better. So what we do is, if we build internal tools for our internal purposes, which is not customer facing, what we do is we always use it in development mode. We don't push it to production. That way I don't have to make any changes. So what do? I have an Amazon, AWS EC2 instance. And on that EC2 instance, I have bunch of agents. Everything is in development mode. I will put it in local host. Whenever I have to use, I will use it through the local host. I don't put it into production, because into production I have to optimize a few more things regarding how the different MD files are referred by OpenAI's LLM or by Google's LLMs. If Claude.md sections are not fully loaded, then is that Claude agent that picks the important chunks required to feed LLM? Yeah, it is Claude agent who picks the important parts based on RAG or keyword match. It is mostly based on keyword match. RAG is rarely done. Who will decide or define? So unless we explicitly define that it should be based on RAG, it's almost always based on keyword match. Would you be able to share collab link or Verser link to people on free plan when you upload the video into the portal? So the links are exclusively for the engineer students and the industry professional plan students. Will these, then what else is there? I think most of the questions are covered. If you have any other question which I have not addressed, or if you want to know details about anything else, just drop an email at hello@visuara.com. We will get back. I'll take a couple more questions. Do you think it is better to split cloud.md into multiple files like skill.md and knowledge.md? I haven't seen that done yet. The thing is, see, we are all discussing about context engineering right now in March of 2026. I'm pretty sure maybe one third of the things that we are discussing today may not be relevant maybe 5 months down the line, right? So maybe something might evolve where the way cloud.md is handled is completely different. Maybe it's split into different files. It's all the things that we are discussing right now are the things that are working at the moment, right? It's not some universal, forever unchanging structure of giving information to agents. That sorry about that. I think my power issue came back. Okay, how about now? Do you hear and see me? All right. Okay, awesome. So just do one thing. Just try the quiz once yourself. Specific homework for today. One thing you should try is this. Try installing Claude if you have. Try taking the $20 subscription, if not for forever, at least for now, or even API, Anthropic API if you can. My credit card is not allowing me to take the Anthropic API. That's the reason why I don't have it. But if you have API, you can just put $5 or something in credits. And then try making claude.md file yourself with minimum instructions in one case, with more instructions in another case. So just like how I did ideas.md converted into claude.md. Try both approaches to build a very basic application. The very basic application could be any website which performs a certain task, or it could be like a certain file structure, or like a compiled PDF document, something like that, and see the quality difference in the output. In general, when you are working on any app using Cloud Code, first half an hour or 45 minutes, most likely you will spend such that your Claude.md file is perfect. Only after that, you will be spending your time on rest of the files. App or tool for voice to text is Whisper Flow, WISPR Flow. So, all right, everyone, I think we can wind up here today. So starting at 8:30 or 9 a.m. in IST will be a bit difficult because there is a scheduling conflict there for me. But let me figure out what else is the solution. The other solution is for those of you from the US with crazy hours like 1:30 a.m. to 2 a.m. I'm wondering if lectures should be split or not, but then it will prolong the whole program. That's the other. Let me think about what could be a good solution. We don't have class on Friday. Okay, daylight saving starts. Okay. It already started, or is it about to start? The daylight saving. Okay, started, right? So if it had not started, was it better or worse? Okay. All right. Yeah, I know that for Indian folks, this is the best timing. But yeah, I'm sorry, guys. It's like a crazy cohort. Like everyone from different parts of the world is there. So what I would say is like you can drop off the call as like whenever you wish. Like no hard feelings. Like, and then I will post the recording as soon as I can, and then we will resume the next day. Yeah, 8 a.m. I wish it was a bit earlier. The only thing is I have a unchangeable scheduling conflict till around 9:15 a.m. IST. So the latest I can start is like around 9:15 a.m. That's the only issue. Otherwise, I would have kept it a bit earlier. Yes, the link to the day one app I have changed. I have put it on the website now. It's a different link. All right, then, everyone. Thank you so much. We will meet again tomorrow. So tomorrow we will discuss RAG, and tomorrow we will be coding a RAG-based chatbot or RAG-based, a PDF chunk fetching application almost from scratch. So this time we may use Cloud Code a little bit. I'm primarily thinking of coding it in Google Colab. So let's see. I'll decide later today. But tomorrow we will study about RAG. Day after tomorrow we will study about MCP, Model Context Protocol. Thank you so much, everyone. We will meet tomorrow, same time. Friday we don't have lecture, so day after tomorrow is Thursday. Then after that we will meet on next Monday. All right, everyone. Take care. Bye. Hi, everyone. Welcome to the day 3 of LLM Context Engineering Bootcamp. Before we start, can you please confirm if you can see my screen and hear me and see me all right? Awesome. So yesterday's session, I have scheduled on YouTube for today IST 3 p.m. So the link should be accessible by then. I have posted it on the course dashboard also for students in the free plan. So we can get started. So where we stopped yesterday was discussing how to structure the cloud.md document and how the system prompts work. We discussed how when you are passing the context into the large language model, that the entire cloud.md is not passed, but rather a portion that is relevant to the current query is being passed into the prompt. And this tremendously reduces the token consumption due to the, let's say, claude.md or agents.md files. Those files can, I mean, typically they are maybe 250 to 600 lines or something like that. But in case they are so big, if it is like 5,000 lines or 3,000 lines, you don't want to be loading that all the time. And we also discussed that to fetch the relevant sections from that document, you may use keyword matching or you may use RAG. So although we discussed briefly about RAG yesterday, we did not go into the details of RAG, and that is what we are going to do today. Today, all of us together will be coding a RAG chatbot completely from scratch, which should work on almost any kind of document. So along with that, we will also be discussing about the write part of the write, select, compress, isolate framework. So specifically, today we are discussing two parts of the write, select, compress, isolate framework, which is write and select, out of which RAG belongs to select, because select means you are selecting what should be there as part of the context at any given point of time. Write means if you want something to be part of the context sometime later, but you don't want it right now, you write or you store it in the memory, either in a persistent memory or in a temporary memory. So we'll briefly discuss that also, but primarily most of today's time we will be spending on coding RAG-based chatbot, which we will do in Google Colab, so that every single one of you should be able to do it with me. And we'll be writing almost every single line of code. So this is the idea behind write, select, compress, isolate framework. It's part of something that LangChain had defined originally. So here the main focus is on the context window. So in perspective of context window, write simply means you move something out of the context window, you store it somewhere so that later you can retrieve it if you need it. Select simply means you are selecting some things specifically from your storage to be part of the context window for the time being. So it's a dynamic process. And this is where RAG comes into picture, because RAG means you are retrieving some things from your database to be for that to be part of your context. Isolate is where agents or tools may come into picture. Isolate meaning you are splitting the context or you are providing an entirely new context for a separate API call to be made, so that if there are sub agents defined for subtasks, you don't want the context of those agents to be polluted by the context of your overall task or overall execution of what you are building. And compress is if your context window, let's say, is 80% full, that means you only have very little space for the upcoming tasks. So you need to do something with the context window, which is 80% full. And what you could do is either you can completely clear the context window, which means everything is lost. That is not very good. But a better thing to do is you can simply compress the context window. So you compress such that everything that is taking, let's say, 50K tokens, you represent in a summary using maybe 5K tokens. So you save a lot of space in the context window, and that space can be used for producing better quality output. Yes, it's very much like /compact in Cloud Code. /compact also does the same. /clear is different. /clear clears the context window. /compacts compacts the context window. But in Cloud Code and many other coding agents, compacting is already part of its framework, meaning by the time a certain threshold level of context is full, it performs auto compacting. But sometimes you may want to compact yourself when you are building, when you feel like your quality of whatever you are trying to generate is degrading. You should feel like, oh, it's probably time to either clear my context or compact my context. So today's 80 to 90% of the time will be spent on this RAG. Little bit of time we will spend in figuring out what exactly will we write if we are moving something away from context window for later usage. So yes, so isolate is nothing but if your context window has 200K tokens, and if so much portion of this context window is full, a better thing to do is have a separate isolated context window where none of these tokens are present. So none of these tokens, which are part of your main context window, should be present in this isolated context window. And this isolated context window will make a separate API call to your, this isolated context window will be used in a separate API call. And where is this used? Let's say this is your context window of the main task. And as part of this main task, let's say you are working on certain experiments and you want to analyze the result of some past experiments. You don't want the main task tokens to pollute your subtask. Your subtask is just analyzing the results of an already done experiment. In that case, you can create a separate isolated context for your sub-agents, and sub-agents will make its own API call. And that context window associated with the sub-agent will have only information relevant to this, right? So we don't have to, we can create sub-agents by just mentioning it explicitly. If you want to spin off sub-agents, you can mention it explicitly if you are working in Cloud Code. But if you are not explicitly mentioning also, sometimes you will notice that Cloud Code will by itself decide to spin certain sub-agents, right? So isolate, we will be coming to that. Isolate as in dealing with tools and agents, we will be coming to that tomorrow. Tomorrow's main task is working on MCP. And today it will be, okay, there is one question, how the context will be shared across sub-agents and parent agent. So there are files which are shared across sub-agents, which will be accessible to both. So whatever is put in storage, so the storage, some of the files are commonly accessed irrespective of what sub-agent you create. For example, the agents.md file in the top of the hierarchy, cloud.md file, which is also in the top of the hierarchy. Or sometimes from your memory, there are some persistent information which you want to make available for different agents. So it is within the agents.md file, you can define where it can get the relevant information from. This can be done manually, but because Cloud Code is so smart, when it defines agents.md itself, when you ask it to do it, it will automatically mention that in the agents.md file. If you remember from yesterday's example, I first had created ideas.md, which was raw. Then I had created ideas v2.md, right? And then based on ideas v2.md, I asked it to create a cloud.md file. And if you remember, in the cloud.md file, there was a reference to ideas v2.md, and that was automatic. I did not mention it explicitly. Similarly, in agents.md file, you can have reference to other files, and this agents.md file could be, let's say, agents.md for agent number 1, sub agent number 1, and agents.md for sub agent number 2. Both of these MD files can have reference to common files, and it can share information. And that information, if it's in a compressed format, will be part of the context of both of these subagents. So there are actually three types of things which you typically store in the storage as part of write, right? So one is short-lived. Ephemeral means short-lived context. So short-lived means if you have three phases in which you are building your product. So when I'm building the the news aggregator agent for AI, I have a short-lived context as well as long-lived context. Or if I'm building an email reply agent, I have short-lived context and long-lived context. Short-lived context is something more like the current thread which I am referring to. So if I have a current thread, and if I think all the information in the current email thread might be relevant, to whether craft a new reply in the thread or to craft a new email in the thread. But if I don't want to store it in the context right now, I can simply put the current details of the current thread in a file, which is temporary, and then refer to it later. And this temporary file can also be, I'll show you one example. It can be I'll come back to this in a second, but you can define a temporary file called task.md. Yes, context window is ephemeral for sure. But often what happens is the tokens that fill the context window from one API call to another API call, sometimes 60% of 50% or 60% of those tokens can be the same. And why is that? Simply because the markdown files which define your primary task are the same. Maybe the result of two different tool calls have very high overlap. So because of that reason, although two API calls are distinct, the way in which tokens are populating your context window, you may find similar tokens in two different API calls context windows. 200K number, is it deliberate or random pick? Found at multiple places that 200K is a sweet spot. Yeah. So 200K is something which is routinely coming if you have a 1 million token context window or 2 million token context window. Your the amount by which you can fill the context window is not like entirely 1 million or to 2 million. Just because the LLMs are providing bigger and bigger context windows, it doesn't mean that you should be filling it to 80% of its capacity. The most recommended size for these kinds of context window is 100 to 200K tokens, because otherwise context rot will happen. You may be only filling like 50% or 60% of the context window, like 500K tokens or 600K tokens, something like that. But that itself can cause context rot. One thing you should realize is, I have a question. Is context window only for the input to the LLM, or does it also matter for the output produced by the LLM? Context window, does it consider the tokens for input or output or both? It actually is meant for both. Context window actually consists of, that's the reason why when the LLM produces an output, right? You have to leave some space in the context window for the output to be stored. Otherwise, your output will be truncated because the context window will get exceeded. And in any case, the output is produced using next word prediction in most of these models. Output is produced auto-regressively. So next token is added to the current set of sequence of tokens. Using that, the next token is produced, and so on, right? Then, okay, there is a question. What's the logic behind using files to store this information rather than some database? So yes, so in RAG, if you are performing RAG, you will be storing all the files in a database. Otherwise, there will be huge latency. But you know what? Sometimes I have noticed, so this is my experience, okay? So I'm building this email reply tool, and we were discussing, maybe because of the sheer volume of emails and the sheer number of different programs that we have, we should probably have a RAG system to fetch the appropriate details about the programs and appropriate details about the past emails using a vector database, okay? And then we implemented it. But to my complete surprise, I noticed that the performance was even better by completely abandoning the vector database and just defining a markdown document with around like 600 or 1000 lines, which was a sort of like a proper summary of these both documents, which describe the details of our program and that describe the details of our past emails. We also recently built a voice agent for calling. So for example, if somebody wants to make a phone call and understand some details about what we do and everything, we just created an agent with a US phone number. You can call that agent and you can talk, and the quality of the output from my experiments, I saw that it was so good, and latency was not at all that much of an issue. And there, the only knowledge base was a properly written markdown file. I don't remember it was a markdown file or txt file. I have to check that once more. But it was literally, the knowledge base was one properly written document with appropriate links if needed. But so from our experience, yes, you can do RAG, and in theory, it should work better than having just files, both in terms of latency as well as accuracy. But from my experience, it has been, at least in the recent times, it has been the reverse. The simpler, the better. That was the case. But I'm not saying it's a rule or anything. I'm just sharing my experience. Then if you are, so basically, if you are performing a phase one implementation of a website building, in the website building, currently you are, let's say, working on a specific card, a card to display information. This is one subtask. And if you need some information which you might use for making a card in your website in the later part of your API call, then you may store that information as a in a task.md file like this. So these task.md files are defined for as something like a scratch pad for the current task. It's not meant for the uh, whole session. It's meant for a particular subtask. And just like how humans use Scratchpad, this you might have also noticed when you run Cloud Code in the terminal also. In the terminal also, it creates these, you know, things to check. So different tasks will be defined, and you can check them off. So similarly, you can explicitly mention like the agent to define a task.md file. Task.md will define the to-do list, and this to-do list will keep on getting updated with what is done and what is to be done. And this is completely temporary. This is never used. And why is this useful, by the way? The reason why this is useful is your overall project, you might have realized that you can describe it in two phases. Phase one is single user experience. Phase two is multi-user experience. Phases equal to two. But then within the single user experience website, there are many different subtasks which you may want to implement separately, because implementing this whole phase one is difficult. Implementing this whole phase two at once is difficult. So what you really want to do is within phase one, you may define phase 1A, phase 1B, phase 1C, and so on. Okay. Phase 1D and so on. And when you are implementing phase 1A, you want to keep track of two things. One is what your overall goal is. The overall goal is the fact that you have two phases. In phase one, in general, you are building this. Next, you have to go in general to phase two. And this will be generally stored in the cloud.md file, which will be accessible anyway to the sub agent if needed. But the details of what is being implemented in phase 1A, you don't have to have a permanent file. You can simply have a task.md file, which the agent will itself take care of. And the task.md file will keep on getting modified within the implementation of phase 1A. And for phase 1B implementation, there will be separate task.md file. So this is one way in which you can have short-lived memory. And from that memory, context window can pull information whenever needed, or context window can store information to that memory whenever needed. Just a second. All right. So there is a very specific way in which you can think when you will need to, write something, and whether it should be in the transient or whether it will be in the persistent context. So basically, if something is going to be used in the next 2 minutes or 5 minutes of implementation, it will most likely be temporary. It will never be used again, and it will stay as these task.md files. But if something is transient, for example, if some files are being referenced in the agents.md folder for the sub agent, not for the entire task, but let's say a sub agent has an agents.md file, and this agents.md file is referring to a specific set of files or a specific database. Okay, only for that task, but then it may be referenced throughout the duration of that particular task, which may last not just 5 minutes. It can last for half an hour. It can last for 2 hours, depending on the time span of implementation. Then those are a bit, it's not a completely short lived. It's like a transient context. And those files you will probably be, it will again be, it could be MD files or it could be vector databases, depending on what the complexity of your task is. If it is a vector database, you will be for sure implementing RAG. If it is a text file, you could be implementing either RAG or typical keyword matching like TF-IDF. We will come to TF-IDF in later part of today's lecture. And then if it is an enduring context, which you don't want to store in the context all the time, but you may refer to it every single time, this is something which you will store in your global workspace. It won't be part of the sub agents. It will be part of your cloud.md file. It may be referred to the cloud.md file, just like the ideas v2 document. Ideas v2 document was referred to in the cloud.md file throughout the implementation of the project, because that is part of my entire project's philosophy. So this, we will not be discussing too much about compress and isolate right now. We will discuss mostly about the select, because this is the probably the single most important concept that you should be familiar with. All right. So yeah, so just have a look at this. If something is to be used for just 5 minutes, look at task.md, which is scratchpad, ephemeral, short-lived. If something is used in the next session, so let's say you are running cloud code in the morning session and evening session, but you are still working on the phase 1A implementation, you will most likely need something which is used in phase 1A in the morning and phase 1A in the evening. In that case, you could store it somewhere in DB files or user preferences as markdown files, any kind of format, whatever is convenient for you, because all of these anyway cloud code can access, whether it's in a vector database format or whether it's in a structured document format like XML or markdown file. Cloud code can access any of that. But for example, if something is not at all short-lived, something that is going to be universally used, to give an example, we are also building like a central brain for our company. So the central brain will be like an orchestrator, okay? And so individual orchestrator, okay? So individual developers in our team are building separate agents. So this is, let's say we call this as agent number 1. This is not sub agent. These are separate projects in themselves. This is agent number 2. And then this is agent number 3 and 4. Okay. Now, one concern that we have right now is, right now we have no way to connect agent 1, agent 3, 2, and 4. All right. Right now, this agent, the task that this agent does is completely isolated compared to task that agent 2 is doing. So now what we are doing is we are building a two-way MCP, two-way model context protocol, where this agent 1 can communicate here, as well as central brain can communicate here. And so can agent 3 with central brain, 4, as well as 2. And the central brain can act as the orchestrator to say, hey, you do this agent 1, and once that is done, agent 4, you do this task. But then here, certain files need to be commonly understood by the central brain orchestrator. Those files will invariably be the cloud.md files in each of these agents, which are defined separately. These are, please don't confuse this with sub agent. This I'm talking about 4 separate projects. In fact, 5 separate projects. This is project 1, project 2, project 3, project 4, and project 5. Project 5 is just an orchestrator agent where it won't be doing any task by itself. It will simply be asking other agents to execute tasks, but to know what the core philosophy and core implementation strategy of each agent is, these files, cloud.md files, will be referenced to again and again and again. If there is any database, let's say one of them is an email agent, it may have an email database stored in a vector database that will also be used again and again and again. So the time span of such documents will not be few minutes, or it will not be few hours. The time span of those documents will be few weeks or few months, and they will be stored in cloud.md files or in any other format. So this is ephemeral memory, this is persistent memory, and this is a bit more short-lived. It can be called as transient memory. But if something is used only once right now, you don't have to store it. If something is used only one time in a context window, don't save it or don't store it, just use it and you are done. You just forget about it. Now, since we will be spending at least 45 minutes or something today coding, okay, there is a question, but why can't we directly connect each project through two MCP? Abhi, I guess you're asking, why can't agent 1 and agent 2 be connected? Is this what you're asking? Yeah, it can be technically done, but the thing is, agent 1 is, let's say agent 1 is good at doing research, okay? And agent 2 is good at communicating through emails. The problem is agent 1 does not know unless told, hey, this is the overall, these are the projects that we are currently doing, and these are the tasks that are pending, and you should be doing this. So agent 1 does not have an overall idea about our central brain of the company. It does not know overall in our company what all things are happening. It is only focused on that one task. Same thing for agent 2. Agent 2 is only good at one thing. If somebody asks it to, let's say, craft an email, it will craft an email appropriately, but it does not know anything else. It does not know when to do something, or whether to schedule something or not. For that, you need to provide instructions. Execution it will do, but instruction someone else has to provide. And that entity who is best to provide such instruction is an agent who acts as a central agent, who will have access to all sorts of information in the network. So this agent will not be provided with any tools to actually execute the central agent. Central agent will only be provided tools to access information and delegate it to other agents. But technically, yes, it is possible to connect two different agents through two-way MCP, not a problem. But I don't think it's a good approach. Okay, now let's get into retrieval augmented generation. And this is a very, very interesting topic, and maybe one of the most important topics that you have to know, irrespective of what industry you are working in. And this will, I think, if you master RAG, you will, lot of issues you will be able to solve for other companies. So when we work with other industries, so we have a division called First Principle Labs. I don't know how many of you are aware of it. So this is our website. So we partner with a lot of industries for solving their actual real world challenges. So you can read about our work, but the point is, most of these projects that we have worked on have something to do with building a RAG-based chatbot or RAG-based retrieval system, either for internal company purposes or for external customer facing purposes. So from our experience, and it's not easy, right? RAG, there are easy ways to implement RAG, which is what we will be doing today. But there are also complex databases where retrieval is actually difficult. So many companies are actually having this requirement of wanting to implement super efficient, highly accurate RAG pipeline for their internal purposes or for customer facing purposes. And if you can master that skill, I think you will have a lot of value to provide to the industry. So RAG, in simple words, it's retrieval augmented generation. So what is generation? In large language model, it produces next token output. So that is generation. And what is augmented generation? Augmented generation means you are providing certain prompt to the large language model, but that prompt is getting augmented by something. And what is that something? That something is a retrieved document. So basically, when you provide a prompt to the large language model, that prompt get appended or prepended or augmented with a retrieved set of information from a database. So this is the reason why it's named as retrieval augmented generation. Now the basic philosophy behind this is very simple. You know about the cost of training a large language model from scratch. It is very expensive. The cost of fine tuning a large language model on top of pre-training is also, it's not as expensive as pre-training, but it is also kind of expensive. Fine tuning is not something which you will do every day. Now, what can you do to make your large language model access information which it does not know, but which are there in other documents? That is where RAG comes into picture. So today we will discuss all of these individual steps that are part of RAG, and we will actually implement it. But let's look at what RAG does. So let's say you have a PDF document. So the example that we will be taking today will be a document which I have downloaded from Microsoft, I think 2025 shareholder report or something like that. So that document will be like a 98-page PDF document. So how did I create the PDF document? I simply did Control P from their website. So their whole web page of their shareholder report was printed as a PDF document. So first we have to ingest the PDF document. So ingesting meaning the PDF document will have text, tables, images, links, etc. And this has to be somehow ingested by some library, and it should be stored in a certain format. That certain format will almost always be a text format. Sometimes it will be an interleaved format with text and images. Sometimes if you use a optical character reader, OCR library, you will have a slightly different format. But basically, you should be ingesting the document before you do anything with it. Then what we do is we do something called as chunking. Chunking is you split the document into different chunks. A way in which you can imagine this is, let's say you have written a 100-page essay. This 100-page essay has different, let's say, different sections. Within each sections, you have different paragraphs. Within each paragraphs, you have different sentences. So chunking can be in different ways. You can say, I will define one paragraph to be one chunk. Or you can say, I will define one sentence to be one chunk. Or you can say, I will define one meaningful part of this document to be one chunk, another meaningful part to be another chunk. So chunking is literally splitting the document into different parts. And then what we do is we convert these chunks into vectors. When I say vectors, literally just this multi-dimensional vector. A vector is just something that lives in a multi-dimensional space. So it will not be two-dimensional vector, but rather it will be a higher dimensional vector like 384 dimensions or 724 dimensions or whatever the embedding model allows. So each chunk will be normally represented as one vector. So if you have 500 chunks corresponding to a document, you will have 500 vectors, and these 500 vectors are now storing the entire information present in your whole PDF document. And you have to store the document in such a way that you should be able to access it very quickly, right? Because the whole point of storing this is for retrieval later. So there are different databases like Chroma database, Pinecone, etc., which we will discuss in a little bit. So once this much is done, so this indexing phase is basically mostly happening once. You don't do this again and again. This is done like one time. So if you're building a RAG-based chatbot on, let's say, 100 PDF documents, you ingest it, chunk it, embed it, and store it. That is done once. And that part will be time consuming. But then what happens on each API request to the large language model is, as user, you will be providing a query. This query will also be embedded into a vector format. That vector should live in the same embedding space as that of the vector of the chunks, because only then you can compare the vectors, right? If your query vector is living in a 50-dimensional space, if your embedded vector for chunks are living in a 100-dimensional space, you can't compare those two vectors. It's like apples to oranges comparison. So ideally, they live in the same vector space. And then you figure out what vectors in your chunk embedded space are closest in similarity to the vector corresponding to your user query. So if my query is, how much profit did Microsoft make in the year 2025? That sentence, which is user query, will be converted into one vector. Then you will have bunch of vectors which are corresponding to the chunks from the Microsoft 2025 shareholder report document. And then my query vector will be compared with the chunk vectors. And how do you compare two vectors? Like, what is one of the good ways to say, hey, this vector and this vector are similar? There are many different ways to do it. You can have cosine similarity. You can have dot product. You can simply have distance function between two vectors. But which similarity function is used really depends on what kind of retrieval algorithm you are using. But any of them are valid. So then what you do is you retrieve, let's say, top 5 or top 10 or top 15 vectors from your database, which are closely aligned to your query vector. Then sometimes it may so happen that you have retrieved 15 items, but the meaning between this query vector, the similarity between the query vector and this vectors in this embedding space is not in the best possible way. Meaning this query vector is embedded using into a certain vector database, right? And this vector database is arranged in such a way that you need to minimize the latency, meaning you have to be able to find out the top K chunks as fast as possible. But then sometimes the top K chunks are not in the best possible order. I will show you one clear example in today's lecture when we are coding. Then what you need to do is this top 15 items which you have retrieved, you may want to re-rank, saying, actually, this is not the best similar item. This is the best similar item. So for that, you will run a re-ranking algorithm where the user query is matched with, so that you will create pairs like user, let me just write it like this, user vector, comma, chunk one vector. So this will be one pair. Then another pair will be user vector, comma, chunk 2 vector. So this chunk 1, chunk 2 are the top 15 items that have been retrieved from the retrieval algorithm. And then this will be passed through another embedding model, which will be like a language model only, a large language model. But this large language model's output will not be next word prediction, because at the end of the large language model, there will be a linear layer which will project whatever the final representation is between this user vector and chunk 1 vector converted into one single token sequence. So the way it works is you will have a separator token followed by the tokenized format of chunk this user vector. Then after that sequence of tokens, you will have another separator token. And then you will have the tokens corresponding to your chunk 1 vector. And then at the end of it, you may have a CLS token or something of that sort to say that you have reached the end of sequence. And then what you do is you pass these tokens, the sequence of tokens, through this model, and then finally to a linear projection layer to produce one score. So this score will be a number like 0.58 or 0.76 or minus 0.2, which gives you an idea how similar are these two vectors. So if it is a large positive number, the similarity between them will be very high. If it's a large negative number, similarity between those two will be very low. And using these similarity scores, which you get for all the 15 pairs between your vector and the top 15 items, you can re-rank those 15 items into rank 1, rank 2, rank 3, etc. And then you can concatenate maybe the top 3 items from the ranking to produce the generated response. So to produce the generated response, you are passing two things into your large language model. One will be the user query itself. Another will be the top 3 items or top 2 items from your retrieved re-ranked output. When you say linear projection, will we have to modify the GPT models and produce rank value? So this is not a GPT model, by the way. These are pre-trained models which are trained on producing good similarity scores. So it's like a model that already understands language, but on top of it, you would have done some fine tuning, where the fine tuning is such that you give it pairs of vectors and you give it a similarity score to predict. And when you train it on large data set like that, it will know how to predict a number corresponding to any given pair of vectors. And that number will signify how similar the given vectors are. Right. So yes, of course, you will have to fine tune the model. You won't be able to use off the shelf models like GPT. There are a couple of questions. How frequently do we have to do indexing phase? Example, my information is not constant and it will change periodically, weekly per se. Yes, very good question. In that case, if the new information that you are getting is relevant to your retrieval, you will have to do the indexing as frequently as your information changes. In many companies, however, the base document which produces the index is not that much frequently changing. In our case, for example, in our email reply agent, we will be changing so right now I have deleted the RAG database, not deleted, I mean, I have deactivated the usage of RAG database for the time being. But however, if I am continuing to use RAG, I plan to change my indexing. I plan to implement indexing once in 2 months, something like that, once in 2 months or once in a month, because in 1 month we accumulate roughly maybe 2000 email threads or something. So already I have 10,000 email threads, maybe into additional 2000 email threads add a little bit of value. So I run this indexing once in 1 month or once in 2 months, but this per request happens like 100, 200 times per day. We will discuss some more details about what type of chunking should we use. There are different types of chunkings. There are different types of embedding models. There are different algorithms for finding similarity between vectors. There are different models for performing re-ranking. Although we will be today implementing one model because we won't have time for everything, we can discuss that a little bit. So this we have already discussed. So let's discuss a little bit about document ingestion options. So three most famous document ingestion options that you may come across. This you may have heard of, LangChain document loaders. Today we'll be using a LangChain document community loader. You may have heard of dockling. Dockling is very, very interesting. Recently, we had worked on a project where we built a RAG-based retrieval system for fetching documents from OpenForm library. So OpenForm is this multi-physics software library, and it's actually very difficult. So when you're performing some sort of multi-physics simulation, if you are an engineer working on something like this, it's very tricky to get solution to your problem. You will be stuck. I have worked on this back in 2015 to 2018 in different projects, and it's very difficult. Either you should have some PhD student who have worked on similar problem with you, or you should have the skill of reading the documentation or reading the wikis or reading the tutorials to understand what the solution for your problem would be. So there is a pressing need for some sort of a RAG-based chatbot or RAG-based platform which can fetch information for anybody who's working on multi-physics based in open form. So when we were working on that, one of the challenges was, okay, what chunking strategy would we use? So there we ended up finally using dockling. So dockling is really good at handling different types of documents with images as well as text as well as tables and everything, but it's a little bit slow. In fact, it is 50 times slower or 100 times slower compared to something like PyMu PDF. So PyMu PDF for very quick applications, you can use PyMu PDF for document ingestion. Document ingestion is not chunking. Okay, document ingestion is the step before that, like the raw information which you have from PDFs, websites, or any other or TXT documents. How do you convert it into a data format which can be used for chunking, right? So PyMu PDF, if you read Reddit, you will see people praising PyMu PDF a lot. Simply search PyMu PDF versus dockling. You will literally come across hundreds of articles saying how amazingly fast PyMu PDF is and how well it works for most of their applications. But in our case, we noticed that although PyMu PDF is very fast, dockling works much better for chunking because of the complexity of our document. In industry grade RAG, you typically need OCR grade data extractors such as Mistral OCR and DeepSeek OCR. Yeah, 100%. So you can use either that or, in fact, Tesseract OCR is also very good. So implementing any of these techniques is not a difficult thing. It's a matter of importing the required library and implementing it. Then the question will come about. What is the volume of your data which you are ingesting? How frequently are you changing the? Yes, this is the correct link. I think dockling.ai. Yeah, I mean, we don't go to the website that often as just importing the library, but I think it's the correct website. But what I was saying was the choice of this will come finally down to what type of document are you using? What type of data is there in your document? Is it images? Is it tables? Is it text? Or is it a mix of those? Then whether you prefer speed of indexing that much or whether you want a mix of speed versus accuracy, right? Some of these, yeah, Tesseract OCR, in my experience also, I have used it only like a handful of times. It has not given me some output which I found very useful. In my experience, just because PyMu PDF is very fast, if you want to try something out, if you want to see how well your RAG pipeline may work downstream, PyMu PDF will give you very good start. And then if you can check how well it works, and if you want to go ahead to build a production level system, go ahead with using any maybe DeepSeek OCR or any OCR based document ingestion pipeline, or try dockling. Firecrawl, I have heard it's amazing. I myself have not used it in any project recently, or in fact any time. I think I don't remember using Firecrawl ever. Can you also show how can we modify the bounding boxes to customize OCR extraction? That will be a bit off topic, but I can figure out how to create something to answer that question. Yeah. Oftentimes we need to modify the bounding boxes for some complex PDF for 100%. So in document ingestion for today's purpose, we'll be using this LangChain document community loader. But you could also very easily replace, I can give you a homework where you could replace that with PyMu PDF or dockling or any other. Llama index data connectors, document ingestion pipeline is good. Unstructured.io is very famous. I have seen many teams in the companies where we partnered with, they had tried unstructured.io for some of their projects. Beautiful Soup is extremely famous. Their GitHub is very, very popular. So it's very difficult for you to figure out for your project what actually works. Sometimes you have to try something out to actually get a sense of what may work for your project. In general, for complex documents, do not go with PyMu PDF or Tesseract. Just go with Dockling or some OCR based techniques. Then when it comes to chunking, so this is something which many of you have asked for. Okay, wouldn't vision models of LLMs be used for ingestion? Actually, you know what? In many cases, if you are directly converting your document to tokens, right, using a vision transformer or something, it's very expensive. But OCR is a much better way. So in most of the multi-modal large language model, one of the first steps is, if you give an input, one of the first things that you do is OCR, like a character recognition through opticals. You might have read the paper. Have you read the DeepSeek OCR paper? It's actually beautiful. What their conclusion is something interesting. It's like text data, if you are representing it as an image or PDF, right? You can reduce the number of tokens surprisingly by 90% or something, and still retain 95% of the information. So then it was mind blowing, because at that time when the paper came out, I think it came out some few months ago. I don't remember the exact month. But I was working on image. Then I was thinking, what is so fundamentally different about image tokens constructed using image and tokens constructed using text? One fundamental difference is that text is sort of more coarse. What I mean by that is, if you are showing the image of a cat, you cannot just verbally say cat, right? You have to show every single pixel that defines the cat. Those pixels define what is a cat. But to represent the broader idea of a cat in text, you just need the word cat. So somehow the expressive power of images and expressive power of text are completely different. And it was so surprising to me that I would not have guessed it. Like, it was so surprising to me in DeepSeek OCR paper to see that. Thanks for sharing the DeepSeek OCR paper. That even when you represent digital text using images and try to extract information out of it, you will still retain a majority of the information. I think there was the first paper. Let me just OCR. Yeah, this one, context optical compression paper. Just so this is the first paper that came in. It's came in the series of DeepSeek OCR papers. But just read this one line. Experiments show that when the number of text tokens is within 10 times that of vision tokens, that is a compression ratio less than 10, meaning vision tokens are 1/10 that of the text tokens, the models can achieve decoding OCR precision of 97%. Even at a compression ratio of 20x, the OCR accuracy still remains at about 60%. Meaning you are only having 5% of the tokens when you are representing something visually. Even if that is the case, the information retained, the amount of information that is retained in terms of accuracy score is 60%. So this is really, really mind blowing. And I think there is a lot of scope for some fundamental research in this whole area, not about DeepSeek OCR, but in general about information, the amount of information retained in optical representation of the same text versus textual digital representation. It's really fascinating. Anyways, that was a digression. So coming back to chunking strategies, there are few different chunking strategies. You yourself can imagine, if you are asked to chunk a document into different sections, if it is a huge, let's say, internet database corpus, which will have all sorts of things in it, you probably will say, okay, I don't know what all structures exist within this data because it's so vast and so huge. Maybe I'll just define fixed size chunks. So I will say each chunk is like 200 characters, something like that. But if you have a document, for example, the Microsoft document, which we will be using today, that document has sentences, that document has paragraphs, that document has subsections. So dividing it into fixed size chunks won't make sense. Why is that? In your opinion, can you mention in the chat, why do you think fixed size chunking is not a great idea always? What's the downside of it? the downside is that, let's say one paragraph number A has information related to quarter one report of Microsoft stock performance in 2025. But then let's say you are chunking it such that the fixed size is only 200 characters. Maybe then that entire paragraph will get divided into three chunks. Whereas in reality, it need not be divided into three chunks, because that entire entire paragraph is talking about one thing, right? So basically what happened is your information, which was semantically completely related to each other within one paragraph, got divided into three different parts. So that is the downside of fixed size chunks. The good thing about fixed size chunks is it will work for complex long data, which has many different formats present in it, like internet corpus of data. And there, if you have no idea what is the perfect way to split it into chunks, you can simply go ahead with fixed length chunks. Semantic chunking is where you look at the meaning of the chunks rather than the sentence length, or whether it is ending in with a paragraph, or whether it is ending in a subsection, etc. So you are creating chunks based on meaning rather than based on the structure of the language. Structure of the language will say a chunk should end with a full stop, maybe because sentences end in a full stop, paragraphs end in a full stop. But semantic chunks need not be like that. Semantic chunk can also divide your sentence in the middle, which is not a problem. Now, I have a question. If you were to implement semantic chunking, what would you need? Because how can you say that this part of the chunk is semantically carrying this meaning, and another part of the chunk is carrying another type of meaning? Sure. Headings are fine. That chunking is anyway there, but you will need some sort of embedding, right? So you will create certain chunks initially. You will create embeddings, and then so what you can do is something like this. So let's say you have 4 sentences, okay? And you may do something like this. Let's say your space is a 2-dimensional space. You will say this chunk number 1, the vector corresponding to that is over here. For chunk number 2, vector corresponding to that is over here. For chunk number 3, vector corresponding to that is here. Chunk number 4, vector corresponding to that is here. Now, what do you see from this? If you say you want to do semantic chunking, which chunks can you group together to create one single chunk? 1 and 2 can be represented using one single chunk, right? Because look at the similarity of the cosine similarity of the vectors. The vector corresponding to this and this are very similar. The cosine of the angle between those vectors is close to cosine of 0, which means it's very similar chunk. So these two can be converted into one single chunk. Similarly, if you look at these two chunks, they are semantically very close to each other. And what that means is they can be grouped into one single chunk. Now you will do this repeatedly until you will either reach a maximum chunk size or you will reach a maximum chunk number in your document, if that is one of your constraints. So if you say my chunk size is 500 characters, you will join different chunks which were split based on paragraphs or some other delimiters. You will convert that into one single chunk based on the cosine similarity of the vectors corresponding to that. So for semantic similarity based chunking, you will need some sort of embedding model. Then there is another chunking, which is called as sliding window chunks. So sliding window chunk can also be used in tandem with fixed size chunks or any other chunks. But basically in sliding window chunk, what you do is you will say, this is my sentence. Okay. I will define one chunk where this is my chunk number 1 and this is my chunk number 2. So some of the ending characters in chunk number 1 and some of the starting characters in chunk number 2 can be found in both chunks because there is a little bit of overlap. What is the advantage of doing this? Why is it advantageous to create chunks that have some sort of overlap between them? So what may happen is, if you have chunking without overlap, there will be no, when you have overlap, some context in chunk number 1 is also present in chunk number 2. So if both chunks are related, this context will ensure some sort of continuity in the semantics or in the meaning between chunk 1 and chunk 2, right? So this sometimes these two sentences are almost saying the same thing, although when you read the words, you may not feel like they are not they are the same continuous paragraph. But then suddenly when you have a overlapping section in between, it will help you understand that, oh, actually the second sentence is a continuation of first sentence only. So information is carried forward from chunk 1 to chunk 2 in a slightly more efficient way. But what is the disadvantage of this? Why can't I just then increase the overlap like this? I have 60% overlap or something. What happens if I do this? It simply produces a lot more chunks. So it may increase accuracy and everything, but my indexing will be super slow. The number of chunks that I have will be so high, and the most extreme case of this is 100% overlap, in which case there is no point in doing what we are doing, right? So we have to have some level of overlap, maybe 10% overlap or 20% overlap. In the example that we will do today, we'll see about the 20. We will look at the case where when we have 20% overlap, meaning 500 characters per chunk and 100 character overlap. Then there are even simpler chunking strategies like sentence-based chunking. Sentence-based chunking is you literally look at where the period is coming. So it need not be like one chunk equal to one sentence. It can also be like one chunk equal to two sentences. But chunk boundary will always come in between sentences, wherever the period is coming, right? And the most interesting way of chunking, which we will be doing today, is called recursive chunking. So recursive chunking, what it does is, if you have a big document, all right, this big document can be split into sections. It can be split into paragraphs. It can be split into sentences. It can be split into words. And then you will decide, depending on the size of the chunk, whether an entire section will be one chunk, or an entire paragraph will be one chunk, or a few sentences will be one chunk. So let's say your chunk size, maximum chunk size is 500 characters. Let's say you may have a Microsoft financial document with one subsection 1.1, which is just one small paragraph like this. But then you may have a subsection 1.2, which may have two big paragraphs. And let's say this paragraph is 500 characters. This is 500. This is 500. So in this kind of chunking, this whole subsection is chunk number 1. But then the subsection 1.2 is actually not one single chunk. It's actually divided into two chunks. So depending on the length of each sections, the one entire section may be found in one chunk. One entire paragraph may be found in one chunk. Maybe just 2 or 3 sentences may be found in one chunk. It depends on your page structure. So today we will see how this recursive chunking output will look like after we do the chunking. Okay. Then this we have already discussed, data converted to vector. So one thing I want to reiterate is your chunks are converted to vectors. So these are all different chunks. But then into that same vector space, you also need to convert your query. That's when you can compare cosine similarity or dot product or any other similarity metric, L2 similarity between this vector and your chunks. Okay, so that is one thing you should remember. So whatever embedding model is used for producing vector representation of chunks, same embedding model will be used for vector representation production for query. And for embeddings, there are again many different options. These are all language models which can produce very good semantic representation of languages in the form of vectors. So just let me ask you a question. What is the primary difference between BERT model and GPT? Like, is BERT a language generation model or is it something else? So the main difference is that BERT is a very good model for understanding language, because BERT is not trained on next language prediction. BERT is basically trained on masked language modeling. So if you have a sentence like the cat sat on the mat, you will produce mask tokens in between. The mask sat on the mask. And the BERT model is trained in such a way that this mask token, whatever the token associated with this mask token, that is what the model is by default taught to predict, right? And because of this, BERT as a model, it's really, really good for encoding the language. So similarly, here what you actually need is, you don't want a model which is like Chat GPT. You want a good representation of the model in vector space, which can capture the meaning in the language. And where is the language coming here? The language is coming in chunks. So you want a good vector representation of those chunks, which are languages, in a embedding space, which means you can use any good language model for this task, but there are specified specialist models like sentence transformers or OpenAI embedding. So this will not look like exactly like GPT. It won't be performing next prediction, but it would rather be performing embedding. So language will be just converted to vector. There is no agenda of producing the next token. So in today's, and there are many, there are Mistral embeddings, there is Hugging Face embeddings. I have used at least 5 of these in the last several projects, but today we will be mostly using sentence transformer. It's very simple to use. This mostly this exact same model we can use, all mini language model. L6 means 6 layers, V2 means simply the second version of that model. So this we will use in today's project, and this I have already talked about, so I will not be spending more time on that. Oh yeah, so how do you select the dimensionality of your embedding space? Let's say you have one embedding space with 64 dimensions and another embedding space with 728 dimensions. What is the trade-off here? If your embedding space is small versus big, what is the trade-off? Big embedding space has more expressive power. If you have 728 dimensions to express a chunk, it means you are having more options, right? So more variety can be captured. In 64 dimensional space, you can only capture that many dimensional information. But the problem is again latency. So to perform similarity search in larger dimensional space could be difficult because there are a lot more options. If it's a 2-dimensional space, it's very easy. 1-dimensional space, very easy. If it is a 728 dimensional space, it's the difficulty increases. But then, so it's a trade-off between what may work for you for your specific case. It may depend on number of chunks that you have. It may depend on how fast you want the retrieval to happen, etc. Plus how good your chunking accuracy should be. If your entire PDF document is talking mainly about one idea, okay, would you rather go with the 64 dimensional chunking or 728 dimensional chunking? So I will rephrase my question. Let's say you have one huge PDF document, okay, and in RAG, you want to use this document to retrieve relevant sections from it. So that goal is unchanged. But this whole document is about, let's say, mostly one idea. Let's say cook a recipe of one single dish or something like that. So what may happen is the diversity of the information present in your document may not be that high. So if diversity is not very high, if you use a lower dimensional space, the vectors in the lower dimensional space may be very close to each other, which means the whole idea of chunking itself will be useless. Because why do you even create chunks in the first place? You want to create some distinctions between this section and that section and next section, right? So if your document has very little diversity, but you still want to produce chunks that are meaningfully separate from each other, you may want to use higher number of dimensions. But if your document already has a lot of diversity, right? It is like if it has many different words, let's say one part of the document is talking about quantum physics, another part is talking about cooking, another part is talking about some other thing, then already the chunks are very diverse. So when you use an embedding model which is not as powerful also, the inherent diversity in the input data itself will take care of the fact that you want to separate your chunks a little bit. So in that case, you can go with 64 dimensional chunking also. 64 is just an example, by the way, but you can go with lower dimensional chunks. So to capture nuances, you will need more dimensions. But if the differences are already inherently present in the data, you can go with lower dimensions. Then similarity search, there are actually many different ways in which the similarity between two vectors can be defined. These are probably the three most popular ones, but some of the complex vector similarity search algorithms use even similarity search like approximate nearest neighbor, etc. So I don't want to go into the details of this because that will simply prolong the lecture by a lot. But just understand that these are indices using which you can say which vectors are close to each other. Cosine similarity is just the cosine of angle. Dot product will also take magnitude into account. Euclidean distance is like square of the distances between the vectors. And now comes the most important thing, vector indexing, or how the database look like. You may have heard of most of these. FAISS is Facebook AI Similarity Search. This is extremely fast. ChromaDB is very popular. I had shared one document from Chroma day before yesterday about, I think it was about context rot. And Pinecone provides cloud vector storage. ChromaDB can run locally. It's very fast, but it's apparently not that accurate, but it's very fast. So here what it does is, can anyone tell me what's the difference between vector index or this vector database versus similarity search options versus the kind of embedding model that I use? What is the difference between those three things? Embedding model versus similarity search versus vector index. Let me ask you, what's the difference between these two? Similarity search versus vector index. Isn't similarity search already performing this the search between identical vectors, basically between your query vector and your vectors in the database? The basic idea is that this vector index, right? The different vector index provided by different libraries will be using one of the or multiple of the similarity search algorithms. So these are actually algorithms. Cosine similarity is an algorithm, is one way to define similarity. Dot product is one way to define similarity. Now, these algorithms, for example, Facebook AI search algorithm might use this IVF, inverted file index, or it may also use ANN. I don't think it is mentioned here, but FAISS, in my understanding, it also uses approximate nearest neighbor. So it can use one or multiple of similarity indices to produce the similarity score between your query and the vectors already present in the database. The embedding model simply produces the vector. So this produces the vector. Similarity algorithm tells if you have two vectors, what is the similarity score? Vector index makes finding of the score between your query, and let's say there are 10,000 vectors in your index. How are you going to search for the closest vector corresponding to your query? Are you going to search one by one? Are you going to say, hey, let me pick the first vector from my store and I will compare it with my query. Then I'll pick second vector and compare it with query. Third and compare it with query. Then you will have to run it on the order of 10,000 times, which is very inefficient. So vector index makes this score finding very efficient. So in one of the projects that we did 2 years back, it was about, so there was a company, basically they wanted to build something for their client. Clients are like diamond merchants or jewelers or something like that. So if a customer comes saying, hey, here is a piece of jewelry, I want something very similar to this. That is what I'm looking for. And in their inventory, there will be, the store will have a lot of different jewelry items. So it's very difficult for them to know whether something similar to this, what this customer is looking for, exists in their inventory or not. And there we implemented similarity search. So we embedded the images as vectors and we did a vector search, similarity search. And there we could see that the difference between Facebook AI similarity search and a vanilla AI similarity search was day and night. It was huge. So this FAISS is very, very good. And in fact, today we'll be using Facebook AI similarity search. There are many other different ones. You may end up using any of this depending on your application. I can't say the details, unfortunately, of the company. Then there is one more question that you may have is what is LangChain and what is Llama Index? Basically, LangChain and Llama Index are basically overall frameworks which will allow you to implement all the things in the pipeline. It will allow you to implement document ingestion. It will allow you to implement chunking. It will allow you to implement any kind of vector database or many kinds of vector database. It will allow you to implement similarity search using indices. And then when you after basically the very last stage until retrieval happens, LangChain or Llama Index can take care of. Which one do I recommend? I actually honestly don't have a preference. I have used both, so I really can't say which one do I prefer. Um, so I will show you. There is one image which I wanted to show you. I don't know if I can find it. Uh, I don't have it handy, but I will share it with you separately. Um, Basically, these frameworks will allow you to stitch together different components. So RAG is a collection of different components, and these framework will allow you to stitch them very easily. LangChain is literally, it's a chain of, if you want to build AI agents or if you want to build AI frameworks, there are many different providers. There are providers for database. There are providers for chunking. There are different libraries for performing document ingestion. So LangChain, for example, will allow you to chain together different parts of that to produce one single pipeline. You can do without that also, but it makes it easy. Now let's discuss the one last idea before we will start coding, which is TF-IDF. So TF-IDF stands for term frequency inverse document frequency. So I'll tell you why this is useful. In many cases, before this modern natural language processing became very popular, the traditional NLP handled sentences in terms of words. So you could also create vector database for sentences. How can you do that? For example, let's say this is my whole vocabulary. The words are cats, drink milk, dogs, water, eat fish, right? So only like 6 or 7 different words are present in my entire vocabulary. So I can define like a 7-dimensional space. I can't draw it fully, but I can define a seven-dimensional space. And then I can say cats drink milk is something like first dimension is there, second dimension is not there. So if there are 7 dimensions and the word cats is the first dimension, word drink is the fifth dimension, word milk is the seventh dimension, those dimensions will have values, but rest of the dimensions will have zero values. So it's called a sparse representation. The typical vector representation that we discussed so far is called dense representation. Dense because along most of the dimensions, there will be some value. But in sparse representation, most of them will be zeros. Along some dimensions, there will be finite values. Then what we can do is, this is a solid example of how TF-IDF works to create re-ranking. Let's say you have 3 documents, okay? Or 3 chunks. Cats drink milk is one of them. Dogs drink water is another. Cats eat fish is the third. And your query is cats drink. Now, if we want to say, corresponding to this query, whether document 1 is the most similar or document 2 is the most similar or document 3 or 2 or 1, whichever is the most similar, we want to do that based on TF-IDF score. So let's see how to do that. So cats drink is our query, and there are 3 documents, n equal to 3. So first thing is calculating something called as inverse document frequency. So inverse document frequency is higher if the frequency with which a word appears in all the documents are low. Meaning, if a word is very unique to one particular document, it's a very valuable word, right? So IDF formula is logarithm of total number of documents divided by number of documents in which this particular word is appearing. So can you tell me what would be the formula for inverse document frequency for the word cats? So you have 2 words in the query. One is cats and one is drink. So cats IDF will be what? IDF for cats equal to log of n. N is 3 because there are 3 documents divided by cats is appearing in 2 documents, right? Document 1 and 3. It will be something like log of 3 by 2. Similarly, IDF for drink will be log of number of document is 3 divided by drink is appearing in 1 and 2. So again 2, same. So the IDF should be ideally same for both. So logarithm of 3 by 2, 0.405, logarithm of 3 by 2 for 0.405. So inverse document frequency is the same. This is not very useful as individual metric, which is the reason why we also introduced a term called term frequency. But inverse document frequency has one interesting thing. Just tell me this. If I have a word, let's say I have a book on some sort of children's story. Okay, so this is like a kids story book, and I have some query, and I want to find the answer for this query from this book. Now, let's say I have a in one of the queries, query number 1, and another query, query number 2. In this query number 1, one of the terms is quantum. In query number 2, one of the terms is, let's say, cat. Now, can you tell me in which of these cases, so this will be divided into chunks, by the way, in which of these cases inverse document frequency will be higher? In query 1 or query 2? This is query 2. When will IDF be higher? Is it for cat or is it for quantum? Let's think about it logically. Okay. If the user's query contains words like cat, how easy or difficult it is to find the relevant section from kid story, if it exists. So the assumption here is that if the user is asking a query, something about this exists in the kid story. So something about quantum exists in the kid story, something about cat also exists in the kid story. This is a big book. But then the frequency with which quantum may appear in a kid story book would be very rare, right? So the inverse document frequency for the word quantum will be a very high number because n, let's say the n is equal to 150, and quantum may be appearing in 1 or 2 places. It's not something which appears very frequently. So then it will be logarithm of 150 by 2, which is a very high number for query 1. Whereas inverse document frequency for cat might appear like 100 times, who knows? Then that will be a small number, logarithm of 150 by 100. So the rarity of the word in the query is one good thing you can leverage to find the appropriate section which you are trying to query. So if the word in your query is so rare, it's actually very useful for you. But then sometimes non-rare words are also useful. What if the user is actually asking something about cat? User is asking something about something related to cat, and there is one chunk here which contains reference to cat 10 times, right? So the frequency with which the term cat is appearing in chunks, yes, here each chunk you can consider to be separate document, correct? Kid story is not the document. Each chunk is a document in this case. And we are trying to find corresponding to the query that we ask, which chunk is the most relevant chunk, okay? But in the words of TF-IDF, which document is the most relevant document? So if in one of these documents or one of the chunks, if the word cat is appearing 10 times, that also has value because query 2, yes, the cat has very poor inverse document frequency, but the frequency with which the word cat is appearing in this chunk is very high. So that is the reason why one more term called TF or term frequency is introduced. So term frequency is the following. Let me copy paste this over here. So term frequency is in your query, you have 2 terms, cats, drink. Those are the 2 terms. So cats and drink. How many times does cats appear in document number 1? Only once. So this is the cats. So cats appear once in document number 1. Drink appear once in document number 1. This is drink. In document number 2, cats does not appear. So it is 0. Term frequency for cats in document 2 is 0. But term frequency for drink in document 2 is 1. And document 3, for that, cats appears once. So that is 1. Drink appears 0 times. Now that in TF IDF is basically the product of TF, term frequency, multiplied by inverse document frequency. So for document 1, for the term cats, TF IDF will be 1 multiplied by logarithm of 3 by 2, which is 0.405. That is 0.405. For drink also it will be the same. So for document 1, the total score of TF IDF will be 0.81. But for document 2 and document 3, the score will be 0.405 and 0.405. And you can see that logically also, you don't even need TF IDF here. If you simply look at your query cats drink, just visually, it is most similar to this one, right? It is not most similar to this or this. You can already see that because here cats drink is already present. So this TF IDF is also telling the same story because now the score is like 0.81, 0.405, 0.405. So after re-ranking, the order in which your documents will be arranged will be document 1 will appear first and document 2 and 3 will appear next. Similarly, and that's the reason why we are multiplying with the TF, because if we gave all the weightage to IDF, here in this example, if somebody asked from this kid story chunks, if the query had something to do actually do with cats, it should not be penalized just because the IDF score of the cat is very bad because cat is appearing 100 times in 500 chunks. But there is one particular chunk in which cat may be appearing 10 times or 50 times. And that chunk may have very high similarity to this query. And how do we capture the fact that 50 times cat is appearing here? In the form of TF, term frequency. The term frequency of cat in document number, let's say this is document number 11 or chunk number 11. In chunk number 11 will be equal to 50. IDF of cat in the whole document will be equal to logarithm of 1.5. And this will be a relatively small number. So the total score of the cat, considering this query and all these documents, will be 50 multiplied by logarithm of 1.5. So that will be a number which is probably not that small. Now, similarly, let's discuss quantum. Quantum has very high IDF, but its term frequency will be very small because quantum as a term will be appearing in only very few chunks, right? So only very few chunks will have term frequency, a high term frequency for quantum. For most of the chunks, quantum will have very low term frequency. So that is why term frequency and IDF creates a balance between a rarity and more commonly occurring words. Yes, exactly. So this is a very different type of embedding. We are not going to implement this, but I just wanted you to be aware of this. This is not a this also you can call as a vector embedding, but it's not a dense vector. It is a sparse vector. Why? Because here the vectors can themselves be, each dimension of the vector will be one word. So if your vocabulary has 10,000 words, each dimension will be one word. So every word in your query will be represented using one vector in a 10,000 dimensional space. But it will be a sparse vector. It will be a sparse space. Why is it sparse? Because most of the dimensions will be absent. Because the word, this sentence, for example, let's say I have 10,000 words in my vocabulary and the query is cats drink. Along one of the dimensions, along cats, I'll have a value of 1 or something. Along another dimension for drink, I will have a value of 1. But for all the other 9,998 dimensions, the value will be 0. So this will be a very sparse space. I just wanted you to be aware of this because in RAG, sometimes you use both approaches or a mix of both. Sometimes you use dense search. Sometimes you use sparse search. Sometimes you use hybrid search. So just be aware of its existence. Now, I think it's a good time where we can go ahead and implement RAG. One small thing is in your context window, typically 60% up to 60% can be reserved for output which you get after RAG, right? The of the entire context window. This is a poorly constructed context window, by the way, in my opinion. 10% generation buffer, even Claude Code throws a warning after I think 80% or 86% of your context window is filled. Okay, so now can all of you open Google Colab notebook, an empty Google Colab notebook? Let us start coding from scratch the RAG chatbot. All right. And one thing you will need is you will need either an OpenAI API key or you will need a Gemini API key. Other API keys are also fine, but the code, you will have to modify the code a little bit, which can be easily done using Gemini, not a problem. But I'm just saying, just in case. And API key is the best way for you to store API key in Google Colab is here. Press this key icon. You can add new secret and all the secrets will be over here. And this will be stored almost permanently in the sense that even after you close the session or even if you open a new Google Colab notebook, these things will be available. So all you need to do is like, you just need to enable it. So this makes your life much easier instead of storing it in temporarily and then having to copy and paste it again and again. This will store that hassle for you. So now we have to start this in a few steps. So first step is importing the required libraries. All right. Then after that, we have to write the code for uploading the document so that Google Colab can access it. Then third is we can have the document ingestion pipeline. If any of you want to follow the exact code that I'm writing, you can just use this link. Just take a copy of this if you want to use the exact code. So the libraries that we will need is, so we'll have to, before importing, actually, we have to install certain pip install. So pip install sentence transformers. This is for embedding. I can write it in one line, sentence transformers, then Facebook AI similarity search, which can run on CPU, FAISS CPU, LangChain. Then if you don't want to write everything in one line, just write again pip install PyPDF. So I'm not using PyMu PDF here. I'm using PyPDF. Anything works, does not matter. And then LangChain community. Then pip install LangChain text splitters. You will see when we come to the part where chunking and all are implemented, where these things are used. So just add these things and run it to install those libraries. Just name this as RAG chatbot from scratch. I had already installed this. That's the reason why it says requirement already satisfied. All right. So this should not take you more than like few seconds. It's very fast. So once this is done, we can write the code for uploading the document. So uploading meaning it's a PDF document. So from google.colab, import files, then uploaded equal to files.upload. So we are using this files.upload function. And then for file name in uploaded.keys, because you could also technically upload multiple documents, but uploaded.keys will fetch the file name corresponding to whichever document you upload. You will see that in a moment how it works. Print uploaded. This is just to see if whether the upload has finished successfully or not, comma, file name. So now when you run this, it will ask you to click and upload. So here it is asking to choose a file. I can choose it from my desktop, but in case you want to have access to the same file which I'm going to use, you can search Microsoft shareholder report 2025. And I think it is this page only. Yeah, go to this page and do Control P. If you do Control P and save as PDF, this whole thing will be saved as, I think, when I saved it, it was 98 pages. Here, I don't know why it is showing 67 pages, but doesn't matter. So I'll share this link with you. Just go to this page, do Control P for printing, and it will save this annual 2025 annual report from Microsoft. So I already have downloaded it on my desktop. So I'll just go to my desktop and Microsoft. Okay, so uploading is done. The last sentence, uploaded Microsoft 2025 annual report .pdf. How to download? Just do Control P. Control P is the print command after going to the website, and it will ask you option to print and then save as PDF. Just save it as a PDF in your local. Otherwise, if this is not a very big document, I can also try to share it here in the chat. I don't know. Oh, it's 1.8 MB. I'm directly sharing it in the chat here, so you can download it from the chat. Uh, all right. So when you run this, it will ask you for choose files. The button will be there. Just click it and upload. Now the next part, from langchain underscore community dot document loaders underscore loaders import pi with capital P. So upload option you will get only when you run this block of code from google.colab import files. Only when you run that, you will get the upload option. Import pi PDF loader. And this is actually not loader, this is loaders. And then PDF underscore file equal to list of uploaded dot keys. So uploaded dot keys was also referenced here, which will be the name of the PDF document which we uploaded. Of zero means you are referring to the zeroth document which you have uploaded, which is this Microsoft annual report. You could upload multiple documents also. Then loader, this is where the ingestion is coming into picture. So instead of PyMu PDF, we are using PyPDF. PyPDF loader of PDF underscore file, which is this name, PDF underscore file. And then documents equal to loader dot load. So this is just a function that we have to call from this loader object, and print number of pages loaded, and this is equal to length of the document. So this PyPDF loader basically creates it such that it recognizes page 1, page 2, page 3 separately. So len of documents will tell you what is the total number of pages. Okay, so if I just run this, you will see whatever that number of pages in the PDF is. And this part may take a little bit of time. It's not as slow as chunking or anything. It's just document ingestion, but this may take a few seconds. Has anyone reached till here? Is everyone on track? Did you upload the document? Okay, awesome. Okay, so print number of pages loaded is 98. So there are total 98 pages in the PDF. I thought it was 68. I don't know why here it's showing 98. Maybe I downloaded a different document or something. Anyways, doesn't matter whether it's the same document or different document. Not able to import LangChain community loaders. Is there any spelling mistake? Like, or did you install this pip install LangChain community? This you will have to do it. All right. Then we can just print one more thing. Print documents of 0. Can you tell me what is this? What is documents of 0? Len of documents is the length of pages, which means documents of 0 is the content in the first page, basically. And first page you can actually see here. Let me open the file. It has not opened yet, but basically the first page is this. It's not here. When I printed it, it was this. You see, it's like a table of content. So whatever is there in this first page is getting printed when I say print documents of 0. If I say print documents of 3, whatever is there in third page will get printed, and that are these paragraphs. Okay. So it's just to see whether whatever we have loaded is the same thing as what we intended to load. Now, what is the next step after ingestion? Chunking. Yeah, so the required dependencies are these. For installation, these are the ones. And after you install, these are the imports. Only one thing you need to import. From LangChain community, document loaders, document loaders, import by PDF loader. Okay, so document has been loaded perfectly. Everything is good. Now let's perform chunking. So for chunking, you have to use from LangChain underscore text underscore splitters import. So here we use recursive splitter. So recursive character text splitter. So, and then text underscore splitter equal to recursive character splitter of. And then here we have to define chunk size. So let's say chunk underscore size is equal to 500 and chunk underscore overlap. So overlap between individual chunks is let's say 100. So here 500 is the number of characters per chunk. 100 is the number of characters that are common between first chunk and the next chunk. So which means 20% overlap will be there between two chunks. Then chunks, this is where chunks are defined, is equal to, just copy this text underscore splitter dot split underscore documents, which is the function. And here we have to pass the documents that we defined here, which is the variable documents itself. So this documents we have to pass, which are documents defined in pages. Now the chunking is done. Now, if we want to see whether the chunking has happened or properly or not, print total chunks created, and that will be length of simply chunks, because number of chunks is length of this variable chunks. So if we run this much itself, we can see whether chunking has worked effectively or not. We can print a sample chunk a bit later once this is done. So total chunks created 583. Okay, so chunking is successful. And then print, this is just to display one of the chunks. So from the 0th chunk, so chunks of 0, this will be one particular chunk. We want to display the content of it. So page content, we don't want to limit it. We can display the entire page content. So if we run this, see, so 0th chunk, from the 0th chunk, we are displaying all the content. So this is the 0th chunk. Okay. From LangChain text splitters, import number of chunks is 706. Okay. Are you using chunk size 500 and overlap 100 or different? I don't know if we are all using the same document or not. Ideally, there should be no difference because everything else is the same. Okay, so I think people who is using 67 pages, it's a different document. Mine is 98 pages. Okay, so I want to show you one thing. Okay, so here this is the 0th chunk. Then let me also print chunk number 1. So look at the last, in the first chunk, in the 0th chunk, look at the last few items. Investments, derivatives. This is from the page 1. Okay, in my page 1, it's like the table of content, investment, derivatives, these things. Those same things are being repeated here. You see, investment, derivatives. Why is that? Why do you see the same thing here and here? Because of the exactly sliding window. We have defined a 100 character overlap. If overlap was 0, the second chunk will start exactly where the first chunk ended, right? So chunking is working perfectly. This is what it means. So now we can generate embeddings from the chunks. So import Facebook AI similarity search, import numpy as np. Then from sentence underscore transformers, import sentence transformer. So this is where we convert the chunk into embedding using sentence transformer, a very specific model. Then we say embeddings. Before embeddings, we can define the model equal to sentence transformer of. So just copy this. We have to pass the name. The name is all mini. Number of layers is 6 and v2 version 2. So this has, I think, around 300, no, 22 million parameters. This is not a very big model. Compared to small language models, this is even smaller than that, because even SLM, small language models themselves, have 1 billion parameters. This is only 22 million parameter model, roughly. Then using this embedding model, we can create embeddings. So embeddings is equal to model.encode. So using the sentence transformer, we are encoding. And what are we encoding? We are encoding the chunks. So chunk dot page underscore content. And this we have to do recursively for every chunks. So for chunk in chunks. So for each chunk in the chunks, so chunks variable is defined over here. We are recursively converting the content of each chunk, which is chunk dot page content, into encoding using the model all mini L6v2. It's a sentence transformer. Then we can say dimension equal to embeddings dot shape of 1. So this will just store the dimensions of this model here so that we can print it and see it. Then we need index. Index is equal to Facebook AI search, Facebook AI similarity search dot index flat L2. So flat L2 we had defined it is the L2 difference between two vectors. It's neither cosine similarity nor dot product. It's the fourth item which we had discussed in the, it's the square of the distance between two vectors. L2 of dimension, because we have to pass how many dimensional space are we looking at to calculate the distance between vectors. And then index dot add np dot array of embeddings. And print. Now we can just say, I want to have a look at how this looks like. So total vectors in the index equal to index dot n total. This is the total number of vectors. So when we print this, can anyone tell me what should be the output of this statement? When I run this, what is the number that we are going to get? It should be same as the number of chunks, because each chunk is getting converted to a vector. So mine is 583 or something. Yours should be 700 ish if you're using the other 67 page document. This embedding also may take like 1 second. Oh, one more thing is you may need a Hugging Face token. So I have it stored here. So you will have to get a Hugging Face access token from Hugging Face, but I'm just clicking grant access. There is some issue here. Local and not valid model identifier. This is a private repository. Make sure to pass a token. Sure, we can pass the token. Mini LM. Yes. Thank you so much. So my Hugging Face token is also stored here, HF token. And you see, when I grant access, automatically this is ticked. Or if I already tick it, it will not ask me to grant access. Access is already granted. So this is just verbose that are getting printed while we are importing FAISS and creating the index, but this may take a minute to finish. Okay, that is done. And see, total vectors in the index is 583. Okay, so that is also perfectly working. Now, an interesting thing we can do is we just want to see how our chunks look like in our embedding space. It's a how many dimensions were there? I should just print this. So print dimension. I think it's 384 or something. Yeah, so it's a 384 dimensional space. What if I want to just visualize how one vector looks like? It can be easily done. So import matplotlib dot pyplot as plt, and then numpy I think I have already imported. Define visualize embedding, and here we will pass a vector to visualize. We will pass a corresponding chunk text equal to, by default we are not passing, then max text characters is equal to 500. Sentence embedding will be downloaded and hosted in collab, and will context and will remain available. Correct. Remain available in the current session. If you quit the session, I think it will be gone. I don't know if it is stored in the temporary storage or between session. I don't think it carry forwards between one session. If you and terminate the session, I think your the downloaded sentence embedding is gone, if I'm not wrong. Okay, so define just visualize embedding. We are passing the vector chunk and the size, max size. Then vector equal to np dot array of vector, this vector. Then normalized vector, we are just normalizing it before visualizing. Normalized equal to vector minus vector dot min to find the minimum value inside the vector. Then divided by vector dot max minus vector dot min. I can just copy paste this. So normalizing it such that the range of values are between 0 and 1. Then color band, just to define the colors of my visualization, equal to normalized dot reshape 1 comma minus 1. You will see the output when I print this. And then if chunk underscore text is not none, then print chunk text and the next character /n, then print chunk underscore text and print the first 500 characters, max text characters, and just print. And then matplotlib plt dot figure of fig size equal to 12 comma 2. So it will be like a row. It will be a very long figure horizontally. Then plt dot im show of color band comma aspect equal to auto and color map equal to viridis. This is very standard in all vector visualization. I have used this in many times. The tick marks on y-axis, y ticks, plt dot x label, just to see what the chunk is. Embedding dimensions. This is just to display the embedding dimension, but we don't need it. We already know that it is 384. Len of vector, and then plt dot title of vector representation. This whole function I can actually share with you. You don't necessarily have to write it. Plt dot show. So this is just the function. I don't think there is an issue. I hope it works. So this is the function just to do our visualization. And if you want to visualize one of the random vectors from our chunks, the embedded chunks, just call the function. The function name is visualize embedding. And into this, we passed one of the embeddings. So embeddings of, let's say, 1. And then we also pass the corresponding chunk. So we say chunks of 1 dot page content. Then if we run this, hopefully we should get the visualization. There is some issue. Embeddings of one. Let us ask Gemini. Okay, where this? It's very this. That's why. All right. So this is the vector. So basically, it's a 384 dimensional vector. Each color corresponds to the magnitude of that particular dimension, right? So each there is like a strip. So if this was like just 3 dimensions, you will just see 3 colors. But here you are seeing 384 colors. But this color band is literally how this whole thing is represented. And if you want to see how some other chunk looks, let's say chunk number 5. So embedding number 5 and chunk number 5 you pass, you call the function. Now this is the chunk. Chunk is something about quarters approaching each day. So basically this whole sort of like three-line paragraph is represented using this one vector. So this color map visualization is so useful to see how the uh, sentence transformer has converted your input into just pure numbers. All right. It's just for visualization purpose, no other purpose. Now retrieval of the chunks. So query equal to input of enter your question. So this is where the user will ask the question based on the document. Then we need to convert the query to an embedding. So query embedding. And for this, we will use the exact same model that we defined up here. So here we have defined the model equal to sentence transformer. So copy that same thing equal to model of model dot encode of query. Then if you want to visualize how your query looks like, your query will look like visualize underscore embedding of query underscore embedding. So you pass the query embedding and the query itself. If you do this, you can just see how your query has become a vector. So let's say my query is how much profit did Microsoft make in 2025 compared to 2024. So let's say this is my question. That whole query will be converted to vector using my embedding model. So this is now how my question looks like. So now what is the goal of RAG? The goal of RAG is to see this color band is matching with which color band. So there are a lot of chunks, 583 color bands corresponding to chunks. Basically, it's like comparing these two vectors. Now d comma I index dot search. So index is the Facebook AI semantic search, the variable for that. Index dot search np dot array of query underscore embedding, and you are looking for top 5 similar items. Then retrieved chunks. Yes, we will also apply re-ranking here. Very good question. Yes, we will. Chunks of I for I in I of 0. Then we can just print it. Print top retrieved chunks. And then I can print the retrieved chunks in the next line. So /n for chunk in retrieved chunks. So we are recursively through a loop going through these retrieved chunks. Print chunk dot page underscore content. And then we say print. We also want to see these top 5 chunks that are closest to our thing, they are coming from which page, because that is very important for us to know. Where does this chunk come from? Meaning, where is the reference to this particular retrieval? Then we can say page chunk dot metadata, and from the metadata I want the page number as the metadata. And then I can just print, because we are displaying 5 chunks, I can just put some stars or something in between the 5 chunks, in between each chunk, and just run this. So now these are my retrieved chunks. I can just replace this with something else. So these are my retrieved chunks. Okay. So top 5 chunks. This is the first chunk. And you can already see that my question was, what was the profit in 2025 compared to 2024? And you can see 2025, then 2024, 2023, etc. This is the first chunk, and this chunk is coming from 9th page. There is another chunk coming from 23rd page, another chunk coming from 87th page, and then 2 more chunks. So totally 5 chunks. These are the top 5 chunks corresponding to my query. Then we need to perform re-ranking, because what if this is not the order in which the chunks are most appropriate to my query? Then we say, there is a question from Sandeep. Can re-ranking happen within the retrieved search itself and retrieve based on highest similarity search? The re-ranking model is actually, think about it. In re-ranking, you are comparing every query with the chunk. Now imagine you have to do that for all the 10,000 chunks. It's very time consuming. So re-ranking you do separately only for the 5 chunks. If you want to do it along with the retrieval, it makes the process very slow, because you will be retrieving while also looking for similarity search. I mean, not retrieving, I meant to say re-ranking. You will be re-ranking while looking for similarity search. So you don't do re-ranking while doing that. You first find the top 5 similar things, and then you re-rank using a either similar sentence embedding model, or an even more powerful one. And by the way, sentence embedding model for re-ranking is not producing vector or anything. It's producing a score. It's producing a score like a zero 0.5 or minus 0.6, etc. You will see that in a moment. So here, from sentence transformers, import cross encoder. Cross encoder, because you have 2 sequences here. You have sequence corresponding to query and sequence corresponding to the chunk, the 5 chunks. Re-ranker equal to cross encoder of cross encoder /ms Marco mini language model L6 V2. And then the pairs that we are passing into the re-ranker are query, comma, chunk page content. So chunk dot page underscore content. For chunk in retrieved chunks. And I think there is a, yeah, I think this is correct. Then scores is equal to re-ranker dot predict of pairs. So basically re-ranker will predict between the query, comma, chunk pairs. There will be 5 such pairs. What is the score for each of the pair? And then ranked chunks equal to, you just sort it based on decreasing order of score. Scores, comma, retrieved chunks. And then lambda reverse equal to true. So highest one should come at the top, lowest should come at the bottom. And then print after re-ranking, we just want to display the order in which chunks are appearing. For score comma chunk in re-rank chunks. Print score comma score. So this will print the score corresponding to the top chunk, and we will do that. Also, do we get any difference in output when we use different embedding model for query and our knowledge base? We can't use different embedding model, right? Because the embedding models will be completely living in different spaces. So we have to use same embedding model. Then score is printed. Then let's print the chunk dot page content. Then what else do we need to print? Print page number, also print chunk dot metadata of page. So page number is chunk dot metadata of page. And then to just separate between the different chunks, I can just print like a dot dot dot. All right, so now let us run and see. So one thing, the way to see if the re-ranking has changed the order is look at the order in which my initial chunks are appearing. 9, page number 9, 23, 87, 29, 29. I'll just write it somewhere. 9, 23, 87, 29, 29. This was the order in which it was originally appearing before chunking, before re-ranking. So after re-ranking, let's see if something different happens. So yeah, so after re-ranking, see 29th page chunk in the 29th page has come to the top. So after re-ranking, the order has become 29, 87 pages a second, 23, 29, 9. So the order is literally 29, 87, 23, 29, 9, I think. So this is after re-ranking. So before re-ranking, the chunks were appearing such that one of the chunks from page 9 was at the top. But then you look at what has happened after re-ranking. I think the 9th one has went to the last. And let's see why that happened also. And look at the score. Score is 0.488158 what was my question? My question was, compared to 2025, how much has the revenue changed compared to 2024? So here it says, in this chunk, look at what it says. An increase in office transactional purchasing with the launch of Office 2024. Consumer product and cloud services revenue increased $760.56 million. Microsoft 365 revenue grew 11%. Consumer subscriber growth of 8%. So look at this. This has the actual information which I asked, right? The last one does it have the information? Microsoft Corporation. I think this is the stock price of Microsoft, probably not it's the share price. I don't think it's the revenue or anything in this last one. Maybe I'm wrong. I don't know what this 100, 140 means. It's probably the share price. But so the re-ranking has actually helped us to find out the most relevant chunk to the top. Now what we need to do is there a chance the most similar chunk to the user query is not from the top 5 chunks? It is possible, which is why you have to sometimes increase the top 5 instead of top 5, do top 15. But then the problem is sometimes you will have a lot of chunks that are also useless. Then you will have to remove some of them after re-ranking, right? Now let's append combine the re-ranked chunk with the context. So combine re-ranked chunk with context. So top underscore chunks equal to chunk dot page for underscore. So first, whatever is returned first does not matter, comma chunk in ranked underscore chunks of 3. So only top 3 we are picking. From the re-ranked chunks, the top 3 we are picking. Remaining 2 are being discarded. Then context is equal to /n /n dot join. So just adding a next line character at the top. Then join top chunks. So these chunks are joined. Then print context. So we can just see when we join the top chunks, how the total context looks like. Just run this. So now this is how the total context looks like now with the top 3 chunks after re-ranking is combined into one single sequence of tokens. Now the last step is generate answer using LLM. And this is where you might need OpenAI or one of the APIs, Gemini or OpenAI. So here import, I'm using OpenAI. Then from google.colab, import user data. Then prompt is equal to we don't need to give this, but I'll just write this. Answer the question using the context below. So this is the system prompt which we are giving to the LLM. Then context is the context which we just created using the chunks. So what was the variable name? It was context only. Then query question is, I think the variable name was query or something. Yeah, the variable name for our query is query. So given the context for the query, answer the question. Then provide a concise answer. One more thing we could tell the LLM is, if you don't find the info in the context, do not guess. Say that the info is not found in the document, because this will help us from preventing the LLM, defaulting to its, it is trained to say something, right? It has some information about Microsoft and the world and its stock price and everything. But we don't want it to answer if the information is not present in the document, because that will be hallucination. Response equal to client.chat.completions.create. And then here we say model equal to one of the models. Any model is fine. GPT 4o mini. Then messages that we pass, messages equal to the role and the content is this prompt. And I think I'm having any client equal to OpenAI dot OpenAI, and then API key equal to user data dot get OpenAI key. And I already have it over here, so I should just enable it. So I had saved the OpenAI key here. So this is where you will have to save your own OpenAI key, and then answer equal to response dot choices dot message dot content, then print answer. We have to copy paste the, yes. So in the API keys section for OpenAI, there will be one place where you have to just simply copy. There will be a copy icon. You have to just copy that. Print answer and then /n comma answer. So let's just see, let's run this to see if we are getting the actual answer. The answer that we are expecting is the answer for the question from 2024 to 2025. By how much did the revenue increase? There is some issue. Message does not exist or you do not have access. Excellent. So I just need to make sure that my API key is correct. Mm, GPT-4. Okay, there is a typo. Oh, yes, for sure. It should be 4.0. And yeah, there is another issue. Your account is not active. Please check. Okay, I think my account might have exceeded the billing, which is why I have another account. If anyone has reached this till this point, just let me know. If you have, I think my API keys might have expired. I will have to recheck this once, or my credits would have run out. Let me. I'll ask Gemini to change this part so that I can use Gemini API key. Change this code so that I can use Gemini API key. Just let me know if you have received any output yet. Like it will ask for a box where you have to enter the response, enter the query, and then it should produce a response. And Gemini API key I haven't set yet. So let me just set that. Okay, it should be named as Google API key, not Gemini API key. So okay, and API key is not valid. Excellent. This is very frustrating to not know which of my API keys have gone expired or credits ran out. Yeah. I think in the key I copy pasted the Google thing itself instead of, yeah. Let me just check this. I'm sure one of these keys work. Okay, I think this is a different issue. Gemini 1.5 Flash, I could just change it to 2.5 Flash because some of these have deprecated. So how about this? Okay, so the answer, okay, this is the answer that LLM gave. The context provides revenue figures, not profit figures. Therefore, the information on how much profit Microsoft made is not found in the document. Very good. So that is a good response. But then let me ask for revenue figures. So I will run starting from the query. Actually, I have one more block of code which you can directly copy paste. It's just for running the chatbot continuously, okay, without having to go back unnecessarily. Uh, Let me do that once. Okay, query what by how much did the revenue of Microsoft increase from 2024 to 2025? What is the 2024 to 2025 revenue increase? Okay, now I don't know what's the new issue. Explain error. Just let me know, guys, if any of you managed to get it correct so far. Should not be difficult. Encode is not a function. All right. I'm not sure because it was perfectly okay before I changed from OpenAI to Gemini. It should not matter what LLM I am using. That should not be an issue. The issue should be something else. Model needs to be changed instead of V2 to V. Oh, which V2? This one. I had earlier used V2, so I'm not sure why that is throwing an issue. But anyways, let us see. Okay, so now this is the vector representation of my query. Then these are the top retrieved chunks. Then this should be the re-rank chunks. Then these are my concatenated chunks, top three. And now this is my question to the LLM. The 2024 to 2025 revenue increase is 36 billion. So really good. I hope this is correct from the document. One simple thing you can do to make this into a chat bot instead of like a one-time chat thing is you can just, I have just one block of code, which I don't want to write from scratch. It's not fun, but just have this. I'll ask Gemini to change the last block of code. Change the last block of code so that I can use Gemini model. So if any of you manage to get an output, please feel free to share your screenshot of some actual difficult question. Ask some numerical question which should not be easily available. Okay, so now here I can ask the question uh, percentage increase revenue or in profit or in share price. Let's see what comes. Unable to determine the intended type of dictionary. Oh, this is a different error. Oh, percentage sign is an issue. Is that an issue? Percent increase in share price. I would have guessed that is not an issue. Unable to determine intended type of dictionary. Let me just ask Gemini to have a look at this issue. So I had shared the link to the code once in the chat. So just copy the code if you want to. Try your own API key and just run it once. If you are getting the output, it'll be amazing. And try some other document where actual internet data is not available, because these models uh, already have a lot of real world info. Since txt document is working fine and able to retrieve correct values based on my query for, okay, so you used text loader, fine. Here in this, I can just type exit to just exit it. All right. But okay, for some reason, this conversation part is having an issue, but that is probably a temporary issue. Percentage increase in share price. Yeah, this issue is fixable. This we can fix later. But I think with this, we can move on to one last part. I have created an interactive exercise for you, but I don't want to go through the interactive exercise. That you can go through yourself. It's very simple. It's much simpler than the Google Colab code. But I want to walk us through some quiz. Okay, so just answer some of the questions in the chat. In the right, select compress isolate framework. Which operation does RAG primarily perform out of this ABCD? Fairly easy. This we have discussed in detail. It is basically selecting from the uh, memory, selecting from the storage or the database to be added into the context. What are the correct stages of RAG pipeline? ABCD. These are easy questions, okay? Just to make sure that everyone is on the same page. It's not to give you something amazing or anything. You first ingest, then chunk, embed, store, retrieve, generate. Fairly easy. You're building a RAG over Markdown technical documents. Which chunking strategy would you use? Would you use fixed, page level, sentence aware, recursive? So mostly in this case, you will use recursive, because in Markdown document by default, there is hierarchy. There are subheadings and headings, etc. So that structure you can follow if you use recursive. Fixed size chunking with chunk size 500 and overlap of 50 is processing a 1200 character document. What does it mean in terms of chunk size? How many chunks do you expect? Fairly easy question. So if the overlap was 0 and character size was, so first chunk will be 0 to 500, then it will be 450 to 950, then it will be 900 to 1400 up to 1400. But there should be 3 chunks. Then ChromaDB, this we have not discussed in detail, but basically you should know that ChromaDB also uses same built-in embedding model, which we just use, all mini LM L6v2, and it runs without API key. What's the trade-off compared to OpenAI's this model? If you use ChromaDB's this model versus OpenAI's large model. Only issue is if the chunks are very similar or the nuanced difference between the chunks are very difficult to capture, quality of the embeddings might not be very good, right? So obviously that's the trade-off. One of them will be faster, the other one will be more quality. Your RAG returns 3 chunks with distances between that and query. Basically, what is the refund policy? That's a query. These are the distances, which means what may be the case? So in general, it's hard to say without further context, right? Without more information, it's hard to say. But in general, if there is so much difference between first, second, and third, because 0.42 and 0.78 are different, I think mostly the first chunk is relevant. The other one, if you look at the percentage difference between these, there is all it's one is almost the double of other 0.42 and 0.78, and again 1.35. But yeah, it's very hard to interpret for sure. This BM 2.5 we haven't discussed in detail. BM 225 we haven't discussed in detail. Dense vector, yeah, this is an interesting question. We discussed about dense and sparse. So dense is the normal embedding with semantics. Sparse is the one which where words themselves are forming part of the each dimensions of the space. So if you are searching memory architectures and you find this chunk, how agents remember, why do you think in sparse keyword search this entirely is missed, whereas in dense it is not? In my opinion, B and D could be the answer. Like one is asking talking about sparse, the other one is talking about dense. So ideally, yeah, dense is using semantic similarity, and memory architecture and remembering, these two are semantically similar, right? So B, but D also technically you can say it's in this context it's a correct answer. How about this? If you are searching for ChromaDB vector database using both dense and sparse search, in which case do you think ChromaDB documentation will become the chunk number one? Think about the word ChromaDB. ChromaDB is a very rare word with very high, it will probably have a high IDF, inverse document frequency, because it's not a word that typically occurs very frequently. So it will help us easily identify the other chunk where that word ChromaDB is appearing. Similar to that quantum word, right? Okay, this we have not discussed reciprocal rank fusion because it's a little bit advanced, so that I will skip. Um, how about this? Your RAG system prompt says answer only using retrieved context. If the context doesn't cover the topic, say so. Why is this rule critical? We also did this when we wrote the code. Why is this needed? If we don't say this, what may happen? What may happen is LLM will try to give some answer, right? And that some answer will depend on its training. So we don't want that. We don't want LLM hallucinating and depending on its training data. We want it to depend on the RAG data. This also we can skip. Okay, how about this? A two-stage retrieval pipeline first retrieves 20 candidates with vector search, then re-ranks them with a cross encoder, just like we did, to select top 5. Why can't we use cross encoder directly on all chunks in the beginning itself? What's the issue with using cross encoder directly to get a so that re-ranking need not be done in a second step? Because think about it, if there are large number of documents, you have that many number of pairs to look at. A query and a chunk is a pair, and that pair has to be passed through cross encoder. Same thing has to be passed through the next for the next pair. So running it on all the 1,000 or 10,000 pairs is very expensive. Then okay, so how about this? Your RAG system's context precision. So the definition of context precision is, if let's say you wanted to, I have written it here. If you wanted to retrieve something, how much percentage of what you want to retrieve has been retrieved? So context precision is how much of the retrieved context is actually relevant. Recall is the percentage. Recall is how much of the relevant information was successfully retrieved. Okay. So just remember this. Precision is if you retrieved 100 items, how many of them are useful? Recall is if you intended to retrieve some certain 100 items, how many of those 100 have been retrieved? Okay. Now with that in mind, if let's say your context recall is 95% and context precision is 40%, what would that mean? Does it mean that you are retrieving uh, only a fraction of what you need? Or does it mean that you're retrieving most of what you need, but you are also retrieving a lot of useless things? So context recall means 95% of what you should have retrieved, you have already retrieved, but you are also 60% additional things you are retrieving which are useless, which means maybe your top K is like you have defined K to be 15. That 15 you can reduce to 5 or something like that, right? Just so that only relevant items are present. This is regarding the write part, which we discussed. An agent writes task.md file listing its progress, key decisions, and blockers during a multi-step refactoring. In WSCI framework, what type of write is this? Is this memory? Is this file artifact, which is like an output from the file, or is it scratchpad or select? The main question is, first of all, this is select is RAG, okay? So this is definitely not a select. This is a write operation. The only question is this something that is going into the permanent memory, or is this something that is temporary? This task.md, which lists the current progress or checklist or to-do list, are all for the current operation, which means it should be part of a scratchpad. It is not something which you will store for the upcoming task. It's for the current task. So it's a very ephemeral, short-lived memory short-lived write. In the recommended RAG token budget allocation, approximately what percentage of total budget should be allocated to retrieve context? This is something which we vaguely discussed, but roughly it is 60%. The retrieved part should be maximum, roughly 60%. Remaining 10% will be for generation, and remaining 20% will be for all the other memory, knowledge, etc. Okay, this is another good question. You index your documents with OpenAI's text embedding 3 small model. So this is the like the sentence transformer, and you embed your query using Voyage AI's Voyage 3. Both are high quality embeddings, but what may happen? Will it work, or will it work imperfectly, or will it not work at all? The problem is these are two different embedding models, which means the vectors are living in different spaces, right? So your similarity search will not work. You need vectors living in the same embedding space. Okay, this is something very interesting. Anthropic's just-in-time retrieval is basically a concept where you retrieve things only when you need. For example, in our email tool, we retrieve a similar email to the current email thread required only when we encounter an email thread that is referring to something which we had talked about earlier, maybe 6 months back. So just-in-time retrieval basically only loads metadata. Okay, this is not something which we have discussed. It loads only metadata, and from the metadata, as and when the context feels like something is required to be retrieved, you will retrieve. So here you will try to shrink it as small as possible. Okay, this is something which we did not discuss in detail. How about this? Multi-query retrieval generates 3 variations of the same query. What is context engineering? And retrieves chunks for each. Why does this outperform single query? So the question is, you want to get answer to some question, but the same question you ask in 3 different ways. Why is this helpful compared to just asking one question in one way? Because when you are asking it in different ways, it will help us find semantically better chunks each of the times, because the choice of words will be different, but semantically it will all mean the same thing, right? So it's not like more retrieved chunks are always helpful or anything, because more retrieved chunks may still have junk chunks. We just saw that earlier, like 40% was the precision, 95% was the recall. But the thing is, when you ask it in many different ways, your semantic similarity to the relevant chunks, there is a higher probability that you will find it. How about this? Gemini has a 2 million token context window. So why do you need RAG? Just copy paste all the documents. What's the reason why people should not do this? Even if LLMs are giving you bigger and bigger context windows, simply because your context will degrade in quality, it will rot. This is something we have discussed many times. This is a big takeaway from this whole discussion. What happens if you increase your chunk overlap from 50 to 200 tokens? So for our 500 token chunk size, our overlap was 100. Here it was 50, and you increase it to 200. What may happen? Will there be no effect? Will there be an effect on quality? What may happen? So in general, what happens is, if you have more overlap, the boundary between chunk A and chunk B is overlapping. And if in both of the chunks, if you have relevant information, it's not like chunk 2 will be discarded. Chunk 2 will also be part of your retrieved chunks. So that is a good thing. So in general, your retrieved chunks will be of higher quality because the boundary is now, the context is provided for both of the chunks due to the overlapping tokens. But the problem is number of chunks will be so high. So in your, instead of 583 vectors, you may need maybe 1,000 or 1,500 vectors. So you are searching in a bigger space, right? Um, if overlapping is not there, think about it. Let's say there are no common words between sentence 1 and sentence 2, but sentence 1 is actually the preceding sentence of sentence 2. And maybe even if the words of sentence 1 and sentence 2 are different, maybe they are still a continuum of the same idea that is being discussed in the paragraph. So if zero overlap is provided, the context from the previous sentence is not available to the second sentence because of the zero overlap. If too much overlap is provided, if there is 100% overlap, there will be infinite number of chunks. If there is 90% overlap, there will be large number of chunks. So it's a fine balance between how much overlap you produce and how many chunks can you manage. A system has 50 plus tool descriptions consuming 8,000 tokens in the prompt. LangChain data shows that applying RAG to tool selection improves accuracy by 3x. How does it work? So the question is, instead of having all the descriptions of the tools stored in one place, you apply RAG to find the appropriate tool description whenever needed. And this is much better. And why is that? Because tool descriptions you may embed in a vector database, and using a RAG at any given point, you pick the top 3 or 4 or 5 tools required for that moment. Just like how in our email system, how we fetch top relevant 5 or 6 or 7 emails to be referenced for the current conversation that is happening. So that is the reason why RAG in general will be very helpful here. Now, last question, 25th question is not relevant. So in a RAG pipeline, stages 1 to 4, ingest, chunk, embed, store, run offline. This happens one time, and this is happening during indexing. But the last 4 stages happens during the request, each API request. Why is this separation architecturally important? The main thing is, as you might have seen, after creating the chunks, creating the embedding was the most time consuming part, right? When we ran the code, everything else was fast. The most time consuming part was embedding creation. So that should not happen in each query, because then the user will never use the chatbot. User will always feel frustrated. Okay, one more thing, offline stages handle private data while online stages only access anonymized data. Oh, that I am not sure how much that is true in general, because see, in offline stage, you are anyway providing all the PDF documents, right? And those PDF documents are chunked, and chunks are stored in the vector. And when you are asking the relevant query, those chunks are only fetched. So I don't think B is necessarily true. There is nothing about privacy or anonymity. You can implement some sort of anonymity if you want to mask certain data from appearing in the user side in the first place, but then you will be masking it from the data itself initially before you do chunking. So here it's about expense. All right. So that will be the end of it. So I recommend you to do 2 things. One is try chunking with different, there are different parts of the pipeline which you can change. The 25th question is not relevant. It's different question. We have not discussed it. So one thing you can do is change the PDF ingestion pipeline. Use something different. Change the chunking type or chunking strategy. Change the vector database. Try maybe ChromaDB or something. Instead of Facebook AI search, try something else. And what more can you try? You can try some open source LLM. So there are different varieties you can try. And you know when this can be very helpful, when you implement the same pipeline to an industry where actually people are struggling to get relevant information, even in the presence of LLM, because all the information is present somewhere masked in documents or tutorials and stuff like that, just like OpenFOAM, because they have new releases, and it's often very difficult to find information with reference, because a RAG can provide references. It can say, hey, this is how it should be done, and here is the reference. And if they want to read the reference, they can go back to it, right? So just try a take-home exercise of implementing the same thing. One more additional thing which you could do is, right now we did this in Google Colab. Same thing you can do where you have it running on a website. So you have a backend pipeline, you have a nice front end where people can log in and use. So that also you try, but you can try it with Google Colab. You can try it with Cloud Code. So today we have run pretty much for 2.5 hours without stop, and I thank you so much for staying back till now. We will meet again tomorrow. We will wind up the lecture here. And for any other questions, just drop me an email, hello@vishwara.com. We will meet tomorrow, same time, 9:30 a.m. IST. And one more thing, tomorrow we'll be discussing MCP. Yesterday's lecture, there was an issue in compilation. That's the reason why on YouTube, when I uploaded, there was some issue with the quality of the video. So it created some issue. Then I deleted it. I re-uploaded it. It should be public today by 3 p.m. IST. So you can just check it. I have added it in the free course dashboard. So thank you so much, everyone. See you again tomorrow. Take care. Bye. So welcome back to the LLM Context Engineering Bootcamp. And today we are going to be discussing about Model Context Protocol, tools, function calling, and how LLM can do all these things with natural language instructions and what are its applications. So today's will be one of the most exciting lectures simply because you will get to see the power of Model Context Protocol and what it can accomplish. This was a term which was extremely popular around April, May of 2025 last year on X.com and LinkedIn. Everybody was talking about MCP. Whenever I opened LinkedIn, it was flooded with just posts about MCP. And now it has become more than just a fad. It's like, it's truly, truly useful to you for many different applications. So my plan is the following. We will first discuss a little bit about the aspects of handling different tools by LLM, because usually when you are building a agentic applications, there will be several functions or several tools that the LLM should get exposed to for performing certain operations. But you cannot pollute the context of the LLM by adding too many things into the context. So you have to be very frugal when it comes to how the descriptions of tools are being exposed to the LLM's context. So first we will discuss about that a little bit. And then my plan is, unlike last 3 lectures where we did the quiz part in the end, I might probably do a little bit of MCP related quiz in the early part of today's lecture, because I have noticed that many people, this is when I read different blogs and articles from Reddit and so on, there is a lot of confusion surrounding what is MCP client, what is MCP server, how do LLM interact with either of these, what is the role of each of these 3 parts, and what are some applications of this. So I hope that through the quiz, a lot of these things will get clarified for you. So first, let's just recap what we did yesterday. So yesterday we were discussing about RAG, and RAG is a select layer of the context engineering layers. Select meaning you are selecting what should be part of the LLM's context. In tools, it's more about LLM deciding, okay, what can I do next? I have so and so information, and now what could I do with all of this information, right? Just one update. Yesterday's recording will be uploaded in the free course dashboard by today around 2 p.m. or something like that. And today's will be available tomorrow. So just it's a minor update. All right. So today we'll discuss how do we define tool schemas when you have 10 tools or 20 tools or 50 tools that the LLM is getting exposure to. Then we will discuss about Model Context Protocol, how it blew up the internet a few months ago and why it has become such a standardized protocol where LLM and any tool can interact with each other, any LLM and any tool. And what exact problem does MCP server and MCP client solve? And can you do something without MCP? What's the problem of not using MCP in the first place? We'll discuss all of that. And we'll also see how the anatomy of an MCP server looks like. So I'm planning to show you 2 examples. One is a case where we will use an already existing tool with the help of MCP from Cloud Code that I will show you first. first or second that I'll decide on the go. Another thing which I'll show you is like the entire anatomy of a very simple MCP server, which has a very useful function. So I'll get to that in some time. So I have one question to ask. Let's say you have something like 7,321 multiplied by 8,761. You are multiplying two numbers. If you have this as part of your query, will you directly ask this to the LLM or should you directly ask this to the LLM? You can answer in the chat. What exactly should you do? If you directly ask the LLM, what's the problem? The problem is that, see, LLM is not a it's not a sophisticated math calculation engine or something like that, right? It is simply a next token prediction model. LLM is not really strong at doing mathematical calculations like multiplication, division. It can do that. It will most likely won't make any mistake, but sometimes it has the possibility of hallucination, and a simple deterministic calculation like this may also result in error if you are assigning this duty to the LLM. Instead, this duty should be assigned to whom? Who should take this duty of executing a mathematical operation like this? It should probably be done by a function in which addition, multiplication, bunch of those things are defined, or like a calculator tool, right? You could have API access to a calculator tool, right? So if you as a human, if you are building a website and in that website you want to execute a complex function and this function is hosted on a server side, what you typically do is like you design an API and then you make an API call request and you will get the response, right? So the execution is not done from whatever logic you have on your website. It is rather done by the function. Similarly, if within the context of an LLM, it just so happens that it needs to execute a mathematical operation. Okay, just a random example. It needs to execute a mathematical operation. Ideally, LLM should figure out that, hey, I probably have to call a tool, calculator tool for executing this without any mistake. So that is where the idea of tools are coming into picture. LLMs, let's say you want to access information, like there are tools will expose weather related data, right? So there are APIs using which you can get weather data. And if you want to display today's weather on your app, let's say you are running Blinkit or you are running any grocery delivery application, you will see that it also reflects the weather. If there is rain happening, it reflects that it's raining. How does it happen? That app has access to some API which exposes the current weather conditions, which are constantly updated in some sort of database. So they will most likely be using some proper weather app API. Or if you need to, let's say, on our website, for example, we have a function where somebody can switch the currency from INR to USD or vice versa. So how does the website know what is the current exchange rate between USD and INR? Again, it's an API call. It makes an API call to some financial tool which exposes the current exchange rate. So similarly, LLM has no access to live data. Live data exists on internet. It exists on different websites. And if those websites allow access to those data through APIs, LLM should be able to somehow access it. So these are actually tools. Second is LLM cannot do actual computation. LLM is only good at next token prediction, but all other capabilities that LLM has, like LLM can write code, LLM can actually do math. I mean, in theory, it can make mistakes, but in practice, it can do math, right? LLM will make mistake only once in a while. In 2022, if you have noticed towards the end, if you ask ChatGPT basic math questions, it was making a lot of mistakes. But these days, the mistakes have reduced tremendously. So, of course, the emergent properties resulting from next token prediction when you are scaling up the large language model, of course, it is increasing. But yet, you would mostly, if you want high reliability, you will rely on computation tools. Then the third thing is LLM cannot make any changes or any effects in the real world. For example, LLM by default cannot place an order on Amazon. LLM by default cannot send an email. For sending an email, you use any email sending tool. You use Gmail API or some setup like that. LLM cannot directly send a message in Slack or in Discord. For that, you may use MCP for Slack, or you will use a API service, right? So LLM do not have access to live data. It has no access to computational tools, or it cannot make any change in real world by directly by itself. But rather, if it has exposure to tools, it can do all these things. And one thing you should notice is whenever LLM makes a tool call, if LLM makes a call to a um, weather condition retrieval tool, the result of the tool will be stored in the context only, because the tool will send the result back, and then that result is compiled in a certain way before feeding into the LLM, so that LLM can give you natural language response saying, hey, the weather today is likely not very favorable for you. You should probably not go out. And that will be stored in the context as well. So of course, you have to have some window available for storing the tool results also. Okay, this is just an example. Yesterday, we had discussed that RAG results will probably take up to 60%. In this example, it's only showing 30%. But don't get hung up on the percentages. It's anyway a thumb rule. But here is the issue. If you have a tool that is that has so many different capabilities, for example, let's say you are making an LLM talk with Slack. Slack has so many different functionalities. You can create channels, you can assign admins, add members, delete members, you can post, there are many, many things you can do in Slack. So now think about this. Let's say as a result of your LLM interacting with Slack, if the response is something like a 5,000 token JSON, it's very big. 5,000 token roughly equates to 5,000 words, not exactly. I'm just saying order of magnitude wise. And this is too big for a context window of the LLM. You might not need these many tokens to be fed into the LLM for you to get the response that you need. Let's say the question that you are asking is, in the general channel, what was being discussed yesterday? Can you give me a 3-sentence summary? If this is what is being discussed, the JSON need not contain information about how to create channels, or it need not contain information about all the other channels. So the token consumption by LLM should be ideally minimized, which means whatever a tool is returning, or whatever the description of a tool is, or whatever information is there associated with the tool is, it should be stored in a concise format so that LLM's context is preserved. There is a question by Abhi. How is a RAG result different from tool result in this example? Both have knowledge based on live weather, right? Okay, very good question. Think about this. In RAG, what we are doing is we have documents that are not necessarily live. These documents are converted into some sort of vector embedding, right? So the vector database itself is not getting updated very frequently. And then from that database, you might want to fetch information once in a while, and you want to analyze that information using RAG. So yesterday, what did we do? Yesterday, we took the PDF file from the Microsoft shareholder report. That shareholder report is not going to change anymore, because it's a already done 2025 shareholder report. So now from that document, you might want to fetch and analyze information. For that, you use RAG. But let's say now there is another tool which is also having real-time updates of the Microsoft stock price. And if you want to fetch that, that is when you truly have something like an MCP. You can think of having an MCP server. We'll discuss the definitions and details in a little bit. But RAG and MCP are fundamentally different in that way. MCP can have access to real-time data, and it will be agnostic to what LLM you are using to connect to an MCP server. We'll come to that in a moment. So when it comes to LLMs interacting with tools, you need a tool description. LLM should be able to decide what tools among all the tool descriptions should I use. And then LLM should figure out how to make a call to the tool. When the tool returns some response, that will be taken into account. And then final response in natural language, so that the user who asked a question, let's say you are asking a question about a mathematical operation, or you're asking a question about financial data, you finally want a response from the LLM just like it is a human. So this response will be crafted. Now there is a fundamental question. Who runs the tool? Is it LLM? Who is actually running the tool? So think about it. When we say LLM having access to tool, what exactly is LLM producing as the output just before the tool is being executed? I'll repeat the question. a tool, you can imagine a tool to be a function, right? That function, you will require arguments to be passed into the function. When we say out of 10 functions, LLM decided to call function number 3, LLM is not executing the tool. LLM is deciding, the LLM's output decide the structure of how the tool call should look like, along with the arguments that we pass into it, right? The actual execution is done by the logic of the logic written inside that function itself, right? So please understand that LLM is not running that. LLM is deciding what tools to call and what tool to execute, and it produces a structured response as a result of this decision. Okay, that structured response will be used to call the tool. So this is one place where LLM will produce a response which as a user you will not have to see, but LLM will produce a structured response, and that structured response will decide what tool to call and what argument to pass. And then the tool will return its response, and the final sort of structured or unstructured response which is exposed to the user is coming at the very end. Okay, so this is the LLM's decision producing a structured response for tool call. This is also LLM's decision to kind of display the final outcome in whatever format is required to the end user. Okay, so just understand this. Now, a tool schema which describes how a tool looks like, or what a tool should do, or what variables to pass, or what this tool is even capable of doing, whether it is searching of weather data, or whether it is searching of US dollar to INR exchange rate, whatever it is, the schema can roughly look like this. There will be a name, and the convention is that if a name is there, it should ideally mention the functionality. The functionality is searching. So functionality and some sort of description about where this functionality is applied to in this format. So this is called as snake case. Whereas if it is something like search products with capital P, what is this called? It's called camel case, right? If I'm not wrong. So the name of the tool will be in this kind of a snake case. Search is the action that it is doing. Products is what it is searching. Then the description will be in natural language. It will describe what this tool is capable of doing, which is already available some sort of to some extent in the name, but description expands it. Then it will also describe the different properties. It will, if it is a function, it will describe what arguments are being passed. If there is a category selection, it will enumerate the category so that LLM will not hallucinate something outside of this category, most likely. LLM can still hallucinate anytime, but this will tremendously reduce LLM's hallucination if these are the only categories that LLM should consider. And many other details, right? So this is a rough example of how the schema in sort of JSON format, how it can look like. Now, the schema design principles, as we discussed, just look at this. The description, which tells what the tool is supposed to do, should be clearly saying, this tool is supposed to search the product catalog from this website database, and it is ideally returning the maybe top 50 items from the database. There is one question: is tool and MCP, are they the same? Are they different? They are different. Tool you can imagine as just a function. So we are yet to reach to the MCP. Okay, I have not defined what is MCP yet, so just don't get confused. Here, if I talk about tool, just imagine that within your, let's say, if you are writing in Cloud Code, within there you have written, let's say, 50 functions for different activities. Now your LLM has to decide for your execution which among those functions it has to execute, which among those functions it has to call. For that, you need to have some sort of description of the function itself, rather than apart from the actual function. Actual function will be written, let's say, in Python format or JavaScript format, but you need to have some sort of description so that LLM can decide which one to call based on a short description. So here we are talking about that selection of functions to execute, okay, in simple words. Then one more thing is, make sure that your name of the tool or name of the function is unambiguous. This is a better convention. This is better convention. This is better convention. But if you write it something like search products or something like this, it's not considered to be a good convention. And this enumeration, if it is a categorical variable that this function is supposed to be handling, explicitly enumerate those categories into the tool description. That will help a lot. We'll see how these descriptions can look like. This we have already discussed. The tool description will help the LLM decide what tool to call, and then it will produce a structured response, which will also include the arguments to be passed, and then tool will be called or tool will be executed, and it will, at the end of it, if it's a function, it will return a certain value. And once this returned value is available for LLM will reason based on that returned value, and then LLM can give you a response which you can utilize, right? So this is the 5 steps involved in it. We'll see this in detail when we are going through a interactive website, just like how we were doing in the last couple of lectures. One more thing I want to discuss before we move into the MCP is what if you have 100 tools or 1,000 tools? Each tool description may be around 100 to 200 tokens, or maybe 100 to 150 words or something like that. So if you have 100 tools and each tool description is 100 to 200 tokens, you may end up consuming 2,000 tokens or 5,000 tokens or 10,000 tokens, depending on the tool. Now imagine you are building a complex software. Your complex software will have so many different functionalities that if you are now handling all those tool descriptions within the context at once, your context will definitely become bloated. So a good practice is, on the lower extreme, if your number of tools are very low, okay, then you can include all the tool definitions inside your system prompt. It is not a problem. However, if your tool descriptions are so big just because of the sheer number of tools, you have to do some kind of RAG where you will have minimum description available. From that minimum description or minimum available metadata, your RAG can decide which 5 tools or which 10 tools you require during the execution of the current task. So in that case, you have to utilize RAG. The RAG can be using vector database or it can be using keyword matching. It does not matter. But at the end of the day, the descriptions that are loaded into the context window will be only a subset of all the tool descriptions available. This is the other extreme. Regarding just-in-time instructions, JIT, we will discuss towards the end of this the set of slides. This we'll come back to in a little bit. So now we can get into model context protocol, where anyway, by default, discussions about tool will come. First of all, let me ask you, how many of you have heard about model context protocol before? Or how many of you know about what it is? Or what, I can ask you one more follow-up question. Seems like some people have heard about it. Okay, awesome. Now, please tell me, in 2 sentences, what is the fundamental difference between model context protocol versus, let's say, making API calls? Let's say you have an MCP server in one case. In another case, you have a server which has several APIs. What's the difference between having an API call executed versus making a handshake with a MCP server to get data or get whatever you need from the tool? The fundamental difference is that different LLMs handle API calls and responses from it in a different way, right? And the LLM, if you want to really switch between Gemini or OpenAI or LLMs provided by any other companies, you need some sort of standardization. So I'll come to this definition, but before that, let me show you. So what happens in the absence of MCP is that this N by M problem. If you have N LLMs and M tools, by M tools, you imagine softwares, GitHub, Slack, your company is using this, and maybe Docker, maybe you also have Firestore database. You have a bunch of tools. And let's say your company uses 3 LLMs. Then what will happen is, in the absence of MCP, if you want to define interactions between your LLM and tools, you may use API calls for sure, but then you will have to write the structure for these interactions N by M times. For interaction between Cloud and GitHub, you will have to define. Between Cloud and Slack, you will have to define. Between Cloud and database, you will have to define. But when you utilize MCP, model context protocol, what it does is it standardizes the way in which instructions are sent into this MCP server. It standardizes the way in which instructions are sent back from the MCP server, this protocol, which means it doesn't matter which large language model you use. There is a common way of communicating with the MCP server, to provide information to the MCP server and to get a response from it. And this makes the life very easy for developers, because that way developer need not think about a developer who's let's say building an MCP server need not think about which model, which large language model the user is going to use. It makes it very easy. So that then the problem becomes sort of like n plus m. You have to set up 3 MCP servers, and you have to set up the connection to the MCP server for each of these 3 LLMs, right? Now, there are two things here. One is MCP client, and there is MCP server. The best way to understand the difference between these two, I will ask you a bunch of questions, and at the end of those questions, you will have a very clear idea in your mind what is the role of MCP client and what is the role of MCP server. Okay, I'll come to that in a moment. But there is a beautiful analogy that you may have seen in the internet about MCP server, which is that of a USB-C port. So before USB-C, you had many different ways in which your devices can be connected to whatever charging point or to a laptop. You remember like maybe 10 years back, Windows laptops, they have many different ports for connections for HDMI, VGA, or then there is USB. Before USB-C, there are other variants of USB connections, micro USB. It's like a pain, but USB kind of standardized this so that in my MacBook, in the same port, I could connect mouse, I could connect, like a converter for USB-C to HDMI. Oh yes, I will check the waiting room. Thanks for the reminder. Yeah, I have just admitted. Thank you. Or I can convert my USB-C connection into anything else which connects to that separate tool. So now my USB-C port will act as a connector between my laptop and projector, my laptop and mouse, my laptop and let's say this Wacom tablet, or my laptop and mic, anything, right? So it standardizes this connection problem between two different hardwares. Just like that, MCP server standardizes the connection between different tools or different software with your large language models. Now, what we can do is, before we go into this further, I will first show you one simple MCP tool which I had defined recently. Okay. Can you see my screen right now, which says a YouTube MCP? Okay. So what this does is the following. So here I have defined two things. One is an MCP client, which is a website with some URL. So let's say this is YouTube mcp.com. So this MCP client is basically the web app. And this client runs on Vercel. Okay. Now, what this does is, I will just show you the front end of this application so that you have a better idea. What this does is, this is a simple application which looks like this, where if I provide the OpenAI API key, and if I provide the YouTube URL of any video, so here I have taken the link to the second lecture video itself. And if I provide the video link here, then I should be able to fetch the transcript, or based on the transcript, I should be able to generate lecture notes, or I should be able to generate key points, or summarize what happened in the lecture in one paragraph. All right. So here what is happening is, the OpenAI API key provides access to GPT-4o mini or one of the LLMs. Then what is the tool that is being used here? If any of you can tell me, what is the tool that LLM is accessing to from the MCP server? The tool is basically a tool which YouTube library provides for fetching the not summary, transcript. That is the key distinction. Just let me go back. The only tool used here is for fetching the transcript. Is the tool creating the lecture note, or is the tool creating the key point, or is the tool creating summarize? None of that is done by the tool. The only role of the tool is when my client meaning when this website asks to fetch the transcript, okay, or when it asks to fetch the lecture notes, what it does is, this client makes a call to a server in which a server.py file is running. I'll show you the file. Where is the server hosted? For the time being, I have hosted it on railway.com. Now, this server, so this is the MCP client, and LLM is or GPT-4o mini. And this is the MCP server. And the tool is, let's call it as get transcript. Okay. Now, what we want ideally is manually, how will we do this? Manually, if we were using ChatGPT, what will we do? We will somehow run this somewhere, this get transcript function, if it is available on our VS Code in a Python file, we'll just run it. We will provide the YouTube video URL, and we'll get the transcript. And then we will copy paste the transcript to ChatGPT, and then we'll ask, hey, based on this transcript, create a lecture video description or lecture notes or lecture summary, right? Here, on the other hand, this is the client itself. What you see right now is the MCP client, in which, let's say you click this lecture notes button. What happens is there is this YouTube URL which is provided to the client. This URL is communicated to get transcript. And there is one more step that happens before this, which is called the client server handshake. I should also mention that probably first. Let me just draw this a bit far away. So the very step that happens in the communication between server and the client and server is the server client handshake. In this handshake, the only information that will be passed from MCP server to client will be that, hey, here are the list and descriptions of the tools that I can provide you. And based on that, the client can decide what tools. Client can help LLM decide what tools to call, right? So this first step is called the client server handshake. After this only, the actual tool calling will happen. So the handshake will happen automatically. It's part of the protocol. And there are two ways in which communication can happen. I will show you two examples, one example of both. In some cases, your client and your server might be on the same device. Can you give me an example of this case? Can you give me an example of a case where your client and server may be on the same device, like on my computer? Any example where this might be the case? Local LLM, access file system, database, MCP, file server. So one good example you can think of is, let's say you have a software that is installed on your device. To make it very simple, I'll show you an example. Okay, let's say the software is Blender. Have you heard of the software Blender? It's a 3D modeling software, very good software, right? Let's say this is installed on your computer and you are using Cloud Code on your computer so that Cloud Code can communicate with Blender to create 3D models or to create scenes, okay? Normally, for a human to create scenes in Blender, even for experts, it will take a lot of time. I'll show you a very good example here. Now, but the thing here is, here Cloud Code is running on your computer. Blender is also on your computer. So the MCP server as well as MCP client. So this is the client and this is the server. Not Blender is not the server, but MCP server, which will connect to different functions available in Blender. Both are running on your device. In that case, the communication protocol between them is called STDIO communication protocol. But if this is happening through the internet, like this example where client is one website, which is hosted on Vercel, the server is MCP server is basically a function that is running on Railway in the backend. Here, the communication protocol can be HTTPS, just like how it usually happens on internet, or SSE, or sometimes it can be socket, WebSocket. HTTPS is the most common one. We don't have to go into the details of this because it's not what is relevant, but what is relevant is to just understand that the way in which the client and server will communicate will slightly differ based on whether the places where client and server are hosted is the same device or different devices across the internet. Now tell me what will happen when I ask my client, who is the website where I pass the OpenAI API key and I pass a YouTube URL, what happens is first the client will pass the YouTube URL such that this to the LLM, such that the LLM will decide a definition of a tool call, in the sense that there will be a structured output coming out of this, where it may say the tool that I have to call is get transcript, and the argument that I have to pass is this YouTube video URL. And then this will be passed using HTTPS request, used in the form of HTTPS protocol into the MCP server. And what does the MCP server do? MCP server will access this get transcript function into which the YouTube URL is passed. This get transcript function, in our case, if I go back, there is one more function that the get transcript function is calling. I will show you the structure in a moment. I don't want to go into the detail right away, but it calls a function called extract video ID. Basically, given a YouTube URL, this function can extract the ID of the URL, and that ID is needed to finally fetch the transcript. So then this function will fetch the transcript, okay? And that fetch transcript is now the data that is being passed from the server back into the client. So now, usually what is the format in which the data or the communication happens when you do an API call? What format document is usually passed in an API call? It's usually JSON. But here is my question. What if as part of the API call, you are also getting a video file or image? Is that passed through the JSON, or is it just referenced in the JSON? It is referenced in the JSON. It will be just streamed as data, right? Similarly, here the JSON or the format of the response will talk about the metadata of what the data is being passed, but the actual data that is being passed from the MCP server to the client will be what? Will be the transcript. Now, if from our tool, if we were asking to summarize, now one more question. Where is this transcript passing? Is that going into MCP client, which is Cloud Code, or is it going directly into the large language model? This transcript that we get from the server. Does it go to the LLM or does it go to the MCP client? It goes to the MCP client always. Why is that? Why should it go to MCP client and why not to the LLM? Because LLM only wrote the structure for calling the function. So why not put the response to the LLM? The problem is, let's say your MCP server ended up giving you a huge output. This server is not the guy who is maintaining your context window of the LLM. Server does not care about the LLM's context window. Server only cares about returning what is asked. The guy who is caring about your context window is whom? Who cares about the context window of the LLM? MCP client cares about the context window of the LLM. In this particular case, the client is the Cloud Code itself. I mean, not in this case, in the case when I am using my local device. But in this case, the MCP client is my the logic of my website. Okay. And then this guy will decide what to ask my LLM to do next, provided this output which it received from the server. So server will communicate to the client. Client will decide, with this available data, what all things should I pass to my LLM? Then if we had clicked this button for called summarize, it will pass two things. It will ask in the prompt, it will pass the transcript, as well as it will pass the command that you have to summarize this transcript into a one paragraph. If we had clicked this key points button, it will say, make a bullet pointed list of items which were discussed in the lecture based on the transcript, and then it will also pass the transcript. Yeah, there is a question. Can you please explain the difference between MCP host and MCP client? Yes. It's an ongoing discussion. So I will ask you many more questions to make it clear. One more thing is, let's actually, before we go ahead, let me ask you a few questions. I think this will clear a lot of confusions about what is a server, what is a client, and so on. So let's get into a series of questions. In the model context protocol architecture, what is the primary role of MCP server? So in MCP architecture, there is server and client, store the conversation history, replace the LLM when tools are needed. What's the role of MCP server? Clearly, it is D. MCP server provides the tools as well as any other resources which the client can access. Next one. Where does tool selection actually happen in MCP workflow? Who, uh, who decides what tools to select? Is it the server or is it the client? One more. Is it the client or ultimately it is the LLM? Ultimately, it's the LLM, but it will happen inside the client because client is having direct access to LLM, right? Then what is the main purpose of the tool schema that the server sends to the client? This is in the initial handshake. The schema of the entire tools that are available will be sent, or even with an individual tool call, a schema is sent from server to the client. Why do you need this schema? Without the schema, how does the LLM know what kind of format response to produce to make a tool call? LLM does not know, right? You have to explicitly teach the LLM otherwise. But if the schema is exposed saying, hey, here is how the function call should look like, here are the arguments that you should pass to this function, and these are the purposes of this function. If you tell this to the LLM, then LLM can produce a structured response call, which will invoke the function call from the MCP server. So it tells the LLM how to call the tool. Next, if LLM decides to use a tool, what does it actually produce? Does it produce a Python function, which is the tool itself? Does it produce an answer to the user immediately, which is exposed to the user, or does it provide a response in natural language, which serves as a request to the server? None of that. It produces a structured tool call. And where does this structured tool call go? Where is it going to? It's not going to the client. We have already passed the client stage because client will give enough information to the LLM to give the yes. In the beginning, client has to communicate with servers for sure. Ultimately, it's going to the server for sure. So this is a structured tool call which the LLM produces. Next is what condition must be true for a tool to be usable by an LLM by an MCP client. The tool must expose a schema describing inputs and outputs. Tool must be written in Python. Tool must run inside the LLM process. Tool must return JSON embeddings. There is no restriction that it should only give as a response JSON embedding. So tool must expose a schema. It should describe what the inputs are, what the outputs are. In the inputs, also the arguments will be explained. What is the main role of the transport layer, such as STDIO or SSE or HTTPS in the MCP? So this transport layer establishes a protocol for communication between the client and server. When is STDIO used? When both the client and server are locally, it's within the same device. Otherwise, you could use SSE, HTTPS, or WebSocket. So this is a protocol for transferring messages between the client and the server. If an MCP server exposes 10 tools, but the client sends only sends the LLM only 3 tool schemas, what will happen? So server communicated to the client that there are 10 tools available, but client decided to send only 3 tool schemas to the LLM, which means the model will only be able to access those 3 tools. So think about this. Model LLM is only communicating with client. LLM is not directly communicating with the MCP server. All the communication between server is with the client. And then all the communication of the LLM is with the client. Then after a tool runs on MCP server, where does the tool result go first? Is it into the LLM itself, or is it to the user, or is it to back to the, it's back to the MCP client, because this is why we have established a communication protocol between the client and MCP. Why does MCP separate the client and the server instead of having, just the LLM call these functions directly, or maybe API call? Why can't the LLM directly make API call or something like that? The basic idea is that this will allow any LLM connect with any tool with a common using a common protocol. So it makes the life of the developers so much more easier, right? So it allows external systems and tools to be accessed safely and modularly. If an MCP server exposes a tool, but the LLM never sees the tool schema, what will happen? So who decides whether LLM should see the tool schema or not? MCP client decides. So MCP server exposed a tool, but LLM never got to see the tool schema. Then basically LLM won't be able to access the tool, right? Because the tool schema is never visible to the LLM. So LLM has no idea about the existence of the tool in the MCP server unless the communication happened from server to client is also communicated to the LLM. Which component in an MCP system actually executes the tool code? This is a very interesting question. You have a code for executing there is a function or the tool. Who is doing this? Because the tool, who has direct access to the tool? Client does not have direct access to the tool. LLM does not have direct access to the tool. Direct access to the tool is only for the server. So server executes the tool, and whatever results are there, it will pass on to the client, right? If a retrieval tool returns multiple documents, who decides what portion of these documents go back into the prompt for the LLM? This is easy because everything, what should go into the context of the LLM is decided by MCP client. So if we have Cloud Code as the MCP client, and if we are using Opus 4.6, what goes into the Opus 4.6 model is decided by the MCP client. Now, which component maintains the conversation loop with the LLM during tool usage? So I can see A and B. So conversations with the LLM is always done directly by the client, right? Tool directly does not communicate to the LLM. Server does not directly communicate to the LLM. Only client can directly communicate to the LLM. In our example, Cloud Code or our website, which is hosted, it can communicate directly to the LLM. The website is hosted on Vercel. Then, besides tools, what else can MCP server expose? This is something which I haven't discussed yet. I will come to that in a little bit. I'm jumping the gun here. But MCP server can actually expose three things. It's called three primitives: tools, resources, and prompts. So I will just go back to my Miro board once, just to show you that there are three primitives which are part of a model context protocol. So this is the way in which the server will expose tool at server. Let me just change the color. At server.tool followed by whatever function. This exposes tools. At server.resource, this exposes the resources, which are documents. And then at server.prompt, this will expose predefined prompts. I will show you one example where this is kind of done in our YouTube MCP. So here, let me show you the folder structure. So here you see a bunch of folders. What I have done here is both the client and the server, I have written the code here and I push the code to GitHub. But whatever code is available in this web folder, this is the website that I have hosted on Vercel, which acts as the front end. So this website, YouTube MCP Git main, this website, okay, this button definition, this style definition, and the way this OpenAI API is stored in the local storage, all of these things, are defined in this inside this web folder. So this web folder has nothing to do with server, but it has got everything to do with what? This folder has nothing to do with server, but it has everything to do with the MCP client. Here, the MCP client is this web app itself. So this web app acts as the client, and this folder defines the client, which means when I am deploying on Vercel, only the contents of this folder is deployed from GitHub. So I will change my root folder as the web folder in Vercel, and then Vercel can automatically fetch whenever changes are made to this folder. And when I push it to deploy it on GitHub, Vercel will refer to this folder on GitHub and it will redeploy. Now, the files that are primarily used in the MCP server, which runs on Railway. So I'll just show you on Vercel. This is how the deployment looks like for my front end. And on Railway, where is Railway? On Railway, I have deployed the backend. The server, which is active like this. This is referring to primarily these two Python files, primarily this server.py file. So let me just show you server.py and its structure. So first, it is importing a function called fastMCP. This is inherently for implementing things related to the MCP, the communication protocol, etc. So this is by default. But another thing this server.py is calling is one is LLM utilities, LLM utils, which we have defined manually here. And this will help us switch between OpenAI or Gemini models. So here I have given two options. So in the front end, I had given two options, OpenAI or Gemini. And when that switch is made, that change should also reflect in the way server sees the model, right? Or server knows how to communicate with the client. So to the provider, which is to the client, I have to say what LLM is being currently used. The LLM that is being currently used is either OpenAI or Gemini. And then in the server.py, I have three things written here, which are several of them are redundant actually, So the redundant things are, I'll tell you what are redundant, and maybe you can tell me yourself. Oh, okay. There is a question. Why should the server know about the LLM? So basically here I am passing the API key in the server function. In the MCP tool function here, I am passing this. And this is being passed into this ask LLM function. Ask LLM is over LLM utils. So basically, whatever function this LLM utils is exposing, and that function has details about what model is being used. And it's not that, okay, I think earlier I said the server is directly getting access to the LLM. Yeah, I'll come to the redundancy part, but basically just to explain this, the server is getting access to a function which says these are the models and these are the parameters. Ideally, these things could be defined, I think, in the front end also. I could simply say the definition of the LLM and the definition of the model can be done in the front end, and server gets exposure only to the client. But the way here it is written is in such a way that this function is being exposed to the server.py. That's the only reason why I have to write in the LLM utils the providers which LLM is being used at the moment. In the server, can I show you in a zoomed out way? I don't know if you can see this fully. Can you just tell me which tool might be redundant here? So the reason why I have written this is to show you the three primitives, the tools, the prompts, and the resources. But so, and then just see this. The only function that this tool or the prompt or the resource is calling is get transcript function. Get transcript function is being imported from the other Python file, which is YouTube tools.py. In the YouTube tools.py, this get transcript function gets the video URL. Video URL is passed into this function called extract video ID. Extract video ID based on the URL, it will check if the URL consists of certain pattern. And if the pattern is matching, it's a valid URL. And then it will fetch the ID of the particular video. And the ID of the video is stored in video ID, which is passed into this YouTube transcript API function. That API is imported directly from this library, YouTube transcript, YouTube underscore transcript underscore API. This is provided by YouTube directly. And one thing here, which was interesting for me, is there is no need of any YouTube API key or something. This function directly allows anyone, even without YouTube API, to directly get the transcript of a YouTube video. So here, ideally, I don't need any of these functions. Like I don't need these resources. I could simply comment, I don't need the prompt. The only reason why I have written it is to show you that if we were having prompts and if we were having resources as the primitives, how the function will look like. Let me just comment this. The only thing that we need here is look at the client. What all tasks are client asking the server to do ultimately, or what all things are client asking the LLM to do. Client is asking for creating lecture notes. Client is asking for key points. Client is asking to summarize, and client is asking to get the transcript. In ideal case, in a different way, if we implement this MCP client and MCP server, a different way of implementation would be for fetching the transcript alone. One communication happens between the tool and the server. Sorry, a tool and the client, and then everything else, summarization, key points, lecture notes, everything happens on the client side. Here, one thing you notice is like the way this is defined, which is not ideal, is that there is one tool, mcp.tool, for getting video transcript. There is another tool for summarizing the video. There is another tool for defining extracting the key points. There is another tool for generating notes. Now tell me, was it necessary that I define these three tools on the server side? These three tools, should it necessarily be on the server side? It should ideally be on the client side, right? There is no need for me to do these actions on the server side. And this is the reason why, if we come back to the earlier point, because these functions are executed on the server side itself, the LLM access is provided to the MCP server in this case. But this is not an ideal practice at all, right? Yes, in this case, we will need, if these tools are defined on the server side, and if the definition of this tool is to call an LLM and do a certain function, of course, the server should require access to LLM. Yeah, so just to clarify, let me just draw this. So MCP server is there. MCP client is there. This is the Vercel website. And this is the railway deployment. In this particular case, one thing that will confuse you is the server is finally returning the final output. It returns one of the four things. It returns transcript, or it returns summary, or it returns, let's say, lecture notes, or it returns, I think, bullet pointed outline or something like that. And there could be one LLM over here which can decide what to do with this. MCP client can ask the LLM, hey, here are the lecture notes. Do this with the lecture note. Hey, here is the summary. Do this with the summary. Hey, here are the bullet points. Beautify the bullet points. But this part we are not doing yet. What is being done is MCP client is interacting with the MCP server. This server, as part of its tools, it has four tools. Get transcript. Yes, all results can be derived from the transcript. So there is no need for having these three tools in the server side. But right now, the way it is defined is there are four tools: get transcript, get summary, then get bullet points. Forgot the name of this, but something like that. Then get the lecture notes. Okay. And all these tools, out of the 4 tools, this, and this require an LLM access. This does not require an LLM access. This is directly getting it from YouTube. Now, if you were to design this in a different way, what you should do is remove all of these tools or all of these functions from MCP server, because this is unnecessarily requiring a communication with LLM, and move this here. And when the communication happens between server and client, remove all of this and just ask the server to do one function. The only one function the server would do is get transcript, which does not need any LLM access. This is purely a YouTube function, YouTube call, API call. And then pass the transcript to the client, and then ask the LLM here on the client side whether I should summarize it or whether I should convert it into bullet points or lecture notes. Okay. But here in this example, get transcript is the only tool which I can show you. So I thought we could display more tools if I also add some additional tools here. Okay. So the confusion that was created earlier was, initially I said, why do we, LLM will never communicate with the server. That is still true. LLM will never communicate with the server. The LLM associated with the client will only communicate with the client. But if the server tools have access to its own LLM, that communication can happen, and client does not have anything to do with that communication. If MCP server functions also got its own API call to make to a different LLM, it can do that, right? So in this current case, the reason why these in LLM utils, this provider is written, the OpenAI and Gemini is written, is because these functions for extracting, summarizing video, extracting transcript. So here you see in this extract transcript, there is no LLM call coming. But here in summarize tool, there is this ask LLM call coming. In extract key points, it is coming. In generate notes, it's coming. So what does this mean? It simply means the following. This tool has access to an API call to YouTube, whereas this tool has access to API call to where? LLM. This tool has access to API call to LLM. So does this tool. That's the only difference here. But then on the client side, you will mostly in most cases will have its own LLM, which will decide or which will be asked to do whatever you are supposed to do with the output you get from the server. So if you were to redesign this particular tool or this particular application, what you should do is you should delete these 3 things. Simply delete these 3 things. Just keep only one tool. Keep only the get video transcript tool. Then the only communication that should happen between client and LLM should be pass the transcript. And then eliminate this LLM utils, because this is also not needed, because the server need not know about LLM. Server has nothing to do this with LLM. Why? Because server is not even calling any LLM. So just comment this line. No need of LLM utils. You can delete this file altogether. This LLM utils completely delete. On the server.m, only thing that is running is this MCP tool. And then this will communicate the transcript to the front end. And then from the front end only, the LLM API call is made for executing, whether you need to summarize or whether you need key points or whether you need lecture notes, or whether you need to just purely display the transcript which you directly get from the server. If you purely want to display the transcript which you get from the server, you don't even need the LLM. All right, you can just directly display. Only server is needed. Does this client-server architecture restrict client to only read from the server and not able to write to the server? That is a good question. Right now, to the server, what is happening is not writing. To the server, what is being passed is the function call with the arguments. So Amit, when you say writing, you mean to say, can something change in the database of the server as a result of the communication that is happening between client to server, right? That is a good question. I think writing can happen, right? That is what is happening in, but at the end of the day, writing is done by the tool. It is not done by the client. So client can, to give an example, let's say you build a chatbot. So yesterday I was building a chatbot for Discord. Now this chatbot will act as a bot and it will post comments or reply. It can do whatever on Discord or Slack or whatever. So there, the tool is in essence, the tool is making changes to the database on the server side, right? But it is not directly done by the client. Client is simply communicating that to the server. Server is making the appropriate tool call. The appropriate tool call may make changes in the database, or it may read the data from the database. It's up to what we have designed the tool for. Okay. Now I want to show you one more thing, which I don't know how many of you are aware of, which is the power of MCP. So I'll show you one YouTube channel. So we actually have a YouTube channel called Visual Learning. Okay, this is anyway our side business, in the sense like this has got nothing to do with AI or anything, but it's a good channel. So our team basically makes these amazing 3D visualizations explaining science concepts and those kinds of things. And most of these are made using Blender, and some things are additionally added using Unity. Now, the good thing is the quality is very high, but see, a human's effort is needed to make stuff like this on Blender. It's very, very time consuming, but it has a huge impact on, small kids who finds it difficult to visualize these concepts otherwise. So now I'll show you. This is the Blender software. I don't know how many of you have seen this Blender software. Can you see Blender software, by the way, right now? Are you seeing Blender, or are you seeing something else? Okay. Now, I don't know if I have to zoom in a little bit. Let me try to zoom in. Yeah. Do you see something called Blender MCP here? So this is one of the latest versions of Blender 4.4.3. There is something called Blender MCP. What you can do is you can start an MCP server. Right now, I have started it. It says the server is running on port 9876. So now the way this structure is in the following way. We have, let's say, Cloud Code. And say my requirement is this. I want to make such beautiful visualizations and animations without touching the Blender, just using natural language. Okay. So I have Cloud Code, which is the MCP client. Then I have LLM, which is Opus 4.6. Then I have MCP Blender MCP server, which is the MCP server. And then I have Blender itself, Blender and different functions or tools within the Blender. I can maybe write like create 3D model or whatever the tool name is. There will be like hundreds or thousands of functions in Blender. So this is the tool. Now what I need to do is this. I will talk to my client and I will say, hey, make this kind of an animation, render it on Blender, right? The name of the YouTube channel is this, Visual Learning. It's an amazing channel. I don't know how much utility this will have for you guys, but this is mostly for folks studying in like 10th grade, 12th grade, etc. It's a nice channel. Anyways, so now coming back to what we do here. So here, let me switch to the... So can you currently see this Blender agent, or are you seeing some other screen? Are you seeing this Blender agent VS Studio VS Code? Okay. Now let's do something. I have already set up the connection. Setting up the connection part is easy between Blender and your client. That Cloud Code will take care of itself, right? You don't have to do something special or anything, but basically this is how it works. First, let me check if the connection with MCP server is still live. So this is only connected, this client is only connected to Blender MCP. It's not connected to any other. Now we will say, okay, let me clear all the context and let me say something like this. I want to make a new scene rendered as a 5-second video using EV instead of cycles. This is just a rendering format. EV gives cycles is very realistic but very slow. EV is less realistic but it's very fast. You don't have to know about that. I want the rendering to happen in 2 minutes. So select the resolution accordingly. And then here is the description of my scene. I want to make an animated scene that shows, let's say something like, can you tell me any science experiment which won't take too much time to render, something that is neither too complex nor too simple? There are many concepts, eddy current, but something which you prefer, anything. Okay, refraction, running on, just jumping on moon, photosynthesis, atom molecule. Okay, atom molecule sounds very much doable. Refraction, the only issue I know is if you render something that looks transparent or something like that with a different medium, it will look a little bit weird with EV rendering. Then we need cycles rendering, but cycles rendering will take a lot of time. Okay, simple harmonic motion, I really like. That shows simple harmonic motion using, let's say it's not a pure spring mass, it's a spring mass damper also is there, spring mass damper system. Make sure that the lighting is a little bright but not overexposed. Also make sure that the camera is pointed at the experimental setup. All right, so just this is a very basic thing. Ideally what we should do is, so we have still not yet created a single Blender animation for our YouTube channel, but this idea occurred to us only like this week or last week, and our team is experimenting. How much can we teach Cloud Code to learn the patterns of our previous Blender renderings? Because all we can do is we can provide the previous Blender files to Cloud Code and ask it to create markdown files like skill.md files, which will summarize our general Blender skills, right? Our team's skills. Like this is the way in which we do the lighting. This is the way in which we define the objects. And when we define constraints between the objects, this is how we define. So it can create enough skill.md files to kind of capture our style of making. And then ideally, I can give very little number of experiments to sort of, a very little number of um, sort of instructions to create something in our own style, right? So it's a very interesting tool. And, we even recently tried this with CAD. So there are a lot of CAD softwares where people are designing actual machinery, right? And those companies, the thing is, those companies are still, the companies who use CAD is still running years behind. I mean, they are not running with the latest AI tools in their arsenal or something like that. So there is a lot of scope for disruption just by introducing um, these tools to such companies, or even helping them set up such workflow. One more thing is, I was recently having a like this was 3-4 weeks back, having a meeting with a company. What they are trying to do is they're trying to create you might have seen these companies where there are 3D renders of any house. So if you're trying to buy a house or rent a house, many platform provides you 3D renderings through which you can you can do a walkthrough. So it's actually a difficult problem because there are more houses and more apartments for which such a 3D render does not even exist from camera photos. But you could imagine creating a workflow where you go to an apartment, and from the apartment you can click large number of photos in different angles, or you can even take a 360-degree camera, and then you can have a setup where all your preferences of how 3D modeling should be done using whatever software you use is mentioned to the Cloud Code. And then that software, you can make the connection to the software using its MCP server. So literally, if you think about the industries that are being disrupted right now because of this kind of workflow, is so huge. It's just that some of those companies will take time to realize that things are changing at such a fast rate, including us. I mean, we were like blown. I did not know last year when we checked something like this for Blender, output was not at all good. Like what it was doing was, I mean, you could write Python code and then that code you could import to Blender, and that code will render something on Blender. It's not very what do you say? Uh, it's not possible to make complex renderings using that. But this time it was very mind blowing. I'll show you some sample outputs if I can find it over somewhere here. But what I'm trying to say is most of the modern tools, right? They have its own MCP server. I will show you one uh, GitHub repo. Okay, there is a question. What are being communicated between the Cloud Code and MCP server? Basically, Cloud Code is communicating to the MCP server its function call. So if the function call involves creating a square-shaped object of certain dimension, let's say the dimension and its XYZ position are the arguments. The function, that particular function call is being passed, and then the Blender tool will execute it, the tool which is meant for creation of the object. So at the end of the day, whether you are implementing this scene, see, the scene is getting created as we speak. It's amazing. It's not easy. So the spring mass damper system is here. It's not easy for a human to do this. It's very, very time consuming. And this is with our very primitive prompt. We have not followed any standards. Like our prompt is like very, very basic right now. But now imagine what you could accomplish if the prompt was detailed, if all your preferences are stored, and this will also be animated. I'll show you once the render is complete. Um, it's completely disrupting every industry. So one thing you should try is, I don't know how much your company, wherever you're working, allows you to use different tools. But my opinion is, I have tried many different AI coding agents. Cloud Code and Codex are above the one league above every other thing which you can use. So if your company is not allowing you to use it for whatever reason, security or whatever, at least in your personal capacity for something which you want to build yourself, you should use it. It's otherwise it's a big loss in my opinion. Um, this GitHub repo actually has a lot of different MCP servers for many different purposes. So you can scroll down here. There are many interesting MCP servers people have created, and you can deploy it yourself also, or it is already deployed for various tools, as well as for various various famous softwares, as well as for other random tools. So just check this. This has 89K stars. There was actually one more GitHub repo for MCP servers, which I don't have. I don't remember on top of my mind, but I'll show you. But anyways, let's check if what happened to our rendering. There is a play button here. So you see this right now. I'm playing this on Blender. It is showing the spring mass damper system, right? You should know how difficult this is to make in Blender, something like this. It's for somebody who's a beginner or even someone who knows this Blender in and out. It's not like it's not a child's play to put these objects, and some people have very poor 3D visualization skills also. It's and to animate these things, to define constraints between different objects, because now this square has to move, this cube has to move along with the spring as the spring is getting compressed. So there is a question, can Blender generate videos as well? Yes. So that is what I'm going to show you. So this animation that is being played will be stored as a video. I have asked Cloud Code to render it as a video. You can render an image, which will obviously be faster. This video will be like a 10 or 5 second video. My computer is a little bit slow right now because of the rendering, but I'll show you. Now think about softwares which are used in traditional industry. Maybe like a logistics handling software in hospitals, or in some softwares used in big company inventories. The problem is that if those softwares are internal softwares, somebody has to create the MCP server if people need to use LLM along with it, if they want to use LLM along with it, right? And somehow, yeah, our company is blocking to use MCP due to security. Is the MCP the only way to do? Can we have our own way to do MCP using function or tool calling? MCP is the best way to expose a tool to an LLM. But the thing is, you don't have to host the MCP server anywhere in a publicly accessible way or something, right? It can be purely internal. And if you are worried that your MCP tool may erase some data in your data set, so I had recently created an MCP server for modifying some content on our own website. Our website backend is in Firebase. And usually we have to go through the front end of the website and make some modifications. Let me just, my screen is frozen actually. Let me stop sharing my screen. Can you hear me all right at least? Or is my screen is a bit frozen? I think this render is taking time. Okay, but you can hear me all right without break, right? Okay, okay, thanks. So I'll just continue speaking. Let the screen come back to normal once the render is complete. But what I'm saying is, one of the issues that I had was if I create tools for editing, let's say a course or deleting a course, and then let's say that tool is MCP server is exposing that tool to my MCP client. What if I accidentally say something and then that thing deletes an entire database or something like that? So I was worried about that. So then what I did was I defined the MCP server such that the functions for deleting or editing are having much more guardrails. So that guardrails are on the client side. Before the client even produces the instruction to delete or edit, there is a triple check I have added. So me as a user, I have to confirm 3 times before something like that is sent to the server. That is one option. Another option is eliminating that altogether, eliminating the ability of the MCP server to make deletions altogether. I'm not able to actually even switch off my camera because my screen is entirely frozen. Let me just give me a moment, guys. Let me close Blender. Anyways, this is the problem with using Blender while you're doing a bunch of other things. One more thing you can do is you can install Blender on a remote server like EC2 or something. The same thing you can do on that so that your local computer is not getting, you know, hung up. But yeah. Actually, let me kill this process. You don't have to see the video to believe me, right? I'll show you some other videos, but this is fairly straightforward. The point being is, I think there is a good money making opportunity in different industries if something like that interests you. One thing you could do is like find industries that are still relying on softwares and those softwares which is like a real big pain point for its users. It need not be customer facing software or anything. It can literally be softwares for internal purposes. It can be softwares which are for managing inventory or sorry, managing invoices on say using Salesforce, or it can be any other tool which causes a pain to a large industry, to a large number of internal users. And now see where you can produce disruption, introducing some sort of system where you have an MCP server and client setup. So it's like it's truly, the thing is, people who are so used to the software sometimes will not agree. That they'll say, hey, this issue is there, that issue is there. Of course there are issues, it's there is no doubt about it. But the thing is, the world is moving in a direction where um, people are embracing AI more and more. There are even terms like AI native. I don't know what it even means, but people keep on saying that from different companies when they have meeting with us. We want to become AI native team. But whatever it is, they want to build internal tools which also has AI capability so that you can interact with it in natural language, just like how I interacted with Blender in natural language. Can this produce an output as good as a 5-year experienced Blender professional guy? Maybe not, but that is not the point, right? In future, it can. It depends on how you set up the client. But the server is perfect in the sense that the server is having perfect access to every single functions that Blender has to offer, just like how the Blender UI is offering you functions with mouse button clicks or with keyboard presses. Just like that, the MCP server is perfect. Now the question is, you as an AI engineer, can you design a perfect MCP client which can interact with the server and get something which is truly valuable? I think that is where a lot of skill is in these days, and there is a lot of opportunity to disrupt many industries in this way. I mean, this is just one example. um, okay, then I want to show you one more thing. That is the idea of just-in-time instructions. Let me first close my cloud code. It's slowing down a lot. Just give me a second, guys. I'll just close every single thing and make sure that my system is not slowed down. Oh, the reason why it was slowing down was because this animation was playing, because it has to render frame after frame in Blender. So that takes a lot of CPU. That was I forgot to pause the animation. I should have just paused it. All right. Anyways, now let's come back to the session notes. So this is the basic architecture. MCP client will be desktop or web app, or I mean cloud desktop or cloud code or web app, and it can access the server. Communication will happen in JSON format, the basic communication, but through STDI or HTTP protocol. And then server will have access to a bunch of tools. Those tools will execute the task, and then the results are again sent back to the client. There is one idea which I skipped earlier, which is this just-in-time instructions. So just-in-time instruction, the idea behind this is, I think Anthropic only pioneered this. Anthropic or Shopify, I forgot the company. But basically what they said is, if a tool has instruction associated with it about, okay, once this tool is, once you have the results from this tool, this is how you can utilize the instructions from the tool. Let's say you have such a description about the expected tool results, and let's say those descriptions are quite big. Usually what you do is those descriptions are all written along with the rest of the tool descriptions. If you have 50 or 100 tools, your system prompt will become massive, because all those tool descriptions you are loading into your system prompt, and because of this you will have context rot, right? But the approach in just-in-time instructions is, if there are things you have to take care of, once you have the tool results, you don't write those things in the system prompt. Instead, you let the MCP server itself return something called as JIT instructions, just-in-time instructions, which will be an additional field among your results. So the rest of the things will be results, okay? And then there will be JIT instructions. And then, this is two-way also, by the way, that there could be JIT instructions which are passed along with the tool call to the server, okay? To the when the LLM is producing the call, and server may have an LLM, or server may have a inbuilt robust logic which is not LLM based but which is keyword based. So the server can refer to the just-in-time instructions, and based on the just-in-time instruction, which will be deterministic, server can decide what to do with the tool results before passing the tool results to the client. That is one thing, so that the tool results that are passed to the client will be much smaller. And then the client can have a much cleaner thing to pass to the LLM. And in the opposite way, when when the server is deciding to pass a particular result to the client, it can add deterministic JIT instructions. The reason why I say deterministic is there is no need of an LLM logic there. This instruction can be purely added using an enumerated list. Yeah, can you give some concrete example point how MCP server will provide just-in-time instructions? For sure. So this is client, and this is server. Okay. Now JIT instruction is just-in-time instruction, which will help us. The only role of that is only goal of that is to save the context window of the LLM. we don't want the context window to be polluted with a lot of unnecessary tool instructions. If there are 50 or 100 tools, we are not the server is not going to use all those tools at once. Even if it's using multiple tools, the instructions only corresponding to the most important tools of that moment need to be exposed to the LLM. Now, who is doing this? Client is doing this. So client decides what goes into the LLM. But then LLM is creating a tool call, right, in a structured format. This will make a tool call in a structured format. So there is one way in which you can add a JIT just-in-time instruction. The LLM can decide to add a just-in-time instruction in a specific format, which will tell the server that when the server is returning the results, and let's say there are 10 tools that are being called right now. And let's say one of the each tool is returning 50 values each. Okay. So there will be 10 times 50. By default, there will be 500 items or values that are returned from server to the client. Now, when client is getting this much, the client is also having to have some logic before deciding out of these 500 values, what all things should I pass back to the LLM, right? So instead, what we can do is the just-in-time instruction created by the LLM during the tool call can be simply, hey, when you are creating the results, just give me instructions, give me the result regarding, let's say, parameter A and parameter B. And the way this JIT is constructed will be in such a way that it is something that the server also can understand, right? This will not be in natural language. I mean, it will look like it is natural language, but this definition will already be there in the server side. Then instead of the server returning 500 values from this 10 tools, maybe it will return 10 multiplied by 2, 20 values. And when these 20 items are now being passed into the client has a much easier time filling the context of the LLM. Otherwise, client has to implement some other logic to decide out of these 500, what are the most relevant things to be fed into the context right now. One more thing that is often done is on the server side itself. Let's say this is the result that are passed from the server. There could be just-in-time instructions which are embedded in the results which are passed into the client, which will say how to interpret this particular set of results. So let's say in the results, there are 500 parameters. Okay. And just-in-time instruction says, if you care about only 99% accuracy, consider only the first 3 params. Then this makes it very easy for the client to decide, okay, only first 3 params are decided, then it can truncate and feed the result to the LLM, right? So this just-in-time instruction helps at the end of the day in reducing the LLM's context window size. Not the context window limit, but the tokens that fill the context window. There is a question, client could initiate tool call with LLM. Client cannot, can you repeat the question? Client can initiate tool call with the LLM. I mean, LLM decides who creates the just-in-time instructions. On this side, LLM creates the JIT instructions. LLM can add it on along with the tool call structure. On the server side, JIT could be embedded in the result in a deterministic way. There could be JIT instructions which are, let's say, there are if based on if else condition. If this is the case, JIT is this. Else if it is case B, JIT is this. Like, for example, if there are 500 responses coming from the tool, JIT should be only top 3 are relevant. If only 10 are coming, only everything can be relevant. All 10 can be relevant. Then who instruct LLM to use JIT? That is part of the instructions provided to the LLM by the client, depending on how the client is set up. So it's up to Cloud Code, right? If we say that we want to follow a schematic where just-in-time instructions are used rather than utilizing the instructions about every single tool available, we can do this. So one more thing is, if there are 100 tools to the LLM, you typically don't have to should not be dealing with 100 tools, right? So yes, JIT basically is a dynamic thing which is added depending on the total number of tools that are needed to be considered. If only 5 to 10 tools are need to be considered, it's not a problem to add the descriptions of the entire tools operation and how the result structure may look like. You can add all of those things to the things into the LLM context, because the total number of tokens this may consume could be between 500 to 1000 or something like that, which is kind of okay. But if the size of the context window or number of tokens is humongous, like 5K to 10K, because of large number of descriptions of 100 to 200 tools, in that case, you will decide out of these 100 to 200 tools, whether we need only 5 tools or 10 tools or a group of tools. To give you an example, in Slack, there are tools that are related to channels. There are tools that are related to messages. There are tools that are related to users. There are tools that are related to pure admin related things, or like making people admin, or removing members, or adding members, etc. Within each of these group of tools, there could be 100 different functionalities which are different functions. For example, within a channel, there are many things, right? You can rename the channel. You can maybe change the channel ID. I don't know if it is possible. I'm just making it up. You can copy the channel ID. You can invite a user to the channel. Now think about this. If you have a group name for the list of tools in the tool description, channels, users, then let's say admin. If the current task that the LLM is talking about in the context has something to do with sending message in a channel and nothing to do with DMing a user or something like that, then the only tools that the LLM needs to ask client to execute in the server is channel related tools. And maybe there are only 5 tools in this group of channel related tools. In the users, maybe there are 15 tools. In the admin, there are 25 tools. Like that, maybe there are 3000 functions which the Slack has. Now, and with these 3000 functions, you should not be loading all of the descriptions of these functions into the LLM's context. Now, how will the LLM decide whether I should load this group, or I should load the users, or I should load the admin? One of the way to do that is by following the just-in-time instructions coming from the last tool result from the server. Then LLM will know what the context of the current tool result is. If the user has been added to a particular channel and a new welcome message has to be sent to the channel, then the LLM can switch the focus from the group of functions called users to group of functions called channels. Then if a welcome message has been sent, then maybe if the LLM has to now notify the admin with some email or whatever, then the LLM can switch its context from this group of functions in the channels to this group of functions in the admin, right? Basically, it's a way to save the context window. The good thing is, in cloud code and modern coding agents, most of these things are taken care of automatically, in the sense that its ability to manage context window is so good already. We will not be implementing JIT in code right away, because that will be extremely time consuming. I want to show you one activity actually. Let's go through that. I will share a link with you. So can you open this link? So this is an activity which will show you in a concrete way what are the schematics of different tools. Okay. Yeah, so resources and prompts. So resources are the documents that we will come to that actually here. The resources are basically the documents that that can be communicated between the server and the client. For example, if there are tool descriptions tool descriptions provided from server to client, and there are, let's say, 500 tool descriptions, these tool descriptions can probably be stored in a document, right, in some format, maybe in JSON format, in a structured document format on the client side. And then client can decide to run a RAG on those resources to feed only the top 5 tool descriptions into the LLM's context. So resources is a broader term saying it is not just tools that are there associated with the communication between LLM and the client and the server, because client and server normal communication is what? Normal communication is simply the tool result that is passed. But in the initial handshake, which will happen between the client and the server is passing a lot of information about all the tools it has at its disposal, right? So those things can be stored as a resource, which can be referred to later. If we come back to this example of getting the transcript, so let's say we are executing the transcript to summary in such a way that first the client gets the transcript from the server, then that transcript is stored as a resource, as a markdown document or something. And then from that resource, let's say you are suddenly now asking a question, find the paragraph related to discussion about RAG from this transcript. Then you can actually run a retrieval augmented generation using keyword search or using embeddings to find the relevant paragraph from that huge transcript, because a transcript of a 3-hour video will be long. But that resource which is stored on the client side can be utilized for feeding the information to the LLM. Now, where did this resource come from? Primarily, it came from the interaction that happened between client and server. Now, prompts are repeatable prompt system prompts, which you can use again and again and again. So in our case, the prompt that is used again and again and again is the button click. So when we click the button summarize, it is utilizing a particular prompt. If we click the button create lecture notes, it's again utilizing another system prompt, right? So when we say there are 3 primitives to the MCP, the 3 primitives are the tools, resources, and prompts. It simply means that there are a bunch of tools or functions that are defined on the server side, which the client can access. There are a bunch of documents which may be exchanged as part of their communication, which can be utilized later as a resource. There are several functions that the LLM can execute through client to the server by repeating the system prompt with a button click or something like that. So the resources and prompts are stored on server side or client side. In the current example, it is stored on, it is ideally stored on client side. The repeated prompts are at the end of the day passed to the client. However, in the way we have implemented it, if you remember, LLM was on the server side, which means prompts are on the server side. And the resource, which is the transcript, was passed from the client server to the client. And that transcript we did not store anywhere, because we were using the same transcript to we were calling the transcript function again and again to get the summary or get the bullet points. But if we are storing it somewhere, it will be stored on the client side and not the server side. Let's actually go through this this function. There is a question: can the RAG can be wrapped in a tool call? That is a good question. I think so. So your question is, if there is a function, can a RAG be implemented within that function, right? That is essentially what you're asking, right? Yeah, I think so. I mean, at the end of the day, RAG has got not much to do with LLM, right? RAG is purely, you have a query, you have a bunch of documents. Documents are in the form of vectors. Query you convert into a vector, and then whichever documents are closest to this query, you just fetch it. So it has got not much to do with LLM, which means it can be, yeah, for sure, it can be implemented as part of a tool or as part of a function. So RAG can be, tool can wrap around a RAG for sure. All right. Now let's open this document, and here I'll just keep the bright mode. Yeah. So here, basically what we are doing is, this is like a imaginary company. It's called Astrolog. It's a fictional space logistics startup. And then we are designing tool schemas. We are designing MCP server configuration, and and React agent loops. Okay, React I should explain once just before going ahead. So React simply means reasoning and acting. So this React framework was also popularized somewhere in the half of 2025. The basic idea is this. LLM will make a tool, will create a tool call structure. The tool call will happen. Tool will provide results, right? Um, then the LLM has these tool results as the observation. Then it can think on this. It can have a reasoning layer based on the results. We will see a solid example in 2 minutes. And then based on this reasoning, it can decide, oh, should I call another tool? So this is tool number 1, this is tool number 2. And this is result set 1, reasoning based on result set 1. Then this will say results 2. Then the LLM will again reason based on results 2. And then the LLM, after these results are there, then it can provide the user response, right? So the thought is the part where LLM will reason. Action is the part where a tool call structure is initiated. Observation is when the tool call results are injected into the LLM, and then the LLM can reason on top of the results. And then finally, in this loop, at one point, LLM will decide this loop can run 2 times or 3 times, and then only LLM will produce the final output which the user can see, right? So let's see this in a visual way. So right now, what this particular astrolog company does is it basically manages the logistics behind, let's say, space exploration, like a fictional thing, basically. And our goal is to design tool schemas. So tool schemas will be utilized for LLM, MCP server configuration, and React agent loops. And all are running on client side in the browser. Okay. Now, first is tool schema. There are two tool schemas. For mission search, there is a tool schema. And it's basically to get what are the ongoing missions or upcoming missions. Crew schedule is if there is a space crew who is traveling for those missions, what is their schedule? Cargo manifest is what is the cargo that is shipped into the space along with the mission. Fuel estimate is, okay, for this mission, for the current status, for current situation, what is the estimate of the fuel remaining? How much can this mission last? So let's first just compare the two schemas. One is a vague schema and one is a well-defined schema. I will not show you the well-defined schema yet. Just look at this vague schema and tell me what is vague about this. What's the issue with this kind of a schema? This is the schema of which describes that of a tool. Okay. Is there any issue in the name? So name is not in that snake case format we earlier discussed, right? It should be like get mission data or something like that. So in well defined, it will be like, this is a good name, search missions. Now in the vague schema, what is this description? This is the most lazy descriptions. Basically, this lazy thing is what we just did when we implemented Blender. But here in well-defined schema, the description of the tool will be search missions is the tool name. It will search the astrolog mission database by keywords, status, etc., and returns this so and so. And look at this thing. What is this queue? Properties, queue, string query. This is the worst schema ever. But actually, this property, it says, where is that? It's a query. Query type is string. Search keyword to match against the mission name, destination, or crew names. So basically, in a well-defined schema, one issue is there will be more tokens that are consumed, obviously. The number of tokens in this tool schema is maybe 1/3 or 1/4 that of the number of tokens consumed in this schema, or maybe half of it. But this is much more useful to the LLM. Now, same thing applies for crew schedule, cargo manifest, fuel estimate. I don't have to show you that. Another thing is this design principle. This we had already discussed. A good tool name should contain a format which looks like this: verb noun format. So search mission is search is the verb, missions is the noun. Okay. Then there should be clear description about what we are supposed to do with this tool. So if the tool is to get missions, it should not just say get missions, gets missions. It should explain in a little bit of detail what the details of what goes into the tool. And what comes out of the tool. It returns matching mission with status, crew, and destination used when the user asks about mission, launches, or destination. All right. Then enumerating constraints is if we want the LLM to consider only certain string values. Instead of just saying, let's say the status of the mission, let's say that is the variable. The status can be planned, in transit, completed, delayed, aborted. Technically, yes, all these are strings. And but the problem is if we just say bad, if we just say type, it's a string type. This is very bad because yes, it is true that this is string type, but there are only so many types of mission statuses. It's not infinite. So LLM, the opportunity for the LLM to hallucinate is minimized when you enumerate the available the string inputs. Then second, the next thing is required versus optional. So sometimes some tool calls will not require all the different arguments, right? Some arguments are already inbuilt. One example is if we are using calling an LLM, or if you are running, if you are building the, let's say, backbone of an LLM, one argument could be how many layers this LLM has. Sometimes the number of layers will be by default decided as 6 layers or 12 layers, which means it is okay if you can skip that parameter. So it is very important to say what parameters are mandatorily required and what are optional. Because if you mark everything as required, you are forcing your LLM to come up with some values to this required field, which will again force the LLM to hallucinate. So just mark whatever parameters are required to be passed into the tool, mark that as required. Whichever is actually optional, mark those as optional. Then return descriptions is it documents what the tool returns so that LLM knows how to interpret and present the results. So this returns is basically showing what this tool or function will return. It will return the list of missions as an array. Inside the array, there will be ID of the mission, name of the mission, where the destination is, status, current status, launch date, the crew who went on the mission, etc. In the bad case, this description of the output format was not described. Then low parameter count, keep parameters under 5, combine related fields into objects or use sensible defaults. More parameter equal to more chances for LLM to make error. This is in tandem with what we discuss here. Here also we are constraining the options that LLM will have to choose from, whereas here we are leaving it open. Then another principle is this just-in-time instruction, and here is an actual example of just-in-time instruction. So let's say the function that you are calling is calculate fuel estimate. And this function will return an output in a JSON format, something like this. Fuel kilogram is 52,500. The cost of this fuel in USD is so much. The safety margin is so much. Now, when before this tool result is being passed into the client, you can add an instruction. I mean, the server can add an instruction saying JIT instructions. Important when presenting fuel estimates, always note that 15% safety margin is already included. If fuel greater than 50,000, one that this requires a heavy lift vehicle, present cost in millions. Example, $2.6 million, not like this. Suggest checking weather at the launch site. So basically, this is the JIT instruction that is coming along with the this particular tool result. And this will, in the downstream, save a lot of, I mean, not this particular example. What I'm saying is, in general, JIT instructions will save a lot of the tokens. Same for, this is another example for a different tool. This is a get weather forecast tool. It will return the weather at a certain location. What is the condition? What's the wind speed? Whether it is safe to launch or not. And then the associated JIT instruction, if the result is JIT enhanced result. Right. So this is just to show you one example of how the just-in-time instruction is actually added into the result. How is it injected along with the result? One more thing we can see is, so this is the whole pipeline. You describe what the tools have. We saw this in the JSON format. LLM decides what tools to call, whether it is get fuel estimate or get the weather report, right? And then after decision, LLM will call. And then after the call, the tool will return the JSON format return. And then if there is a React loop, LLM can reason on top of that result, which I will show you in a moment. Now let's move on to the this part. So this is how the rough MCP architecture looks like. This we have discussed in detail. Even if you skip this is okay. But basically there is a host. there is a client that the host talks with. So in our case, the host is the web app. The client is basically on the web app itself. Client connects with the server, and the server is in Railway. And then communication happens between client and server. And let's look at this server builder. Okay, so I will first just do one thing. First, remove all of this. And let's do one more thing. So just look at how the three primitives for the MCP server looks like. So the three primitives are tools, associated resources, associated prompt. So let's say the tool is search mission. We are only caring about searching for missions. Then that will be added into the JSON, which is communicated between the server and the client. And then in the resources, we can add the resources related to the missions. It could be a log from the astrolog, which is a document that enlists the missions active or not. And then there could be a crew schedule associated with the mission. And then in the prompt, there could be like a already defined prompt. Here, the definition of what this mission brief is not mentioned, but the system prompt could be, here are the mission details. Here is the resource document. Based on this, create a 2-sentence or 3-sentence brief of the mission, right? And this is how the final JSON format will look like, in which all the three primitives are embedded: prompts, resources, and tools. And this is the initial handshake, what is shown here. Initial handshake, if you just click this play button, you can see client will ask the MCP server to initialize. MCP server will respond with its own capabilities, tools, and resources support. And then once this is received on the server side, the connection is active, connection is complete, meaning now the client is ready to interact with the server to execute tools. And transport is, this is how there is one more thing I want to show here. Tool call flow. So tool call flow look like this. Client will ask for a list of tools. Server will respond with the list of tools. Client will call a specific tool or specific set of tools. Server will execute the tools and return the results. Fairly straightforward. And this we have already discussed. STDIO is the standard input-output protocol. I don't think it's a protocol. It is the way in which the communication happens between server and client, especially when they are running on the same machine. HTTP or SSE or even socket, WebSocket happens when there is a network in between. And let's also see this React loop. I just want to show you how the actual thought, reason, action loop looks like. So let's say this is the question: what missions are currently in transit? Okay. And let's just run the step. So the thought the LLM has is the user wants to know about the missions currently in transit. I should search for missions with status as in transit, not status as delayed or not status as aborted or something. Then based on this thought, so this thought is basically the reasoning part of the LLM. The action that is taken is call the function search missions, and the query that is passed is the argument that is passed is query should be in transit, status should be in transit. Then after this action, you will get some results. So where is this results coming from, by the way? Where is this coming from? It's coming from the server, right? MCP server will have these results which are passed into the MCP client, and LLM will get access to that. And based on this observation, there will be another thought. I found one mission out of all the missions. It found there is one mission in transit, Mars Pathfinder Relay. I have all the details I need to answer the question and then show the answer. So the final answer which user gets after user, there was a thought part here, which is the reasoning. As part of it, there was an action. As part of it, there was an observation. Then that resulted in another thought or reasoning. And then finally, you have the answer. Then this is the most basic part. But if there is multi-step, the LLM can do this more number of times. So let's say this is the question: can we launch ISS resupply Delta on March 10th? Check whether the cargo, check the weather and cargo weight, then estimate fuel. So first, the thought is user wants to know if M003 can launch on March 10th. I need to check the weather. I need to get the cargo manifest to calculate total waste and estimate fuel. Then Tool will decide first, okay, first get weather forecast, weather forecast for Cape Canaveral, and this is the date, March 10th. Then observation is you get this thing. This is the observation, partly cloudy, wind speed is so much. Then the thought is, okay, weather is good, so launching is safe. Because if launching is not safe, you don't even have to call the next function, right? So if the weather forecast is very bad, you don't even have to call the get cargo function or the estimate fuel function. So weather is good, launch is safe. Now I need to check the get the cargo manifest. Then the action will be check cargo manifest function. So this function is now called. This function will return the next observation. The observation is for the current mission ID that we are discussing. What is the cargo status? Then the thought is cargo's total is 435 kilogram. Now I can calculate fuel estimate for this particular payload. Then the next action is for this cargo, for this particular mission. So the destination is to the International Space Station. What is the expected fuel consumption? Then the next step is, as a result of this action, there is this observation, which is the result coming from the MCP server. And then on this result from the MCP server, there will be a reasoning loop. And then at the end of this reasoning, it will say, okay, mission is safe. I can go ahead. The fuel estimate is cargo size is 435 kilogram weight. Fuel estimate is this many kilograms, $100,000. So this is how after 3 loops, right? So first loop, first thought action observation loop was this. Reason action observation was this. Second was this, these 3. And third was this. And only then it ended up with the final answer. Sometimes it can, for this React loop to implement, we need to call reasoning models, or regular LLM models will work. I think for this, we'll have to use reasoning model with its capability. Otherwise, the regular models will keep on giving you its output, right? It should have an internal reasoning capability. Otherwise, it will keep on relaying its output to the user. There is another one, update the Venus atmosphere probe mission to completed status. So here the thing is, if it's an aborted mission, it should not be changed to completed status. So user is asking something that is impossible, not impossible, that is something that should not be done. So the thought is, in the React loop, the thought is the user wants to update the mission status. Okay, first let me find the mission ID. Then the action is search missions. Then observation will be all the missions are available. The ID is available from the particular mission name. And then I will try to update it to be completed. Then it should write a function, update the mission status, and mission ID is provided, status equal to completed. But then success is false. Error, invalid status transition, cannot move the status from aborted to completed. Always allow transition from aborted is none. So basically aborted mission status cannot be changed. So this is now the observation. Basically it's an error. After this, there is nothing. So the thought is, the update failed because aborted is a terminal state. You cannot transition from aborted to completed. So cannot update M008. Status transition from aborted to completed is not allowed, and aborted mission cannot be marked as completed. So basically the agent can go through different scenarios and reason and tell the user what to do. Now look at the token consumption. Obviously, the downside of React is token consumption is high, but then in mission critical applications, it will be very good to have a React loop. In fact, in many cases, how many of you have used Paper Banana for making figures? Have you heard of Paper Banana tool? I think I had mentioned it in the first lecture or something. Basically, it's an amazing tool. It's an amazing tool to create figures using Nano Banana. But however, Paper Banana itself came out as a paper, by the way. So this is the paper. This is from Google. I think it's from Google DeepMind, if I'm not wrong. Okay, not sure DeepMind, but Google Cloud AI Research. But this paper, what they did is they did not build a new model, but they built an agentic framework around Nano Banana to create amazing quality figures. So just check this. So basically, this whole figure was created using Paper Banana itself. So this paper was written most of the part using Paper Banana. If you really want to try the implementation, I have made a banana.visuara.ai. You can just check this link. Here you will have to paste the description of your figure and just paste your API key. and then you can generate amazing figures. Just check this website. But what I'm trying to say is here also they have the same loop. There is a agent who will critique the initial iteration that is created. Then there is a thought process where what are the mistakes, what is the difference between what the user has asked and what the generated output is. And it will create three outputs. You see this iteration 1, iteration 2, iteration 3. And over each iterations, it will try to make the output better and better and better. And it's actually very mind blowing. You don't need actually this website to implement Paper Banana. If you have Cloud Code, just give the this Paper Banana GitHub LLM research. So just give this link. It's a public repo. Just give this link to Cloud Code, and Cloud Code will figure out how to invoke Paper Banana using pip install Paper Banana. So the instructions are given here, but you don't have to necessarily give this to Cloud Code directly. You can just refer to this GitHub. But basically the point is here also they have implemented something very similar to React Loop, where every single action that is done on Nano Banana is evaluated in the next loop, and then it iterates. And because of this, the token consumption is higher. It consumes maybe 3x or 5x more tokens than normal, but the output is significantly good. So, and then this custom query, I want to try this. Which missions are scheduled to happen in the next 3 months? I'm just running this. So here an LLM is being utilized. So I have given Gemini API key here. And the thought, so this is now the actual loop, right? So the thought is the user is asking for missions in the 3 months. So search mission tool is the most appropriate. Then the action is that tool is called observation is all the mission IDs are now available. And then the thought is I have received the list, and then we need to find whichever are from the next 3 months. So in the thought loop, it will see that these are from the within the 3 months. This is also from the within the 3 month. Okay, here one problem that has happened is I have defined the maximum token length so that my API, my Gemini API usage is minimized. That's the reason why the output is truncated. But otherwise, if I don't, keep the token limit, you will see the full output. So this is the React loop. One thing we can do is, can we come back to this quiz and let's go through the first 15 questions. We had skipped this in the beginning. So yeah, I will share the code base also to the, you mean the Vercel app as in the Vercel app for YouTube, this maker, right? YouTube transcript maker, right? I will share that, yeah. So let's do this. In the tool lifecycle pipeline, describe, decide, call, return, reason, which stage is most impacted by the schema? So think about where the impact is coming. Impact is coming in the LLM's decision, right? So LLM's decision is what? LLM's decision to invoke which tool. So this is the most impacted part of having a poor quality schema. Next is, which of these is the best tool name following function calling conventions? Obviously, the search mission, this is the convention. I don't see what's wrong with this one also, mission search, but it just so happened that sometimes there are certain conventions which emerge eventually. Right now, this is the convention. Maybe tomorrow it will change. Who knows? A tool schema has 8 parameters, all marked as required. What is the most likely problem this will cause? So basically, all the parameters we are saying all are required. None of them are optional. This we discussed earlier. So the problem is this, right? You are telling the LLM that, hey, you have to put something here. You can't leave it empty. This parameter cannot be left empty, which means you are forcing the LLM to come up with some parameter or something to insert. And this will, if you are forcing the LLM to do something, it will do something. And which means hallucination can happen, right? It's not that the tool may execute slower, because some default parameters might be already inbuilt in the tool, which means even if you don't pass it, the default parameter will be taken. So it's not about whether tool will run slow or not. Why should tool schemas use enum constraints for parameters like status, instead of free text strings. Same logic. If you are providing free text strings, you are allowing LLM a lot more window of exploration, in the sense that LLM can come up with any output. But if you say output is from one of these, you're forcing it to pick from one of those. It will pick from one of those. Enums prevent LLM from hallucinating invalid values. It will not say get mission status instead of failed and something like that. Mission status cannot be something like upcoming or something like that. So it will prevent LLM from coming up with random values. What are just-in-time instructions in the context of tool use? So we saw that the JIT instruction earlier was part of the tool's return value, right? And that will help the LLM figure out how to interpret and present the result. But JIT can also be in the other way. JIT can also be embedded in such a way that LLM can add it as part of the tool call also. So it is a guidance that is embedded. So somebody has mentioned lazy loading, a system prompt technique that lazy load tool descriptions only when the tool is about to be called. So the thing is, JIT comes, it is not to call the tool or something like that. It is to get the tool description. What are the required to the other JIT which we discussed, not the one from the results. If the JIT is part of the result, you are looking at how LLM can interpret this result so that the next action can be taken with least context consumption, right? It's not about it's not just about lazy loading. It's also about I'm not sure if lazy loading is the right term. Somebody had mentioned if B could be the answer. I'm not sure if this is the right way to interpret the just-in-time loading, a system prompt technique that lazy load tool descriptions only when the tool is about to be called. Because you need to know what tool to be called in the first place, right? To get the description. So JIT primarily allows for that. And then using RAG, you can get the description corresponding to the tool if the descriptions are stored elsewhere. Then you are designing a safety critical fuel estimation tool. Should you put safety instructions in the tool schema description or as JIT instructions in the return value? Where should it's a safety critical fuel estimation tool. So fuel estimate should never be wrong. So where do you put these instructions, JIT instructions? So you can put it in both. The reason is, let's say the fuel value is low. Corresponding to that low return value, there will be some JIT instruction which comes as part of a if ladder. So you can have, if the fuel value is less than this much, put this as the JIT instruction. If fuel value is greater than this much, put this as the JIT instruction. Else, if fuel value is so much, put this, right? So JIT instruction can be added in the tool results using a deterministic if ladder. Plus, you can add some in the tool schema description, you can add some guidance about if the value happens to be less than this, delay the mission until the fuel issue is resolved or something like that. That you can add. So the answer is both if it's a safety critical application. In the React, which is reason plus act pattern, what is the purpose of explicit thought step before each action? So basic idea is this: LLM needs to improve its own context to decide what tool to call next. So when you add a thought part, explicit thought part in the React steps, what happens is you're essentially consuming a bit more number of tokens, right? You are saying you're forcing the LLM to think. And as a result of that thought, some tokens are being generated. Those tokens are added to the context window. And that the total set of tokens are now added back into the LLM to decide the action. So what has happened as a result of thought is the LLM has produced an output based on the tool result or based on the observation. And then LLM now have a broader context to decide what action to take next. So it, on one hand, it consumes more tokens, but on the other hand, the tokens that are generated as a result of the thought is of extremely high value. So those valuable tokens are now added into the context before deciding what action to take next, right? So it forces the model to reason about what tool to call. Then another one, a weather tool returns launch safe is false. JIT instructions is critical. Do not suggest waiting for weather to clear. Policy requires 48-hour clear forecast. Meaning, if the launch safety is false due to weather issue or something, you need 48-hour clear forecast. So that is the JIT instruction, just-in-time instruction. An agent without thought, without the thought step in the process, will say the weather is bad, but you could try again in a few hours. So in this case, what has went wrong? So the question is, JIT instruction clearly says, like, look at our own reasoning. Our reasoning is when we see this JIT instruction, it clearly says you need a 48-hour forecast, clear forecast to even decide whether you should launch. It's not like whether currently the bad weather is bad, you again check whether you can immediately launch. It's not like that, right? So this JIT instruction is clear. So, but then why did LLM not get that clarity? It did not get the clarity because as soon as it received this launch safe is false, it thought, okay, it is not safe to launch right now, which means weather is bad, so you could try again in few hours. But that is because of the absence of thought step. If there was thought step, it would have reasoned that, oh, the JIT instruction says that you need a clear 48-hour forecast. So you need to first look at the weather forecast now, if such a tool exists. And then if that tool is giving us a response that till the next 36 hours weather is not good, but after that you have a window of 96 hours of clear forecast, so maybe we can check again after 36 hours, something like that. Then it would ideally make another tool call before giving the user this response, right? So what has happened is the agent skipped explicit reasoning and didn't process the JIT constraint before generating the output for the user. Another one is an agent tries to update a mission from aborted to completed. This we saw this example, and receives an error, invalid status, invalid status transition. Aborted is a terminal state. What should the agent do next? So now this is the observation, right? This is the observation. After this observation, because it is a terminal state, there is no other action to be performed. The only thing is you reason based on the observation, and then based on that, you provide the user an output, or you say what the user should be understood. Like you should understand that aborted mission cannot be changed in status. Then a few questions about MCP, just 6 more questions. In the MCP, what are the 3 primitives? This we have already discussed: tool, resources, and prompts. Very easy. Then in MCP, who decides when to invoke a tool versus when to include a resource? I don't think we have discussed this. When to invoke a tool is decided by whom? Is it the client, or is it just the when? You can answer instead of ABCD. You can just answer who is deciding when to invoke a tool. It's the LLM, right? So LLM. See, think about this. When we were building a 3D model in Blender, the only instruction that I gave is make a spring mass damper. Now the LLM has to decide, should I put a spring first, or should I put this thing, add color to the spring? Should I add a camera? Should I add lighting? Right? So these are all different tool calls. We did not explicitly say that, right? Cloud Code also cannot say that. Cloud Code is not the brain. The brain is ultimately the LLM. Now think about this. The order of the tool call is very, very important. The order in which tools are called will decide the final output. And who decides this order? LLM decides the order. It's not the client. Which tools should LLM know about? That is decided by the client. So here model decides when to call tools. The client application decides when to include the resources. The resources and where are these resources included, by the way? Where are the resources included? Client is the one who is including it, but to where? The resources are finally, at the end of the day, it's loaded to the LLM's context, right? Part of the resource or full resource. So the client can decide, hey, I need to implement a keyword-based RAG to fetch the appropriate subsections from the, let's say, cloud.md file, or let's say from a JSON file, to include it in my context, right? So client decides that before it is passed into the LLM's context. Then based on all of that, LLM will decide, here is my current context, and based on this, these are the tools that I need to call in this order. All right. Next, what transport does MCP use when a server runs as local subprocess, similar to Cloud Code controlling the this Blender? It will be stdio. Then during MCP initialization, the client sends an initialize request. The server responds with capabilities, and the client sends notification/initialized. Why is this three-step handshake necessary? Meaning, why should why should the client first initialize, then the server responds, and then client sending this notification/initialize? Why is this three-step needed? And this is called as the initial client server handshake. The reason why this handshake is needed is because if this is not there, LLM has no idea what all tools are existing on Blender. So my Opus 4.6 has no idea what tools exist on Blender. Maybe some new tools are added. So the initial handshake between my Cloud Code and Blender has to happen, so that then the Cloud Code can tell, hey, here are the tools and descriptions that the Blender has in a token efficient way. So basically, it lets both sides know. It lets the server know that this client is communicating. It lets the client know that from the server side, you will have access to these tools. An MCP server exposes 15 tools, each with detailed descriptions. What is the main risk of having too many tools? The risk of having too many tools is these too many tools. If the client is not doing a good job of passing the tools in a good way to LLM, if with too many, actually here there is one, in my opinion, the question should be an MCP client exposes 15 tools from the server. That's the better way to word this. But at the end of the day, what will happen is LLM will get confused. So here we should say something is exposing 15 tools to the LLM. Basically, MCP client exposes 15 tools to the LLM with a detailed description. Where is MCP client getting information about the tools from? It is from MCP server. So ultimately, it is coming from the MCP server only. But the better wording of this question would have been, an MCP client exposes all the 15 tools it got from the MCP server with detailed description. The risk is model will get confused due to context rot. Then this is the last question. In a React race, an agent chains get weather forecast. Following that, check the cargo. Following that, get the fuel estimate. Each tool result is adding tokens. Why does tracking cumulative token consumption matter? Same thing, basically. This, as I showed you, see, even my result got truncated earlier. So you could exceed the context window. Even if you are not exceeding the context window, your context may rot. So this is the issue. So this is the end of the quiz. Now I want to give you a homework. Okay, so now it is Thursday. You have 3 days to finish this. So homework will be, deadline will be on Sunday late night. So the homework will be about building a model context MCP server and client, hosting it yourself, and sharing the link where I can test the client. The application can be anything. I don't care what the application is about. It can be something simple to something complex. But I will provide a detailed description of this homework, which you can take a bit of time to work on Saturday. I will really appreciate it if I can already make, if you make it in such a way that it also allows for Gemini and OpenAI API key. You don't have to give the API key or something. I can use my own so that I can test this. So this exercise will, in this exercise, if you want to include RAG for whatever reason to contain the token consumption to a certain limit, you can add that. But my primary thing is, what I want to do is I want you to either implement your own MCP, or figure out, the secondary option is you figure out how to connect to an MCP server of an application which you use on a daily basis, okay, which is part of your job or something like that. And then record like a 5-minute video where you show how you connected the how you build the MCP client and how you connected the MCP client to the server. And with this, what are you accomplishing? Like, what task are you automating? The more value added this particular MCP server is, the better. You don't necessarily have to build the server. You can use existing servers others have built from internet, from GitHub or anywhere, doesn't matter. But show the utility of this application, show why this is so important, and also tell me in what industries can this cause some sort of disruption. All right. So this detailed homework description I will put in the assignment section as part of today's session. This is session 4, right? As part of session 4 material, and you will have 3 full days to work on it. All right. So we will next meet on Monday, same time. Tomorrow we don't have a lecture. One more update is that regarding the Thursday's build lecture, I will confirm the timing and the date, whether we need to take it on Thursday or whether the duration, because it will be a long lecture, should we keep it on weekend, that I will confirm sometime early next week. So we will meet again next week. You can post your discussions and everything on Discord, or you can even email me. But please don't forget about the assignment. I will post the assignment and I'll put a reminder on Discord. But I really hope you all will get some time to work on it. It will not take you more than something like this, let's say max to max 3 hours. So you can split it such that 1 hour each day. If you can spend on Friday, Saturday, Sunday, that will also be more than enough. Sometimes it won't be even costing you 3 hours. But just try this activity to build a very useful MCP server client framework where you think it can add tremendous value to some industry, right? Or to your own workflow. And you can share one of the two things. Either you can share a Loom video recording, these descriptions I'll post, or you can give me a link using which I can just test it out. All right. So thank you so much again for staying back in a long lecture. Have a good weekend. Saturday, Sunday. We will get back again on Monday. Quick question: does MCP result count part of output token? MCP result meaning does everything from the server, is that counted as part of the tokens? It is not, because client is ultimately deciding what goes into the LLM's tokens, right? So that is under the control of client. So thank you so much. Please build. This weekend is a build weekend. So I am really expecting something mind-blowing. I really hope I can find some gems among you who will build something and truly inspire me. If there is something which you build amazingly, we can even collaborate together after this bootcamp is over. So please put your heart and soul into it, and let's see what you can come up with. Anything does not matter. The complexity does not matter. But if the value proposition of what you are showing is something really interesting, we can figure out ways to collaborate. So thank you so much, everyone. Let's meet on Monday. And for whatever reason, if you need a little bit more time for this exercise, just drop me an email. I'll be happy to respond to you. Thank you so much. See you next week. Bye.